tables, those have been scheduled, and almost 175 those delegates from these 7 countries, that includes Japan, Korea, Taiwan, Singapore, US, Netherlands, and Sweden. Those have traveled all the way to join and share their insights and views and create the business opportunities, which is a win-win for both the countries. In addition, during the grand inaugural session, we will have Honorable Chief Minister of Gujarat, and there are plenty of action-packed session considering multiple launches, multiple MOUs, the groundbreaking ceremony, and many things which I will keep it in the pocket right now. As we go along, you would hear about that. So all in all, this is going to be a very eventful event. And I'm really thankful to all the CXOs, CEOs, leaders, managers, all across the world, including our ISA member community, for joining in a big way to come over here, discuss the business opportunities, expand the ecosystem. And that's the most important thing, because traditionally India has been great on a design part of the semiconductors, while the manufacturing has been, we have been a bit late, or I would say we're far late there. And this is the time now for India to ramp up the manufacturing activity. And thanks to the initiatives and support from the central government led by Honorable PM, Mr. Modi, also Honorable Union Minister, Mr. Vaishnav, and multiple states, including most importantly, state of Gujarat, those are given incredible support and policy-making initiatives and acting as a catalyst for developing the manufacturing ecosystem in the state of Gujarat. And all of us, those who have come over here, are gathered here particularly with a single motto that we expand and accelerate this ecosystem of the semiconductors and electronics, which is the most complex thing in the world. And I'm sure these 3 days of the conference, the exhibition, would create much more business opportunity, more commitments from several players, joining hands with the local conglomerates or industries, or bring their own entities into the state of Gujarat and other parts of the country. Finally, India has to become a major player in the semiconductor manufacturing on a global scale. And with that, I would conclude my opening speech and welcome for all of you. Once again, thanks a lot. Have a great time. Just as a housekeeping, one information I want to share with you. Today's this morning session up to lunch is entire hall, and then we will have a partitions. The central hall will have Vision Summit related track. On the left-hand side, you will have the iSpec track. On the right-hand side, you have speaker lounge and other stuff. The international roundtables are done in a different room. The displays, signboards are there actually. So thank you very much. Thanks a lot, and have a great time.
Thank you so much, Mr. Chandak, for your inspiring address and for setting the perfect foundation for what promises to be a game-changing summit. Your leadership continues to propel our industry toward new heights. Now let's dive into our first visionary keynote. Imagine a world where semiconductors are not just components, but catalysts of intelligence, automation, and sustainability. Our next speaker is someone who has dedicated his career to pushing the boundaries of what semiconductors can achieve. I am delighted to welcome Dr. Madhur Bobde, Chief Technology Officer of Alpha and Omega Semiconductors. With his deep expertise in power semiconductors, system-level solutions, and next-generation technologies, Mr. Bobde has played a crucial role in driving efficiency and performance across industries. Ladies and gentlemen, please put your hands together for Dr. Madhur Bobde.
Oh, perfect.
Console, this will work for the slide changer, right? Give me a thumbs up. Okay.
Good morning, everyone. I would like to extend a very good morning to all the esteemed guests industry leaders, and distinguished colleagues. I'm truly honored to be here at the IASA Vision Summit 2025. We are here to discuss the future of semiconductor in India. This is a very important segment that decides the future, the economic growth, the technological advancement, and energy sustainability of India. I would also like to thank our partners, Kaynes Semicon, who have really helped us bring AOS to the table of this initiative. Particularly, I would like to thank Raghu sir and Ramesh sir for inviting AOS as well as giving me the opportunity to talk here. Thank you. While semiconductor industry is vast, power semiconductor presents unique opportunities, and these are very accessible in the short term for India. So that is going to be the main focus of my talk today. Well, you can see from this chart that, power semiconductor is everywhere. It is so pervasive yet so integral to our modern civilization. They power everything from these small personal home gadgets to big industrial machines. So it is very important to realize that power semiconductor is a very key element of the future of growth. As we stand on the brink of a new era marked by AI, EVs, and smart homes, sustainable energy, all of this is coming from the power semiconductor growth and development. It is the backbone for all these great revolutions. At the same time, this technology is also moving forward rapidly. I have been in this field for more than 20 years, 25 years, and I have seen humongous progress in the field of power semiconductor. I will touch upon some of those areas today. Well, I think this slide is more of preaching to the choir. It is very clear that developing a domestic supply chain is absolutely critical for the growth of semiconductor in India. I was looking at some of the projections, and the numbers are astonishing. The semiconductor consumption in India is projected to cross 100 billion in the next 5 to 7 years. If domestic production is not ramped up, this will be a huge burden for the country in order to support all the industries that use them. So it is absolutely critical to have semiconductor development here locally. In addition to reducing the imports, this will also bring huge advantages. We believe that building a local ecosystem of R&D, manufacturing, talented engineers, you get that going and the magic happens. Automatically, innovations will follow. The teams, the R&D teams, the manufacturing teams will figure out how to make optimized solution with best efficiencies that are suited for the local customers, our local customers. At the same time, they will figure out how to bring down the manufacturing costs once the economies of scale are achieved. However, it is very important to take that first step. Efficiency of power semiconductor is absolutely critical for all applications. And I will give a couple of examples where you can clearly see its impact. The first example is switching from a conventional ceiling fan to an efficient brushless DC motor ceiling fan using electronics control system. It consumes 65% lower power. And looking at the volumes of ceiling fans, that alone can have a humongous impact on the energy consumption in India. Switching from conventional ICE cars and two-wheelers to EV-based can have a huge impact on the emissions in the country. Not only that, even for two-wheelers that use ICE, using integrated starter and generator, using advanced electronics and power semiconductors, can bring huge efficiency boosts and lower emissions. I'm truly excited to see the progress and the initiatives in India. This is the first time I'm attending this conference, and it is really astonishing to see the initiatives, the support coming from the federal and the state government, the initiative taken by the local companies to build this ecosystem. However, what truly impressed me was the thinking, the global thinking of the people and the companies here. They are eager to tap talent across the globe, whether it's a human talent or companies. To me, that is extremely critical to be able to ramp up semiconductor ecosystem at a fast pace in India. It is very critical to leverage the knowledge, experience of the global companies and talent so that India does not go through the learning curve again, and they do not repeat the same mistakes that happened before. Next is the sales pitch for Power Semi. So I believe that Power Semiconductor is the low-hanging fruit, the first step towards establishing a robust semiconductor ecosystem. And the reason for that is illustrated in the table here, where I compare a power semiconductor technology with a CMOS technology, a cutting-edge CMOS technology. So we all know that the CMOS technologists have been chasing Moore's law for a few decades. And now it is at the cutting edge. You are looking at single-digit nanometer nodes, 4 nanometer and that sort. So setting up a fab for those technologies is extremely expensive, costs tens of billions of dollars. On the other hand, the power field, whether it's power discrete semiconductors or BCD technologies, are not so dependent on the node, the lithography, because here the device architecture is more important. The optimization comes from the device architecture, the application-specific optimization, and the package. You won't believe it, but package is equally or more important in a power product. Another big advantage that power offers is that it can enable faster ramp. I will show you some of the technologies, and what you would see is that a wide range of voltages and applications can be covered by a few technologies that can be done in a single fab. Not only that, the fab and the OSAT are actually very close to the final product and the customers. They are, as compared to CMOS, in CMOS you have multiple layers of design architectures, you have software layers, and it really is, a longer cycle time and a lot of intermediate steps to make your product ready for your customer and start shipping. On the other hand, power semiconductor, much faster ramps and a lot of predictability in the volumes. So I will show the evolution of power semiconductors, and I will start with the MOSFETs. This is the workhorse that has been around for 50 plus years. And it started in the late 70s with something called the planar DMOS structure. And over the next 3 to 4 decades, the evolution of this device has bifurcated between the low voltage and the mid voltage. So my definition of low voltage is anything from 50 to 250 volts. And over here, 2 key innovations really boosted this technology by a factor of more than 10x. The first is something called a trench FET structure. So this structure, as you can see, has a trench in silicon that simplifies the current flow path and enables scaling. The second big innovation is called the shielded gate transistor. So this uses an advanced concept of charge balance to further improve the switching and conduction performance of a power switch. On the high voltage side, the most popular structure in the industry is something called superjunction. So this uses alternate P and N columns in order to achieve the charge balance. Now, each of this device structure has spawned a multi-billion-dollar industry. Next is the high voltage, which is between 600 to 5 kilovolts. Now, in this, the most dominant device structure is the IGBT, insulated gate bipolar transistor. And this device has also evolved a lot in the 3 or 4 decades that it has been around. In this case, the optimization happened both on the front side and the back side. On the front side, the device went to trench gate to simplify current flow path and achieve injection enhancement. And on the back side, the device went to thin wafer, to a structure called field stop. Together, they have brought tremendous improvement in this. And we are seeing, alternate materials, wide band gap coming in. So in this category, we have the silicon carbide, and in the previous one, we have the gallium nitride. Now, these are new materials. They look promising, but they have their own challenges. Okay. I think I need to speed up, so I'm going to go a little faster. The package also plays a very important role here. And the evolution of the package technology has gone from the through holes and sorts to DFNs, the surface mounts that can achieve better thermals, smaller form factor, and lower costs. And then we are also looking at dual side cooling, multi-chip modules for the low voltage and case modules for the high voltage. A quick snapshot of AOS. So AOS was founded in 2000, went public in 2010. It's headquartered in Sunnyvale, California, and we have advanced device and packaging technology for the power industry. We have an in-house fab in Oregon and assembly and test in China. Our goal is to provide the optimum power solution to our customer using device, technology, and application know-how, as well as packaging technology. We have a worldwide design and manufacturing. The top left is the headquarters in Sunnyvale. Below that is our fab, and then we have design centers across different regions. Most importantly, we are growing in India. We have a design center in Bangalore. And on the top right, the two pictures are our assembly and test site. The top one is a joint venture that AOS did, and I will talk about it in the following slides. So this is really a testament to AOS track record of bringing up fab and OSAT from greenfield. Yes, yes. So AOS worked with the local government in China to bring up a 12-inch fab and a OSAT side by side in a record of 4 years. This was fully operational product with products, of production of 8K per month and wafers and 400 KK per month packages. And it was able to break even EBITDA in 4 years. So we are here to repeat that. And the next chapter is our collaboration with Kaynes Semicon. We are going to work hand in hand with them to bring up the key packages shown here. The goal is still the same: ramp up an OSAT with a record speed. So we are committed to working closely with our partners and bringing up this OSAT facility, both the pilot as well as the main OSAT, within next 2 years. Thank you very much.
Thank you, Mr. Bobde, for that insightful keynote. And I would now request Mr. Sanjeev Keskar to kindly present a memento to Mr. Dr. Madhur Bobde. Your expertise in power management innovation has truly broadened our perspective on the limitless potential of semiconductors. Thank you very much. Moving forward, our next visionary keynote comes from a leader who has been at the forefront of cutting-edge semiconductor packaging and manufacturing. Mr. Eswara from Polymatech Electronics Limited has been driving innovation in the semiconductor system, ensuring that India emerges as a global hub for advanced technology solutions. So let's hear his vision for the future of semiconductor manufacturing. I welcome Mr. Eswara. And I now request all the speakers to kindly follow the limit of 10 minutes in the presentation or the speech. Thank you.
Good morning, everyone. We are at the dawn of new era, where India is poised to become global semiconductor powerhouse, driven by innovation, policy support, and world-class manufacturing capabilities. Semiconductor market considered to be oil of this new era. This is estimated to be $1 trillion by 2032. And we from India will be producing $100 billion semiconductors. As this number is about 50% of the software market in India, we can estimate how much employment this industry is going to generate for India. The value chain revenues will be much more than 100 billion. To become Atmanirbhar Bharat, Government of India has proposed several grants like capital subsidy, production and design linked incentives, and all states are also extending from their side. Many conglomerates joined making Vikasit Bharat, and have committed huge investments in making semiconductors in India. Let me take this opportunity to introduce Polymetallic Electronics, one of the India's pioneering semiconductor company. Our journey began in 2019, but our legacy in manufacturing goes back further 2008. Today, we stand at the forefront of this revolution, bringing advanced semiconductor packaging and manufacturing capabilities to India. Our vision is to bridge technological gap, enhance domestic semiconductor supply chains, and propel India into a position of global leadership. In Chennai, we are leading the way in optoelectronics packaging, a critical segment in high-performance electronic devices. By leveraging cutting-edge technologies, we are ensuring India has a robust ecosystem for LED chips, laser diodes, and other optoelectronic components used in industries ranging from healthcare to automobiles to consumer electronics. Our facility in Chennai is equipped with state-of-the-art clean rooms and advanced package solutions that cater both domestic and international markets. This facility is set by Mr. Hidenobu Hitotsumatsu, a synonym in Japan for LED chips packaging. In California, we are building semiconductor testing and failure analysis equipment from Long. Our equipment is used by every semiconductor and automobile company. We are expanding this equipment building facility in the state of Kerala in India. Telecommunication is the backbone of India's digital future, and our telecom device packaging facility will be coming up in Chhattisgarh this calendar year, and it will be driving advancements in this sector. As 5G and next generation networks expand across the country, Polymetallic Electronics is ensuring India remains self-reliant in producing high-end semiconductor modules from telecom infrastructure. Our experts in system in package, it's called SIP, and advanced interconnected technologies enable us to deliver world-class solutions for mobile networks, IoT applications, and satellite communications. From Wales, United Kingdom, Cardiff University professors are designing our chips. At the core of semiconductor fabrication lies high-purity wafers. Our Nagpur facility is setting new benchmarks in ingot and wafer manufacturing, positioning India on the global semiconductor supply chain map. By producing high-quality monocrystalline and polycrystalline silicon, silicon carbide, and sapphire ingots, we are reducing dependence on imports and ensuring a steady supply of essential raw materials for chip fabrication. This facility is a testament to India's ability to achieve vertical integration in the semiconductor sector, creating a strong foundation for future chip design and fabrication initiatives. Polymetallic has tied up with ECM France for production of ingots and wafers. Globally, Polymetallic Electronics is not just building semiconductor packaging and manufacturing plants. We are building an ecosystem of innovation, research, and skilled workforce. Our commitment to sustainability, automation, and AI-driven manufacturing ensures that we remain at the cutting edge of semiconductor technology. As we move forward, collaboration with academia, governments, and global semiconductor leaders will be key to India's success. The future is bright, and with the right policies, investments, and talent, India will soon emerge as global semiconductor hub. Let us together shape the future of semiconductors in India. The time is now, the vision is clear, the mission is available, the possibilities are limitless. Vande Bharatam Vishwagurum. Thank you.
Thank you, Mr. Eswara, for sharing such invaluable insights into the evolving semiconductor landscape. I now call upon Dr. Virappan to kindly present the memento to Mr. Eswara. Thank you, sir. Now we shift our focus to Siemens EDA, a name synonymous with innovation in electronic design automation. Our next speaker, Mr. Ruchir Dikshit, is a driving force behind advancing semiconductor design and AI-driven chip development. As a Vice President and Country Manager of Siemens EDA, he has been leading the way in revolutionizing design tools that power the chips of tomorrow. Let's welcome Mr. Ruchir Dikshit to share his visionary insights. Welcome, sir.
Let's see if I can talk to you while you can see me. If I can get one, that would be awesome. All right. I don't want to hide behind this podium. Good morning. And I am from Bangalore, and I have to say this good morning because I have never seen anything in Bangalore start before 10 a.m. Right? So this is amazing to see a room full of people at 8 a.m. Who have chosen to give their mornings to come and listen to some of us. I thought I'll talk to you about intelligence. Intelligence that each and every one of you is building. Each and every one of you is building into things that we use every single day. Artificial intelligence powered by human intelligence that you bring in. Everything that we touch in our lives. Whether it is things that we consume, knowledge, food, or it is things that we ship to get things to us, things that we produce. Everything is intelligence now. And why say this? Because it's not just a claim. There is data. So McKinsey has been doing this exercise for quite some time now. And they did a survey and found out that the number of companies who have at least one artificial intelligence application within their own company has grown over 5x. And look at the second chart, the small chart. All right, can you hear me? Awesome, thank you. So if you look at Gen AI, the curve on Gen AI is even steeper. And that's happening because new use cases are being adopted. As new use cases come up, the side effect is that the AI model keeps on getting bigger and bigger and bigger. I don't know if you can see it from back there, but at the top is the llama model. And look at the y-axis on the number of parameters the llama has to take care of compared to GPT-4. Just imagine the amount of compute and storage it needs to get through that. When we go to ChatGPT today and punch in a query, we don't realize how much compute is happening behind the scenes to get us the answer in a few seconds. And with that, this data all of you know because you are creating it. About $1 trillion of semiconductors and electronics by 2030. And that's crazy. 1 trillion of value that people here in this room are creating for the world. And while the excitement exists, there are some challenges. We all deal with it, and we are here to discuss those challenges with our peers. All right. So the first challenge, again, this expression was used earlier, preaching to the choir, right? Multi-domain design. We're talking of electrical, mechanical, electronics, all having interactions with each other today that didn't have earlier. Then we talk of complexities. We're dealing with that. And then, in addition to that, PPAS, PPA, and schedule. The S usually people forget because all of these are getting even more difficult because increasing complexity. So I thought I'll quickly go over some of these things. Cost and schedule is an important thing for all of us, right? We want to save cost and we want to be on schedule. Some geographies in the world have a challenge of not enough engineers coming out of schools. In India, we don't have that challenge. We have lots of engineers, but the demand is even greater, which means that we need to make those engineers useful and skillful very quickly. So talking of that, how much time do I have, ma'am? That's it? I should have asked this question 5 minutes later. Wrong time to ask the question. So let's do this. Let's try and get this quickly. The reason this is a challenge is because this is a chart that you all know, we all live and breathe it. Every single node that we jump, the number of engineer months required to get a design done increases by orders of magnitude. So EDA, what has EDA been doing? EDA has been doing the traditional things and some advanced things, right? We keep improving our algorithms. We keep bringing ways to verify your designs quickly, do your designs quickly. We look at what we can do to allow reuse to you and also work on creating a skilled workforce for you. So that's what EDA has been doing all these years. And the reason we are doing it is because if you look at optimization, right, even every time M&A happens, every time executives and all of us, we talk about optimizations, what do we talk about? The first thing that comes to our mind is how can we centralize? We centralize, we optimize. And that's what's been happening in the industry so far. Most of the investment is on the right-hand side of this chart, where we say, okay, we design once, we put it on a big server farm, and then it applies to everything. But as soon as we start to look at edge devices, 17 trillion edge devices in the world. If we have to design once for every edge device, we'll never get things done. But it can be done with automation. And that's where AI comes into picture. In the last 2 years, I have not had a single conversation with a customer or a competitor where AI was not mentioned. Hey, what do you have in AI? The thing is, AI is exciting because AI has the promise of reducing all our parameters by 50%. Get our designs done 50% faster. But there are 5 critical elements. First is verifiability. Can you verify your algorithm? Can you guarantee that the model that you built is correct? And the reason I talk of verifiability first is because I don't know if you saw the press release 2 days back. ChatGPT has cut down their hallucination rate by 23%. 23% is the reduction. So from 60% hallucinations since their press release, 60% hallucinations, they have come down to 37% hallucinations. Now imagine we are building hardware. If our designs had a hit rate of 63%, every 63% times we'll be right. 37% of times we don't know if this will do what we want to do or not. So anything that we want to do in AI has to be verifiable. It has to be usable. If it's not usable by general public or engineers, new engineers, experienced engineers, it's of no use. Then it has to be general. It cannot be for one application. Robustness, of course, I don't want to talk about that. And moving on to the last one is accuracy, because we all need it. And once we have all those 5, we have industrial grade AI. Because the thing is, adding AI to something is very, very easy. Making it useful is the tough part. I mean, each and every one of us can sit here for half an hour, 45 minutes, or maybe half a day, and think of areas where we think, oh, you know what, AI here will be very useful. So finding a target for AI is very useful. But that's not the real value. When it goes to defining how accurate it is, needs to be, and what accurate means takes years. And as we go down, making it industrial grade, meeting all the 5 parameters I talked about can take months and months and years of work, engineers' worth of work. And it has to apply across the life cycle of the design, from concept all the way into the hands of the customer. Because in the first half, we are talking about the quality that we want to deliver. In the second half, we are talking about the quality and the life and the cost of ownership that we promise to our customer. I cannot move forward until this moves. There we go. So, little bit of seamless advertisement. I will spend less than 30 seconds on it. The thing that I want to talk about is what we are working on is all the way from adaptive to generative AI through the continuum, making you and your engineers better to help them make products which are better and faster to the market. So challenges I talked about, things are on the slides. The lady has come up here waving hands at me to get me off the stage. But the first thing is to talk about challenges is cross-domain. I talked of mechanical, electrical, electronics. But now we need the ability to have interactions within the tool flow, within the tool chain that is not file dependent. So yes, 3D IC is something that's being talked about. How many people here are doing or thinking chiplets today? Thinking. There are some people I know who are thinking but are not raising their hands. It's too early in the morning. They are from Bangalore. The second challenge that I talked about earlier, if you remember, was stricter PPA trade-off. And this is where having the ability to design at a different level of abstraction becomes very useful. I talked about accuracy and the quality we want to deliver because we don't have the luxury of getting a general purpose engineer to deliver our products, to design our products, because our quality demands are much higher. So helping our engineers become more intelligent, becoming more resilient is something that we need to be looking at. I'm going to skip over this. So wrap up. What is Siemens EDA trying to do? What we are working on is to solve your business challenges. What are your business challenges? If you take all of your business challenges and you distill them down into 3 categories, I say that what worries you as an executive, as a designer, is quality, schedule, and making sure that you get there with your resources. So we are working on that. On the basis of technology that we build, on the basis of processes that we are creating for you and your engineers, and creating a platform that you can take advantage of to give better products to your consumer. Thank you so much. Have a great day.
Hello. A huge thank you, Mr. Dixit, for that inspiring keynote. Your vision for AI-driven design and automation will undoubtedly redefine how we innovate in the semiconductor space. I now request Mr. Sudhir Nayak from ISA to kindly present the token of gesture, the memento, to Mr. Ruchir Dixit. Sir, you can come in the center. Thank you very much, sir. The next keynote comes from a pioneer in semiconductor engineering and testing solutions. Mr. Srini Chinnamalli, co-founder and CEO of TESOL, has been instrumental in shaping end-to-end semiconductor engineering services, ensuring that the industry remains agile and future-ready. Let's welcome Mr. Srini Chinnamalli. Welcome, sir.
Hello. Good morning, everyone. It's good to see such a large gathering of semiconductor professionals. Big round of applause to IESA for getting this event together. IESA has been working tirelessly for the last 21 years. And TESOL, I'm from TESOL. When we got started, IESA was also getting started. And over the years, okay, let's see if the slides come on here. Can anybody look at the slides? Yeah, I'll just keep talking while the slides are coming. When we first set up our test lab in 2004, we were hoping to see this kind of vibrancy, but great to see a lot of good momentum in India.
Hello. Sir, just a moment. Yeah. Can we have his presentation, please, video team? Thank you.
Okay, it looks like I need to talk from my memory. But over the years, when we first got started, now we've grown to be, the largest semiconductor engineering solutions company in the world. Big thanks to all the members of the IESA to make this happen. Now we are, okay, let's see the slides don't advance. You'll have to keep looking at my picture, I guess. Excuse me, okay, I'll just, do I wait or continue? Okay. So so TestSolve is, we got started with advanced test solutions. We are over 3,000 employees worldwide, working in 11 different countries. And, a lot of OSATs. Okay, great, it's here. Okay, great. So, last 21 years, we've been contributing a lot to the ecosystem in India as well. We've trained over 5,000 engineers in the field of testing and design and so on. But again, I'd like to thank all the IESA members. It couldn't have been possible without your support. Big round of applause to all the IESA members as well. So anybody setting up new companies in India, I relocated from the US in 2004 to set it up. I had my doubts at that time. But after working in India, the kind of engineering talent we have in India, nothing is impossible. So all the new companies getting started, all the best for your success, and we are here to support you. I'm going to talk about the importance of tests in the semiconductor value chain, and often overlooked aspect of the engineering. So if you look at the typical manufacturing flow, right, once the wafers are fabricated, there is a test at that point called wafer sort or wafer test. And then the wafers are assembled, and then there's another test called final test or package level test. Contrary to popular belief, every chip that is manufactured has to be tested. It's not sample tested. If somebody wants to ship 10 million chips a month, each and every chip has to be tested. And testing is pretty expensive proposition. Every second costs anywhere between 5 to 7 cents. So approximately $4 a minute, or 350 rupees a minute. Yes. So it cannot be manually tested, right? By the time somebody picks up the part and puts it in a socket, it's already a minute. So it has to be very, very automated and efficient. The chips have to be tested in a matter of few seconds in the ATE world. And the quality levels are very, very stringent. This measured in defective parts per million called DPPM. So any chips going into consumer devices, typically it's about 50 DPPM, which is not more than 0.005% defects. If it's going into automotive applications, it's 0 DPPM, any life critical applications. So that's the role of test, right? It has to be very high quality, very automated, very efficient. So that's, we've been in test engineering for a while. It's good to see a lot of OSATs coming up. Till we tested and shipped the parts, companies cannot realize revenue. So it's an important part of the semiconductor engineering as well as manufacturing value chain. Now the test is getting more and more complicated. So now with the advances in packaging, chiplets in the AI era, everybody wants to talk about AI, so I just threw in the AI word out there. So if you look at, each package, there are multiple dies. It can be CPU, GPU, it can be on a silicon interposer, or nowadays you're getting glass substrates, and then that's mounted on an FR4. So essentially, thanks to the advances in packaging, the test also is getting more and more complicated. So, as we speak, we are testing hyperscaler chips. And these data center chips can have multiple CPUs, GPUs, I/O dies, active passive silicon, dummy dies, and so on. This is public information. For an example, this is older generation of products. But if you look at AMD MI300 chip, it has 3 CPUs, 6 GPUs. It has 4 I/O dies, a lot of thermal dies, and so on. So in terms of test, the top is the regular, the vanilla test flow that we had earlier. Now we need, for example, the chiplets, each of those dies can come from different design houses or different fabs. Chiplets, all the chiplets have to be tested once. And then the silicon interposer, they're mounted on the silicon interposer. Then there is a wafer test after the assembly. Then they're all mounted on a regular package. There's another assembly test, final test. And then, because the quality levels are so high, you need system level test as well. So the test is getting very, very complicated. Now it can be a simple power management chip, but then the whole package with CPUs and GPUs can be thrown out, right, if one die is failing. So the wafer sort test should be very, very high quality. It's called known good dies. You cannot afford to have any wastage of packages and so on. So, this flow is, people are just beginning to establish these complicated flows, and chiplets are going to become very commonplace soon. It's not as commonplace now, but in 2-3 years, it's going to be a big percentage of chips that are, especially the high-end silicon that is shipped. Now the DFT also is getting complicated, right? The test strategies. Typically, a lot of access is not there for the internal IOs, right? It doesn't come as a primary IOs on the chips. And each of these dies can have different DFT standards. So how do we access all the internal nodes and make sure if something is failing, how do you know which die is failing? And, of course, now there are some complicated strategies. There's an IEEE 1838 standard to access, different dies inside the chip. And, you need to figure out how to have a fast way of streaming all the scan vectors and so on. So DFT is also getting very, very complicated. Apart from that, if you look at the test hardware, if you look at the probe hardware, which is the hardware required to test at wafer level, the bump pattern can be 2 to 3 times more denser than a typical. They can have 10,000 to 20,000 bumps on each of these chiplet. And the test quality, before we used to do smaller subset of tests at wafer and then do all the complicated tests at the package level. But now the wafer test has to be very, very stringent. So this probe hardware material should have high-speed material to be able to test high speed, and then RF and so on. So that's getting very complicated. The final test, the load board hardware also, for example, now each chip can be 800 watts to 1000 watts of power because of so many dies in each chiplet. So you need to have special cooling mechanisms. You need to have, and the test head has limited space. So how do we accommodate tens of thousands of components on the load board? You need to have some piggyback schemes and so on. So needless to say, the test hardware, you need a lot of care in designing that. And then, of course, the qualification. This is burn-in, where, how do we have qualification conditions for multi-process, multi-die kind of chiplets? And in the old days, we used to put, the whole board with 30, 40 chips in one oven, and you cannot do that anymore because each chip is drawing, anywhere between 500 watts to 1000 watts plus. You need to have local cooling mechanisms and so on. So the qualification process is also very complex. Last but not the least, there is system level test. There's one extra step in there. It has to be tested at system level. And system level test, each of that can take anywhere between 20 minutes to 1 hour per chip. So you cannot be doing one at a time. So you have specialized handlers. You should have test strategies to test 600 of these chips at the same time, so that there's good efficiency of throughput. So SLT is a good combination of test engineering, embedded systems, application engineers, and so on. So what does it mean for India? So in terms of the regular testing, right, the other countries, Southeast Asian countries, they have a head start on India. They have very well established OSATs and manufacturing mechanisms. Now for chiplet kind of testing, you need a lot of coordination, as you can see, right, between DFT, substrate designers, test engineers, product engineers, and so on. India has the advantage of having a very good engineering ecosystem, not just manufacturing, right? So we can come up with innovative solutions. A lot of places, these methodologies are still being defined. So, and TESOL operates in 11 different countries. We have good look into engineering ecosystem. When I go to, other Southeast Asian countries and so on, this kind of engineering talent is not available. And this is where we can innovate. And, I know a lot of OSATs are coming up. Other than the regular packages, also think about advanced packaging, right? This is where we can have a differentiation compared to other ecosystems, other manufacturing ecosystems. Okay. How many minutes? 5 minutes? Okay. I have 5 more minutes, so I'll just wrap it up. So in terms of, again, OSATs and semiconductor companies, we need a lot of, investments in this space. It's not like a software company. Let me just advance all this. Yeah. So if you look at, what does India need, right? So we have, for any vibrant semiconductor ecosystem, we need to have product companies, like chip product companies and startups. Yeah, sure. And we need manufacturing OSATs, and of course, we need product OEMs. So we have very good engineering ecosystem. No place in the world has this kind of engineering ecosystem. All we need is risk capital, right, which is missing. So government and private industries, like China set up $73 billion risk capital fund. They gave $2 billion to startups alone in 2022. So can we have that? The risk capital is missing in India. So that is something, if government and private equity firms can work together, India can be a superpower in semiconductor world. Thank you. I wish you all the best. Yeah.
Yeah, I'll do that. I'll fix it. Thank you so much, sir. And I now request Mr. Ankur Jain to kindly present the memento to Mr. Chinnamalli. Thank you so much. Semiconductors are not just about circuits and chips. They're about materials, science, and innovation at the atomic level. And no one understands this better than Applied Materials. Our next visionary keynote is by Mr. Avinash Avula, Country President and MD, Applied Materials, a leader who has been driving material innovation to enable the next generation of semiconductor breakthroughs. We welcome you, sir.
Good morning, everybody, and I hope all of you are doing well. I'm also from Bangalore, but I was up early. So great to see a great audience here. We're happy to participate in this event and help shape the future of the semiconductor industry in Gujarat. It's an honor and privilege to share with you our perspective on the industry and how we want to collaborate with the industry going forward. Just a quick background about Applied Materials. We were in Silicon Valley from the foundation in the 50s and in the 60s, and we are a 50-plus-year-old company shaping semiconductors around the world. In fact, we like to say that there is no chip in the world that is made without an Applied Materials equipment, and so we're super proud about helping contribute to the future. In India, we've been here since 2002, and we started slowly building a team with adding capabilities over the many decades, and slowly have moved up the value chain doing engineering and product development as well. And we're very excited that the ecosystem is shaping now where we can also participate locally and not just globally around the world. My counterparts who spoke today talked about a $1 trillion industry. We see AI driving that. The last 50 years took about 500 million revenue today, but I think the next 5 years we will see a doubling of that industry. And so very excited about the drivers for it and how that will shape our future. As we look at the various components of the participants in the value chain, the fabless companies, the fabs, the equipment companies, and the materials companies, we're all set to grow as we look at that future. And certainly as we look at the opportunity in India, we certainly see an opportunity for all of us to partner and shape that growth for us. As you all know, this whole process is very complex and takes a wide range of ecosystem partners to come together. These are our existing players that we see around the world that we partner with across equipment companies, fabless companies, chip manufacturers, and also materials companies. But of course, we're waiting to see Tata on this list. We're very happy to have the opportunity to work with them. And I think a year from now, when the Tata fab is up and running, we'd love to see how we're working together to shape that and add a new dimension to the industry in the future. So looking forward to that as we grow the industry here in Gujarat. And just again, I don't need to give a tutorial to experts here, but if you think about the process flow for a semiconductor chip, it is a very complex process, integrating equipment, materials, manufacturing know-how, and building a chip over multiple phases and steps. The nice thing about Applied Materials is we pretty much participate in every step of the value chain of production of a chip, less, of course, the imaging, the lithography step. So very happy to enable the entire process. And we think we're the only company in the industry who can do that. And so as we look at developing technologies and partnering with customers, we can bring the value of the entire portfolio to help solve customers' challenges. As I mentioned, our portfolio is pretty broad. We operate across many dimensions of the process. And as we have these programs and tools and equipment, we're able to bring an integration capability to solve challenges beyond just doing a single process step. And that's something that we've been adding to our portfolio over the last decade, starting with packaging, but also looking across all the leading edge technologies where we can design a structure, develop a process, and then provide a solution to our customers. And this is an opportunity to partner more closely in a very customized way to help each customer build a new technology solution using our wide range of platforms. This is just an example of how we do packaging. As the portfolio that we have today, we can do pretty much, again, every step in the advanced packaging phases that allow us to actually help craft a specific device structure, build processes, and then engage our customer to provide a solution that goes beyond just one tool. Now, when we talk about tools, we have a very complex setup. This is an example of one of our leading machines or tools that does the process steps. And you can see a higher number of very complex parts, about 10,000 go into making one system. And it's not simply hardware. We do software to integrate the tool to make it work properly, but of course what happens is physics and chemistry in the chamber that allows us to do the process. So we are a systems engineering company. We help solve materials challenges and process challenges, but it takes a lot of it to come together, whether it's automation, robotics, software, technology, device structure, engineering, and so on. So that is a very complex capability that we have built. And we're excited to even to work with our partners here on developing the next generation technologies for our customers, both here in India and worldwide. And one of the things that our company has launched recently around the world, we started with an announcement in Singapore a few months ago, but also we're building a center in Santa Clara and also an innovation center here in India The idea for EPIC is equipment, process, innovation, and collaboration. And this is about how we bring the equipment to work on process technologies in a collaborative way with our customers, our partners, our suppliers, and how to push the leading edge of innovation with them. So as we think about what we try to do, basically, by doing this in parallel, working across the value chain together, we can accelerate and reduce the time it takes to build new capabilities. And so we are building now centers in the US and have also started to announce our programs in Singapore, also a capability in India that will be added in the future to accelerate innovation and bring a variety of different partners together. So this is a vision of how the company sees the future, because we can't do everything ourselves. We really need to collaborate across the value chain. So a year ago, we announced an innovation center for semiconductor manufacturing in India. This is a work in process, but running on schedule for us to build a capability in India to do R&D at a product level. And for us, product, as I mentioned, is equipment. And that will require us to build, design, develop products that engage also the local supply chain ecosystem and our customers to come together with academia to help us build next generation technologies that serve not only, again, our customers around the world, but where we have opportunity to work with customers here in India. So this is an area that we look for collaboration. As the center comes up, we look for opportunities to bring other parties in, work with us to bring various technologies that we can integrate into our systems and then support the development of next generation equipment. We also announced recently, or have been working with universities and academia across India on a program we call Ascent, which is to bring new challenges to the academia and engage with them on how we will bring their insights, their capabilities to help solve challenges that we are working on today and for the future with our customers. So there's a lot of opportunity for us to collaborate, to work closely together, and this is something that we are trying to drive more of as we establish and increase our presence here in India. With that, I would like to conclude my remarks. Thank you very much.
Thank you so much, sir. I now request Mr. Hitesh to kindly present a memento to sir. Can I request Mr. Hitesh? Okay, please. I have to allow them to check, okay? Just give me a moment. They'll have to check for the COs. 12 minutes. 10 to 12. Just give us a moment for the security check, and we shall then proceed towards the next visionary keynote. Okay. Sir, done? Sir, done? And finally, to conclude this incredible line of visionary keynotes, we have a true thought leader in the field of embedded systems and semiconductor solutions, Mr. Lars Reger, Executive Vice President and Chief Technology Officer at NXP Semiconductors. He's a pioneer in secure connectivity solutions, IoT and automotive semiconductors. Please help me welcome Mr. Lars Reger. Over to you, sir. So you need to switch it on. We shall help you.
Does it work?
Okay.
Works. Namaste. Thanks for having me here and good morning. So that's the first time that security is needed before I'm allowed on stage. And I'm very happy to give you a short insight in how we at NXP see the world and what makes us tick, not only in India, but especially also in India. So the title is saying the rise of the responsible robots. And how does it all start? Well, normally it starts with us having a dream. Me, with my childhood dreams, I wanted to become an astronaut. That was decades ago. And of course, the key question is, how will you make a difference to the world? How will you be recognized in the world? And what is the area where you can optimize something for mankind? Well, very honestly, in the days where I was dreaming to become an astronaut, it was still the complete analog world. And we moved since then into an on-demand world. Marisa needs a taxi, Ajit needs a pizza. On demand, you take your mobile phone, you press a button, and you order it. Sometimes it even works when you need a presentation here on stage. You press a button and you get it. And now, this world is going to move into a world of robotics. Analysts are forecasting that we are getting 70 billion smart connected devices around us in the next decade. Listen, 70 billion little smart connected robots around us. And what will happen with these robots? Well, we will use them for better manufacturing. We will use them for better and renewable energy management. We will use them for autonomous transportation, for your smart home, so your cocoon around you, and I will use them to manage my health and my wealth. So my digital twin in the cloud for me personally. Or in other words, the world that anticipates and automates what Lars wants to do next is just upon us. So in other words, I said it already, we need to build robots. And how do you build robots? Well, every little single robot, whether it's a smart thermostat, a smart fridge, a smart car, or a manufacturing robot, is built in the same way. You sense your environment, you get data from the cloud, and with all that data, you start thinking of a smart advice. And then you send that smart advice to the arms and legs of your little robot. And if you cannot trust your robot, you will not do that. So trust is a special ingredient. And how does a nerd define trust? Well, it's safety, functional safety, and it is hacking security. You will make sure that your devices cannot turn against you, that they cannot be abused. And as there is so many robots with so many form factors, you need to have them scalable. And how do you build such a robot? Well, we've done it pretty wrong in the last 10 years because a lot of guys said in the autonomous driving area, well, it's just a piece of AI on wheels. But how real robots are built, you see in front of you. Because here on stage is a biological robot talking to you. And this biological robot has a very, very different brain architecture. This biological robot here on stage has a spine. You see it here in orange. And that spine is a real-time, a simple but a real-time system. So if this robot here stumbles, the spine says, with the reflexes, straighten your legs. Nothing more than that, but straighten your legs, stabilize your body. Then you have a green part here, your cerebellum. Well, and this cerebellum does funny things because I stand here on one leg, my heart is beating, my stomach is working, my temperature control is intact. And this robot is still able to talk to you because there is a different compartment, the blue part, the cerebrum, needed for this text to talk to you. And I can walk here on stage and I'm not falling off stage when I think about my next sentence. That is important. We have these different architectures. A fast real-time system, a more mighty real-time system, the automotive guys would say all ASIL-D electronics, and then only on top you have a little bit of AI. And how much AI do we need? I mean, big debate between ChatGPT and DeepSeek. Yeah? How much energy do you need? How big is your compute needs that you need to have? And I can tell you the world record for large language models is below 20 watts. Because my brain, maybe I would love to have it at 40 watts, but my brain is running normally in the range of 20 watts. 19 of the 20 watts are in the orange and green part. And if I heavily think, then I increase. Just by heavily thinking, I increase a little bit to this 20 watts. I have billions of neurons, and all of that is not needed for building a transportation robot. Because look at the right side. An ant, an insect, is a very intelligent transportation robot, a mosquito. They can do the transportation, the flying parts very nicely. I mean, they have their limitations. If you have a bright light, the mosquito cannot escape the bright light. So you need your main brain to escape traps. But for the pure transportation, I promise you, the world record will be somewhere between 1 milliwatt and 20 watts for an AI system. So that DeepSeek comes at a certain point in time and says, I can do much, much better than ChatGPT with much less energy, was totally clear. I mean, when you announce it, yeah, I mean, that's maybe a geopolitical dance, yeah, when you want to kick whom, yeah, that's a different question. But we will see enormous innovation in that area, especially in the robots area. Now, what do we need for all of these robots? Very simply, we need platforms. On the first, on that green bar, we need functional, safe power supplies, because everything is nothing in your body if your blood circuit doesn't work. If you cannot supply your neurons, functionally safe, no failure on these systems. Furthermore, you need neurons, you need a network, you need a wiring harness, you need to be able to talk to the different ingredients. So in car electronics, let me be very simple, what we are doing in the semiconductor world, it is CAN, LIN, FlexRay, Ethernet and SerDes electronics. You need microcontrollers and microprocessors, very tiny, very small, to the big systems, and you need to have the right functional, safe and secure software on top, middleware, operating systems, because what is hardware if you cannot customize it? And how do you customize it? You program it. Okay, so with all these ingredients, then how do we work ourselves towards a more robotics era? Well, I can only speak on behalf of NXP and what we have done over the last quarter. We have announced that we're going to buy Aviva links for 16 gigabit SerDes electronics. And by the way, Aviva Links has quite some offices in Bangalore and Hyderabad, so deeply, deeply linked to the Indian ecosystem. We have announced that we're going to buy TT Tech Automotive, functional, safe and secure middleware, operating systems in the real-time segment. And 2 weeks ago, we have announced that we also now enhance our office in Hyderabad by acquiring Kinara. And Kinara, as far as my team tells me, is the Hindi word for edge, and that is for a good reason, because this is a AI company with AI accelerators that we are bringing as companions next to our functional, safe and secure electronics. In other words, we are trying to enhance that spectrum that we need with NXP, silicon and software to build these robots. But the brain is not everything. To build the best robots in the world, these robots need to have better senses than the biological robot here on stage. And what are better senses? Better senses are capabilities like our superheroes have. Like in our famous Marvel movies. You want to have someone who has the ability to influence things around you, like Dumbledore, like a magician with his wand. You can operate things in front of you. You want to be able, like Yoda, via telepathy, to see what's happening outside of your line of sight. You want to have X-ray vision. You can see in rain and fog. You can see through things what's happening, which objects are approaching you. And like in Hitchhiker's Guide Through Galaxy, you want to have a tool like a bubblefish that you can plug into your ear, that even me as a German can understand every Indian dialect. So a language translator, a communication tool. Now, how do we build this in silicon? Well, very simply, we have it. We are opening doors already via ultra-wideband technology. We are seeing what the goods are doing around us via car-to-car communication. 500 meters of distance, I know what a car is doing, what a traffic light is doing. I know very precisely via our high-resolution radar how people are walking 300 meters in front of me. I can separate people walking 300 meters in front of me by these high-end radar systems. And we have the famous Meta standard, where in my smart home, my sound system, my window blinders, my fridge, my solar cells, and my home gateway can talk to each other. And all of that I'm combining to build the best robots with better sensors than me, with more energy efficiency and a higher functional safety. And just to give you a couple of examples, we have this together with our partners, with TT Tech, in level 3 autonomous units for cars. We have this in energy storage systems, for the house, so derived from the car into the smart home. And I will also not go into all details. Of course, these robots are looking in this way for your personal health as well. So health monitors that are highly secure, highly functional, safe, and that are protecting your own personal health data and are making sure that in case your insulin levels are not where they should be, that even your car is not opening you the driver's seat and that you are not allowed to be in there, but rather an ambulance or a doctor is called. So with all of that, just to condense it and just to wrap it up, we are kicking the door open for building robots. It's cool for us semiconductor guys because 70 billion smart connected robots in the next 10 years means tons of silicon. And it is silicon in the sensing area. So how do I sense better than any human being? It is in the think. How do I efficiently compute? How do I efficiently bring AI onto the road? How do I connect? How do I drive my actuators? How do I build trust, so safety and security into the systems, all at low energy consumption? And then how do I scale the brain to make it fit for the purpose? Or in other words, it will be a big architecture consideration, a sensor consideration, a systems consideration, and a platform scalability consideration. And all of that big time happening also here in India, especially here in India. NXP has 4,000 R&D engineers here in India, and some of our most advanced devices are coming from here to the world, and that story to be continued and expanded at a very fast pace. Have a great day, thank you, and if you want to build robots, you know where to find us. Thank you.
Thank you very much, sir. And I now request Mr. Rajiv Kushu to kindly present the memento to Mr. Lars Reger. Thank you, Mr. Reger. Your vision for secure, intelligent semiconductors is paving the way for a smarter and more connected world. So you can go a little further for the photograph. Thank you. Thank you so much, gentlemen. Ladies and gentlemen, Now let us immerse ourselves in a visual narrative that encapsulates the vision, initiatives and impactful contributions of GSEM, GIDC and DSIRDA. Please direct your attention to the screens. Thank you.
This is Dholera. The future begins here. A visionary initiative led by Honorable Prime Minister Shri Narendra Modi. With world-class plug-and-play infrastructure, seamless connectivity, and a thriving ecosystem, Dholera is setting new benchmarks in urban innovation. At its core is the upcoming semiconductor fabrication plant by Tata Semiconductor Manufacturing Private Limited, a milestone positioning India as a global semiconductor powerhouse. As we continue our journey of transformation, here's a glimpse of what's next at Dholera SIR. A 200-bed multi-specialty hospital with ICU, OPD and advanced radiodiagnostics facilities. A state-of-the-art higher secondary school. A vibrant multi-cuisine food court. And a fully equipped 11-garage fire station. Dholera is not just about industry. It's a complete lifestyle. From modern studio apartments and luxurious corporate hotel by leading private developers to an international tent city and a premium guest house. This urban hub has it all. Innovation, infrastructure, opportunity. This is Dholera. The future begins here.
Semiconductors are playing a critical role in the world in more ways than we can imagine. It is our collective aim to establish India as one of the key partners in global semiconductor supply chains.
Driven by the vision of the Honorable Prime Minister Shri Narendra Bhai Modi, the Government of India launched a comprehensive Semicon India program in 2021. The India Semiconductor Mission, ISM, was established to position India as a global leader in semiconductor design, manufacturing and innovation. Gujarat, under the leadership of the Honorable Chief Minister Shri Bhupendra Bhai Patel, is synergizing with this vision and policies of the Government of India. Gujarat State Electronics Mission, GSEM, promotes initiatives to develop semiconductors, electronics and display manufacturing ecosystem in the state with a three-pronged strategy by providing fiscal support, world-class infrastructure and capacity building. Gujarat's specially curated electronics policy supports the upstream and downstream ecosystem partners. To support the chip and electronics design industry, the state has introduced a dedicated policy under the Gujarat ITES Policy 2022-27. Additionally, the state promotes global capability centers through its GCC Policy 2025-30. The government is actively supporting upskilling and training facilities in hub-and-spoke model in collaboration with industry partners and premier STEM institutes such as IIT Gandhinagar, PDEU and many others. Department of Science and Technology, PDEU, Gandhinagar and Micron have collaborated to establish an ATMP training center to enhance capacity building in the semiconductor sector. Gujarat is an industrial paradise with its all-inclusive, sustainable development model, excellent connectivity, huge reservoirs of skill and knowledge, and vast business and investment potential. A robust industrial corridor with special investment regions, backed by a dedicated freight corridor, facilitates the logistics. A world-class semicon city is being developed in Dholera, featuring state-of-the-art infrastructure, seamless 360-degree multimodal connectivity, and cutting-edge common facilities, all designed to foster a thriving semiconductor ecosystem in the state. Gujarat is leapfrogging as India's gateway to Silicon, with over $14 billion worth of projects under the Semicon India program. Micron Technology, the American leader in the memory and storage solutions, is setting up India's first state-of-the-art semiconductor memory ATMP facility at GIDC Sanand. The project broke ground in September 2023 and construction work is under progress. TSMPL, Tata Semiconductor Manufacturing Private Limited, a subsidiary of the Tata Group, one of India's largest conglomerates, is setting up the country's first commercial semiconductor fab in Dholera SIR in technical collaboration with PSMC. CG Semi Private Limited, a subsidiary of Murugappa Group, is setting up an OSAT facility for specialized chips in GIDC, Sanand, in technological collaboration with Renaissance Electronics and Stars Microelectronics. Kaynes Semicon Private Limited is setting up an OSAT facility in Sanand, Gujarat. In July 2024, the government of Gujarat organized the Gujarat Semi Connect Conference to bridge the state's diverse domestic industrial ecosystem with emerging opportunities in the rapidly growing semiconductor manufacturing sector. Building on its success, the government of Gujarat will host the Gujarat Semi Connect Conference annually, establishing it as a flagship event. Welcome to Gujarat Semi Connect Conference 2025. Suswagatam.
Thank you. Ladies and gentlemen, now moving further, it is my distinct honor to invite Professor Rao R. Tumala, Advisor, ISM, a distinguished expert in the field, to deliver his keynote address. Sir, the stage is yours. Please help me welcome Professor Rao R. Tumala. Welcome, sir. One of the house announcements: those who have joined us late, kindly put your mobile phones on silent mode or vibrating mode. The speakers who will be using the microphone are required to use this podium only. That is exclusively for Honorable CM, sir. Thank you.
Good morning. You're supposed to say good morning. Thank you. Thank you so much. I'm very happy to be here. I am honored to be part of this exciting journey for India to become the last big semiconductor nation. I've been here now 7 times in the last 3 years to see how I can help. I concluded the easiest way for me to convey the message is to tell you, in my opinion, having been in the industry now for 50 years, the potential of India is unlimited, totally unlimited. So most of the companies in India today, as you know, mostly foreign companies, are here for only design and software. In my opinion, India's potential is a lot more than that. To me, the design and software is roughly about 1/3 of the total product. The design itself is about 10%. So if India can go into what we call manufacturing, you can see the opportunity for India to become a super powerhouse in this area. In my opinion, the best technical vision for India is what I call integrated systems packaging. Integrating designs, semiconductors, components, interconnections, thermal power, on and on and on and on. Because India already has design and software. The only two missing links, in my opinion, are technologies with which to manufacture, initially develop technologies, and manufacture to make products. So therefore, if you ask yourself what the India need to do, okay, given all the fundamental it already has, two things: expertise, infrastructure, and resources in manufacturing, and similarly, expertise, resources, and infrastructure in technologies. So with all of the companies like Micron, Tata, CG, Kaynes, and many others to come, India is well on its way to correct one problem, namely the manufacturing problem. That's extremely important because India needs to show that it has all the infrastructure necessary to manufacture. So knowing what I know about the companies, I came from the industry myself, these companies will do everything they can to make sure that part of the problem would go away. So the only problem, therefore, that I see that India needs to do is what I call technologies, okay, which means expertise, resources, and infrastructure. That's the focus of what I'm doing with a group of about 300 people in India. We call it IDSPS team. Okay, this team consists of about 100 companies. Most of them are global, and about 100 faculty, each advising about four to perhaps 8 students. Okay, they're not quite there yet. Okay, roughly, okay, about halfway there in my opinion. But in a year or two, I can see the potential of a 1,000-person R&D team, because if you have 100 faculty advising 4 MTech and 4 PhDs, that's about 800 together with the companies. Okay, I can see the potential of R&D all under one roof like no place in the world. So this team, if you ask me what this team is doing, working with me, is really building the nation with infrastructure for research, education, and then in partnership with the global companies who believe we can provide a sustainable path for manufacturing, having developed these technologies initially, but bringing the supply chain ecosystem from around the world. We have many of them in this room here. We think we can bring India to a level where we can provide a sustainable path connecting to where Gujarat is today. Okay, as you all know, those technologies are legacy nodes, whereas the rest of the world is working towards what I call 2030 manufacturing technologies, like chiplet-like packaging, 3D packaging, hybrid bonding, co-packaged optics, on and on and on. So that's the focus of the IDSPS team. So as we bring those technologies to manufacturing, you can see how we can bridge the gap between what's going on in the rest of the world and what's going on currently in Gujarat. Thank you very much.
Thank you so much, sir, for your enlightening address and for sharing your wealth of knowledge with us. Next, we are privileged to have with us Mr. Ang Wee Sang, Executive Director, Singapore Semiconductor Industry Association. His expertise in the semiconductor industry has been instrumental in shaping its global journey. Sir, we invite you to share your thoughts with us. Please help me welcome Mr. Ang Wee Sang, Executive Director, Singapore Semiconductor Industry Association. Welcome, sir.
Good morning, distinguished guests. A special thanks to Ashok, the president of ISA, for inviting me to give this special keynote message. Now, today I'm going to talk about Singapore and India partnership. Singapore is a global semiconductor hub. Our journey began in 1968 And over the past 57 years, we have steadily moved out the value chain from packaging and testing to becoming a critical hub that contributes approximately 12% of the global semiconductor sales. Beyond that, Singapore manufactures over 20% of the world's semiconductor equipment. More importantly, with more than half a century of industry development, we have built a resilient ecosystem of small medium enterprises, or SMEs, that support semiconductor industry, not just in Singapore, but across the region and the world. I would like to convey 3 points in my speech today. I'll start off with this statement. No nation builds semiconductor industry alone. The future of semiconductor is not about competition, it's about collaboration. And today, Singapore and India stands at the crossroad of an extraordinary opportunity. So that leads to my first point, strengthening the Singapore-India semiconductor partnership. For decades, Singapore has been a trusted global hub for semiconductor manufacturing, advanced R&D, and industry innovation. We are home to leading semiconductor giants, a thriving network of startups, and a strong supply chain ecosystem. India, on the other hand, is on the rise. It is a nation with immense engineering talent, a rapidly growing electronics market, and a strong government support for semiconductor development. Singapore and India are natural partners. The question is not if we should collaborate, but how we can accelerate this partnership to build a stronger, more resilient semiconductor industry that benefits not just our nation, but the entire world. And that leads to my second point. How do we accelerate this partnership? Partnerships are not built just on agreement alone. They thrive on people, leadership, and most importantly, business synergies. To make the collaboration real and impactful, we must focus on actions that drive tangible results. Take, for example, the backbone of the semiconductor industry, talent. A workforce exchange program could accelerate the development of highly skilled engineers, bridging expertise across borders and strengthening both nations' semiconductor industry. Another example is the cross-pollinating of our industry leaders at both countries. A strong industry needs strong visionary leaders through joint leadership development programs, mentorship initiatives, and industry roundtables. Singapore and India can develop globally adaptable executives who understand both markets and can drive semiconductor growth on an international scale. SSI and IESA will work together to accelerate this development of our industry leadership. Lastly, on business collaboration, we need more platforms such as this Vision Summit, where business leaders, policymakers, and innovators can come together to unlock new opportunities. For India to accelerate its semiconductor ambition, companies can tap into Singapore's robust ecosystem, leveraging our advanced manufacturing capabilities, cutting-edge R&D, infrastructure, and most importantly, the global supply chain networks. By integrating talents, leadership, and business collaboration, we don't just create partnerships, we create progress. And that leads to my last point, a call for action, moving from potential to progress. The semiconductor future is borderless, and it starts with a decision we make today. In July last year, SSI and IESA signed an MOU to strengthen collaboration between our semiconductor and electronic sectors. We are focused on business-to-business collaboration, talent development, and leadership growth. This partnership is important as a milestone, but milestones alone do not build the future. The real impact will come from both bold actions, stronger industry ties, and most importantly, a long-term commitment to this collaboration. Imagine a future where Singapore and India co-develops the next generation of semiconductors, a future where our engineers, researchers, and business leaders work seamlessly across borders, driving innovation together, and a future together we will strengthen the supply chain resilience, ensuring the world has access to the chips that powers the future. This is more than just a partnership, it is a shared journey. So my closing message is this. The future of semiconductor belongs to those who build it together. Singapore and India have a talent, ambition, and opportunity to lead. But partnerships don't succeed in theory. They succeed in actions. So let's take that action today. Let's accelerate this journey. Let's shape the future of semiconductor together for the world. Thank you.
Thank you very much, sir, for your invaluable insights and for shedding light on the evolving dynamics of the industry. And now we have the distinct pleasure of welcoming Mr. Jordan Wu, co-founder and CEO, Himax Technologies, Inc., a visionary leader whose contributions have significantly influenced the technology landscape. Sir, we look forward for your address. We welcome you. It's just the morning. We should be a little high on spirits, so please help me welcome Mr. Jordan Wu. Thank you.
Distinguished guests and my friends in semiconductor and high technology industries, good morning. These are truly exciting times for India, a country with a vibrant economy, empowered by the world's largest population, which represents an unlimited market potential, and enormous young and yet largely untapped talent pool. Just look at this platform, right? And look at all these people. And I just saw the earlier speeches made by my fellow semiconductor companies, and the video and academia and people from all over the world. I can sense the rhythm, the pulse of the industry, of the economy, of a country which is eager to move on, and led by the government, which has great vision, a very ambitious plan, and roadmap to lead the country towards the next powerhouse of technology of the world. So on behalf of Himax, I'm very, very honored and excited to be here. Actually, in a short while, we are going to take advantage of this platform to announce a three-way partnership with Tata Electronics and my fellow semiconductor company, PSMC from Taiwan, and ourselves, where we are going to bring together the strengths of the three parties, with Tata Electronics having its manufacturing muscle and local presence, and PSMC, our long-term partner, bringing the foundry manufacturing expertise and know-how, and Himax, as a design company, bring our IC design expertise. So thank you very much, Reindeer of Tata Electronics, for inviting Himax to the Semiconnect today. And thank you, Martin of PSMC, for bringing us together. I'm thrilled about our three-way partnership, and I'm looking forward to a long, exciting, and rewarding journey together. Now, if I may, I would like to quickly introduce Himax and share a few of our product areas with you, in particular, products and technologies which we are eager to bring to the Indian market and have them made in India through the Tata PSMC Himax partnership. Himax is one of the largest and leading fabless IC design companies in Taiwan, which I helped co-found in 2001. We specialize in image processing related semiconductor technologies, and is a global leader in ICs which empower all kinds of displays. We've been shipping over 1 billion chips a year for many, many years in a row. And in the past few years, our presence has been particularly significant in displays inside vehicles, inside your vehicles, where we are the #1 in the world with over half the global market share. As displays, flat panel displays are now everywhere in our daily life. In fact, you likely have actually used many of our products without realizing it, as they are built into your TVs, computers, smartphones, cars, e-readers, or for that matter, perhaps even the ATM machine I just came across in this conference center. In making these chips, PSMC has been one of our key foundry partners, and we've been working together for exactly 2 decades. Hand in hand, we have manufactured and shipped many billions of ICs, covering a wide variety of applications. Looking forward, our joint mission is to duplicate our success in Taiwan by making billions more ICs together. Only this time, they will be made in India. Together with Tata Electronics, we'll be selling those ICs not just to the Indian market, but all over the world. Next, I would like to touch upon our presence, our exposure in AI. As we all know, these days, you really cannot talk about technology without talking about AI. Our presence in AI today is in 2 very, very different areas. In the very high-end, high-performance computing AI used in data center, Himax, in partnerships with world-leading foundry and AI semiconductor players, is playing a critical role in enabling the upcoming CPO, or so-called co-packaged optics technology, by offering our state-of-the-art expertise in WLO, or wafer-level optics. The realization of CPO will help substantially elevate data transmission bandwidth and bring down power consumption, 2 of the most critical challenges faced by the AI industry today. Another area of our AI technology that is perhaps more relevant to India today is a unique ultra-low power AI image sensing total solution, for which we have a trademark called WiseEye. WiseEye is a cutting-edge endpoint AI integration featuring our proprietary ultra-low power AI processors, always-on CMOS image sensors, and advanced CNN-based AI algorithms. In the rapidly evolving AI landscape, WiseEye technology stands out for its ultra-low power consumption, measuring merely single-digit milliwatt, making it the only one of its kind in the whole world today. This opens the door for battery-powered endpoint devices to incorporate AI sensing, something otherwise impossible without such extremely low-power AI. By working with ecosystem partners, we are expanding WiseEye AI applications aggressively, now covering areas such as computer, automotive, smart home, smart city, office, factory, retail, healthcare, agriculture, and a host of other AI applications. As an illustration of our capabilities, by consuming just single-digit milliwatt of power, our WiseEye solution can do people counting, gesture recognition, and even perform state-of-the-art palm vein, and face authentication with the highest level of accuracy and security protection. To complete the story of our WiseEye, you actually don't have to be a skilled programmer to use our WiseEye, because we offer a very user-friendly no-code AI development environment. To help AI product developers reduce cost and short-term development lead time. Our WiseEye AI also comes with hands-on open source AI frameworks, tool chains, and robust AI models applicable for many, many different real-life applications, with the number of applications still expanding rapidly as we speak right now. So I believe it is through technologies such as WiseEye that we can work closely with many, many partners in India, a country with a global reputation for smart engineering talents, software engineering talents in particular. I'm convinced in this new era of AI everywhere, we can further our collaboration by taking advantage of the strengths of our two countries, with India offering software talents and an enormous market potential, and Taiwan being the global leader in semiconductor. Finally, I look forward to making our first chips in the very first commercial semiconductor fab in India, right here in the great state of Gujarat. Thank you.
Thank you, Mr. Wu, for your profound insights and for inspiring us with your visionary leadership. Now it's a moment to welcome, a formal welcome to the esteemed dignitaries gracing the dais today. Their presence underscores the significance of this event and reflects their unwavering commitment to fostering innovation and industrial excellence. I would humbly and with pleasure and pride welcome on stage Her Excellency Marisa Gerards, Ambassador of Kingdom of the Netherlands to India. Welcome, Madam. We also welcome on stage Mr. Ajit Manocha, President and CEO, Semi Global. Welcome. Mr. Sushil Pal, CEO, ISM. Mr. Ramesh Kannan, Managing Director, Kaynes Technology. Mr. Randhir Thakur, CEO and MD, Tata Electronics. Mr. Matt Crawley, EVP, Global Business Unit, Jabil. Mr. Gursharan Singh, Senior Vice President, Micron Technology. Mr. Lars Rega, Executive Vice President and Global CTO, NXP Semiconductor. Mr. C.S. Chua, President and MD, Infineon Technologies Asia Pacific. Mr. Ashok Chandak, President, ISA. Mr. Girish Chandra Chaturvedi, Chairman, Cephas Semi Private Limited. Mr. Jordan Wu, Co-founder and CEO, Hymex Technologies. Professor Rao R. Tumala, Advisor, ISM. Mr. Martin Chu, President, PSMC. Mr. Angwi Singh, Executive Director, Singapore Semiconductor Industry Association. Welcome. Welcome, esteemed dignitaries. And those who are in the hall, our Honorable Chief Minister, sir, will arrive in a moment from now. So you are humbly requested to kindly take up your seats, please. Those who have joined us late, put your mobile phones on silent mode or vibrating mode. Thank you. Those whose name have been taken and they have not been on the dais, we humbly welcome them. Please take up your seats on the stage. We now wish to welcome our esteemed guests on the dais. Our Honorable Chief Minister, Sir, of Gujarat, Shri Bhupendra Bhai Patel, has arrived over here and he is currently inaugurating the exhibition. We also welcome on stage JETRO Chairman. Welcome, sir. We welcome Mr. Ishiguro Norihiko, Chairman and CEO, JETRO. Welcome, sir. You can see on the screens that Honorable Chief Minister of Gujarat State has arrived. Yes, we can extend our good wishes sitting here. Thank you. Ladies and gentlemen, our Honorable Chief Minister of Gujarat, Shri Bhupendra Bhai Patel, has recently inaugurated the exhibition and he'll be over here in the dome. When he arrives in the dome, we request everyone to kindly rise up and greet him and other dignitaries. Also, those speakers who are on the stage, you're requested to use this podium for your speech. That is exclusively for Honorable CM Sir. Thank you. Ladies and gentlemen, please help me welcome Honorable Chief Minister of Gujarat, Shri Bhupendra Bhai Patel. Sir, it is indeed our pleasure to have you over here on this momentous occasion. We also welcome Chief Secretary, Government of Gujarat, Shri Pankaj Joshi, and Ms. Mona Khandar, Principal Secretary, DST, and other esteemed dignitaries on this occasion. Welcome, sir. Thank you. We also acknowledge the presence of Shri Hasmukh Arya, Chief Advisor to Honorable CM Sir, and Mr. M.K. Das, ACS to CM Sir. Distinguished guests, industry leaders and visionaries, as we gather here at the crossroads of technology and opportunity, it is time to officially commence the conference with our welcome address. To deliver the welcome address and opening remarks, I'm honored to invite on stage Ms. Mona Khandar, IS, Principal Secretary, DST. Welcome, ma'am.
Namaste and good morning. It's my distinct privilege to extend heartfelt welcome to this gathering of visionary leaders and esteemed dignitaries. Honorable Prime Minister of India, Shri Narendra Modi, has given the clarion call of Viksit Bharat by 2047. In the wake of emerging geotechno-economics, there is a remarkable shift in India's erstwhile service-led growth strategy, paving a way for a more balanced outlook that focuses both on high-end manufacturing as well as services. In order to achieve this, Honorable PM announced one of the most ambitious semiconductor policy of India. Committed to Viksit Bharat through Viksit Gujarat, Honorable Chief Minister of Gujarat announced the first state-specific proactive semiconductor policy. It provides for capital assistance up to 20% of eligible project cost. Gujarat policy also offers fiscal support for land and operational expenditure. It is my proud privilege to welcome the visionary Honorable Chief Minister of Gujarat, Shri Bhupendra Bhai Patel. He has put in place a policy framework of Gujarat Electronics policy, IT-ITS policy, biotechnology policy, and Gujarat Global Capability Centers policy. This further supports semiconductor sector by incentivizing downstream applications, design, research and development centers for the semiconductor ecosystem. Being well aware that high-end semiconductor manufacturing is a way more demanding than robust fiscal support, Gujarat has adopted three-pronged strategy, which also includes building world-class infrastructure and capacity of human resources. State-of-the-art Semicon City at Dholera and Semicon Cluster at Sanand are pivotal to this strategy. Among the best for law and order, women's safety, and cities' livability. Gujarat has also fast-tracked setting up of Taiwan Desk, International Tent City, and social infrastructure in Dholera and Sanand. I'm honored to welcome Chief Secretary of Gujarat, Shri Pankaj Joshi, who is guiding us through this strategic journey. This conference will be hugely benefited by the gracious presence and insightful address of Mr. Krishnan, Secretary Meiti tomorrow. I extend a warm welcome to him and CEO ISM, Mr. Sushil Pal, for being a strong support to us. Gujarat has received tremendous response from global semiconductor leaders, with the number of semiconductor companies growing from 1 to 6 in just 1 year, taking the total investment to over rupees 1.25 trillion. This growth demonstrates investors' confidence in Gujarat's potential. I extend a warm welcome to anchor investors, Shri Gurcharan Singh from Micron Technology, Dr. Randhir Thakur from Tata Electronics, the technology partner, Mr. Martin Chu from PSMC Taiwan, their valued customer, Mr. Jordan, CEO Himax Technologies, Shri Girish Chandra Chaturvedi from CG Semi, Shri Ramesh Kannan from Kaynes Technology, Mr. Matt Crawley from Jabil, and Mr. C.S. Chua from Infineon. I extend a special welcome to Her Excellency Marisa Gerards, Ambassador of the Kingdom of the Netherlands to India, Mr. Ishiguro Norihiko, Chairman and CEO of JETRO. I'm pleased to welcome 6 foreign delegations and global industry leaders from NXP, Singapore Association, and others. I would also like to welcome all the state and central government officials present here today. Their relentless support in facilitating anchor investors and resolving their teething problems have been tremendous, especially for providing logistics, infrastructure and utility facilities, and granting customs and environment-related clearances. I warmly welcome the local industries present today, who are going to be an integral part of electronics and semiconductor value chain. Gujarat's homegrown industries like machine tools, chemicals and gases, logistics, renewable energy are of international repute. Linkages and collaborations with local industries will enhance efficiency of the local and global value chain. I extend a heartfelt welcome to entire academia present here today. Gujarat boasts of annual passing out of more than 100,000 engineers, STEM graduates, and diploma holders from more than 100 STEM institutions. They are reorienting their academic programs and partnering with anchor investors for industry-specific skilling, research, and development. I warmly welcome our conference partners, Mr. Ajit Manocha, CEO and Chairman, Semi International, Mr. Virappan, Mr. Ashok Chandak from India Electronics and Semiconductor Association, and Dr. Rao Tumulla, India Design Semiconductor Packaging and Systems. I would also like to welcome all the friends from print, electronic, and social media. I'm confident that Gujarat SemiConnect will be a catalyst for collaboration, inspiring innovation, and a significant contributor to India's journey as a global semiconductor leader. Thank you very much.
Thank you, ma'am, for setting the stage with your insightful words and for reinforcing Gujarat's commitment to driving innovation in the semiconductor space. After the warm welcome words, we would like to welcome our esteemed dignitaries. Foremost, I request Ms. Mona Kandar, ma'am, to kindly welcome Honorable Chief Minister, sir, with the Tulsi sapling. Thank you, and would now request ma'am to kindly welcome Chief Secretary, sir, Shri Pankaj Joshi. Thank you very much. Ladies and gentlemen, it is now time to hear from some of the most influential voices shaping the global semiconductor ecosystem. Their insights will guide us in navigating the challenges and opportunities of the industry. I now invite Shri Sushil Pal, CEO, ISM, to share his thoughts with us.
Thank you. Honorable CM of Gujarat, distinguished dignitaries on the dais and in the audience, industry leaders and delegates from various countries, ladies and gentlemen. It's indeed a matter of pride and privilege for me to be addressing this gathering. Many congratulations to the government of Gujrat Semi and ISA for organizing an event at this scale. I will begin with a few numbers. India ranked 11th in terms of the GDP in 2012, and it climbed 6 positions to become the 5th largest economy in 2024. Electronic exports ranked as the 12th largest sector for exports, amounting to $6.4 billion in 2017, and constituting only 2% of India's total export of approximately $300 billion. It climbed to become the 5th largest export sector in 23-24, exporting approximately $29 billion, constituting almost 7% of the total exports. And in the current financial year, in the first 10 months, it is already the 3rd largest export sector, beating the gems and jewelries to the 4th and the 5th position. Therefore, there is a strong linkage and a very positive correlation between the electronics and semiconductor manufacturing and India's rise to become the 3rd largest economy as envisioned by our Honorable Prime Minister. Semiconductor and electronic manufacturing sector have to power this growth of an Indian economy to make it the 3rd largest economy in the world. Honorable PM has set us the target of achieving $500 billion electronic manufacturing by 2030-31, out of which semiconductor itself would constitute approximately 25%, approximately $100 billion. With a strong manufacturing focus, because manufacturing is actually the engine of growth for any economy, and this engine, because the manufacturing drives the per capita income and export earnings, and also employing a substantial size of the population having diverse skill sets, and has a huge multiplier effect on the related sectors and services as well. Electronic manufacturing, it forms the most important segment of the manufacturing because of its market size, because of its high growth rate, because of a high potential of employability, and tremendous positive externality, and also because this is the most traded commodity globally. Semiconductors are the foundational industry and the building blocks of almost every electronic item. These tiny chips play an indispensable role in shaping the various spheres of our modern life, be it industrial, consumer, communication, defense, automobile, or computing devices. Reinforcing this vision of Atmanirbhar Bharat, India is committed to the development of semiconductor and display manufacturing ecosystem and deepen its value chain to facilitate a world-class semiconductor manufacturing ecosystem and infrastructure. Policies and efforts are already underway to develop a complete ecosystem, which would include the equipment, raw material, and gases, etc. as well. India offers multiple opportunities for the global investors to invest here. It provides the most vibrant democracy in the world, a young and a talented demographic profile, a very clear and unambiguous policy, complete support both by the federal and the provincial government, low labor cost, strong infrastructure, and a huge domestic demand, and also because of the efforts of our Honorable Prime Minister, is one of the most trusted global partner in the world. Through this Semicon India program, with a $10 billion incentive, government has set a transformative course, turning ambitions into action. And so far, we have already attracted the investment of more than $18 billion under Semicon 1.0. And what better place to invest in India other than the Gujarat? Gujarat has been a pioneer in enabling policy environment, not only to semiconductor industry, but for other sectors as well. Gujarat, driven by the strong and the laser-focused administration, under Honorable CM, was the first state to come out with a semiconductor policy and has emerged as the first semiconductor hub in the country with multiple projects coming up. Gujarat can also pride itself in the fact that India's first chip would actually be coming out of this state, and thereby truly completing this journey of charkha to chips in actually a true sense. Many states have actually learned from this, from the initiative of Gujarat and have tried to actually emanate the policy initiatives taken by the state, and I commend the state for their leadership. This event itself is a testament to the traction and attraction of the industry for setting up the semiconductor ecosystem in the country. In the current geopolitical environment, which is highly competitive and highly fragmented, and where a few states don't hesitate to weaponize the technologies, the semiconductor value chain has to be highly resilient because it guarantees not only economic growth, but also national security. Therefore, it is not just an economic opportunity, it is a strategic imperative, and we invite you all to be a part of this shared journey. Thank you.
Thank you very much, Mr. Pal, for your invaluable insights. Your words will surely inspire new initiatives in India's semiconductor industry. Up next, it is my privilege to invite Shri Ajit Manocha, President and CEO, Semi Global, to share his vision with us. Welcome, sir.
Good morning and namaste. 2 years ago, on this platform, we celebrated the first announcement of Micron as the first anchor investor in state of Gujarat. Subsequently, Tata and 4 more, I think you heard the name so many times, so I will not repeat. And thanks to the leadership of the Prime Minister Modi ji and the Chief Minister Shri Bhupinder Bhai Patel ji and the staff from the Gujarat state, and that leadership is really showing results, but we cannot stop here. Last year at Semicon India, the inaugural Semicon India in New Delhi, Noida, Modi ji talked about the future. He also talked about Moore's Law on this platform 2 years ago. He said, our country should progress just like the Moore's Law helped progress the semiconductor industry. And I mentioned to him privately at that time, the way he said in Hindi how India should progress, I translated that to Modi's law of exponential growth during September Semicon in Noida last year. Now, those are good words to say. Moore's Law, when it came about, people did not know at that time the impact of the Moore's Law. Without Moore's Law, we would have not been where we are today. And similarly, the impact of Modi's law of exponential growth, it will not mean anything unless there are some actions. For Moore's Law, the actions were done by the industry. For the Modi's law of exponential growth, the actions have to be happened by the state governments, the people of India, and the people of the industry. Now, our industry is at a critical juncture. Unprecedented opportunities, unprecedented supply chain disruptions, and unprecedented geopolitical issues, or I could call it unprecedented uncertainties. Now, I said that word in September. Since September, I think we can say unprecedented opportunities raised to the power X based upon the election outcomes in many countries. And you know what I mean. Now, how do you navigate yourself for these kind of disruptions? While there are opportunities, we cannot really stand back and say things will work out. No, it's not, they're not going to work out. Industry is going to grow from $620 billion IC revenue last year to $1 trillion in next 6 to 7 years. The real question for all of us as fellow Indians is how much share we want for India. It is only up to us. Now, why this is so important? I mentioned it before, I'm going to say it again. The time has come that we need to grow more powerhouses of semiconductors in the world. Otherwise, our supply chain will never become resilient. And India has demonstrated to be the right country And of course, Gujarat has demonstrated, I'm sure other states will come up within the country. It's a large country and a lot of opportunities. It will not dilute Gujarat. It will not dilute India. It will make India stronger. And that is happening, exactly that's happening in the US. Everything was in Silicon Valley, now it's getting into the Midwest and other parts of the US. Last year at Semicon, the inaugural Semicon, we had unprecedented performance. We had 675 booth exhibitors from 100-some countries, and we had 130, 140 CEOs and CXOs from the entire value chain of semiconductor, and that has never happened in any part of the world. First time happened in India. And almost everybody, all executives, when they went back, they told me, we are believer of India. We will invest in India and will make India the next powerhouse. Semi did Semicon 24, and now we're going to do Semicon 25 on September 1, 2, and 3 in Yashobhumi, Delhi in this year. And we brought the ecosystem. That's our core competency. We enable ecosystem. We have been the witness or in the making of South Korea, Taiwan, Japan, China, and now India. And we are also very fortunate that we have boots on the ground. ISA, which is a very established association here, and the Vision Summit is the signature event of them, which is happening today. They have joined as family of Semi. And now the boots on the ground, we're going to make Semicon India 25 even bigger than Semicon India 2024. So with that, I'm going to say 2 or 3 messages. So we talk about what market share we want for India. And the number one focus should be ecosystem in the country. Without ecosystem, my friends from Tata or Micron or Kaynes, you name it, they will all struggle. We cannot afford any setback for any of these anchor investors in this country, because that will send a bad news around the world. This is important for the people of India to make sure that these investors are super successful with unprecedented success, because that's really the name of the game. Now, this morning, one of the speakers said, I'm from Bangalore. Actually, we don't start in Bangalore until 10 o'clock. And then once somebody spoke from Gujarat, says, I'm from Gujarat. We start at 8 o'clock. My friends, I'm from Silicon Valley. We don't sleep. We only sleep for a few minutes to dream. Keep dreaming, so sleep less, but keep dreaming for the next future of India. And the second message I want to give you is execute, execute, execute. Without execution, our investments, all our vision will go nowhere. So this is my message to all of you, to make India the next powerhouse that's good for the country, good for the world, and good for the humanity. Thank you very much. Thank you.
Thank you very much, Shri Ajit Manocha, for your inspiring words and for guiding the industry with your global expertise. ISA is regularly doing the research reports on the ESDM sector in India. Those are highly valued in the industry. ISA's core team prepared the comprehensive report on the semiconductor manufacturing supply chain. I humbly request Honorable Chief Minister, Sir, to kindly release the report prepared by ISA on manufacturing supply chain, and also the esteemed dignitaries are requested to join for the same. Thank you very much. Let us move ahead with the Make in India product launch. Now, in order to talk about this, I would welcome Mr. Ashok Chandak, President, ISA. Welcome, sir.
Honorable Chief Minister of Gujarat State, dignitaries on the dais, and dear friends. It's a wonderful morning and a great thing moving. Actually, we spoke in the morning as well. You know, ISA Vision Summit usually paints the vision, the future, what's going to come and what needs to be done. But it's not only important to have the vision, but also look into how the reality is turning out, and it's an exciting journey. Any successful milestones are very, very important. And as all you know from the industry, as the industry stalwarts, India takes pride in a great design ecosystem. But at the same time, we know we have a weakness in manufacturing. Thanks to Honorable Prime Minister of the country, Mr. Modi, also Gujrat CM and the policies, we have a real breakthroughs of several manufacturing plants coming up. But still, it's very important to understand and see whether we are turning this vision into a reality. And that is where ISA, who has been working on not only vision painting, but also looks into how do we get it into the reality. And today we have 5 companies. Those are going to showcase their products, which have been already realized in the country. And I would invite all of them together. Actually, I would just announce the name and I request them in view of time to come together. So first is TISOL, Mr. Srini. TISOL now has become the world's largest independent semiconductor test company. And they have announced a new plant. Their turnover goes more than 1,000 crore, very unique out of India. And they announced a new plant and they have set up now the new machines, very innovative tools. Those will cater to their global demand of almost every semiconductor company they touch as a customer. That's number 1. Number 2, we have Suchi Semicon from the city of Surat, who is setting up their OSAT facility. They already realized the first SOIC chip, which has been realized, and that would be shown as a demo, as a showcase. Plus, they are going to do the mass production by month of April or May, that time frame. Third one, we call Fermionics, Mr. Gautam Singh. They have worked on the beamformer IC, very complex design, complete design and complete prototyping, including the architecture. Obviously, the manufacturing happens outside of India because of the foundry requirement. That's number 3. Then we also invite Mr. Raj Chodankar from RRP Electronics. They have done the QFN package, which is very innovative and also realizing it. I request all the colleagues here to come on the stage and showcase their product, please.
Gentlemen, you can move with your products for the product launch. All of you can move further.
And also we have Polymatic, the company located in Kanchipuram in South India. Those are doing the silicon sapphire ingots as well as the 6G telecom die. Thank you, friends. Thank you very much. So that's one of the showcase of the vision to reality, and this will continue further. India, with the contribution from all of you, we are going to accelerate our journey on the manufacturing excellence. I'll just take another 20 seconds more. The supply chain report, which is mentioned already, has looked into much detail about the requirements for gases, chemicals, materials, minerals, and many things. We estimated that by 2030, the market size will become about 400 billion plus, and aspiring to take a 10% market share, we have an opportunity of $40 billion. It's all yours. Thank you.
Thank you so much, and we extend our good wishes to all of the people out here. Now I invite Mr. Gujrat Semi, SVP, Micron Technology, to the stage to deliver his address. Welcome, sir.
Bhupinder Bhai Patel ji, Pankaj Joshi ji, Madam Mona Kandhar, Sushil Pal ji, and all other dignitaries, industry leaders, and esteemed guests. Namaste and good morning. So firstly, to Bhupinder Bhai Patel ji, Micron is executing very, very well. Team Micron, do you agree? Oh, good. So this execution is coming with tremendous support from various agencies, various partners, and my special thanks to Sushil ji, Mona ji, and Mr. Joshi for all the help and especially the push. Appreciate very much. So I first want to express our thanks for Prime Minister Modi ji's dedicated vision to strengthen India's semiconductor ecosystem. I also wish to thank Bhupinder Bhai Patel ji for enabling the development of the semiconductor industry in Gujarat. Today, we look forward to your leadership in strengthening India's competencies in semiconductor manufacturing, product design, and R&D. Semiconductor industry needs are unique, and we appreciate government proactiveness in recognizing these uniqueness and enabling positive policy changes. I would like to thank the MITI, ISM, Ministry of Commerce, Ministry of Finance, the Customs and Revenue Departments, DST, GSEM, GIDC, and Revenue Departments, and all the other central and state government officials who are continuously supporting Micron and new and other upcoming semiconductor establishment ecosystem partners in India. Micron is one of the world's largest semiconductor company. We are the world leader in memory and storage solutions. At the heart of AI revolution, we see multi-year growth opportunities driven by various vectors, such as server to data center, PC to mobile, and automotive to industrial systems. Our investment in a state-of-the-art assembly and test facility in Sanand, Gujarat, illustrates our belief in India's critical role in global semiconductor supply chain. Today's world economy is driven by innovative technologies that make information more accessible. And Micron's memory chips are at the center of this revolution, accelerating artificial intelligence and enriching life for all. It is an honor for me to represent Micron here today among esteemed government and technology leaders to discuss opportunities to build and grow a strong semiconductor manufacturing ecosystem in India. As a company, we are optimistic about India and the specific opportunities it offers in the years ahead. We have made a promising start, but to continue this momentum, India needs further and focused government support. Over the next 20 years or more, years to broaden its role in global semiconductor supply chain. This includes providing incentivization schemes for manufacturing, research and design, and ensuring predictability in customs and regulatory frameworks, fostering international partnerships and adopting advanced technology will further enhance the global competitiveness of the toll manufacturing model. Higher incentives for made in India components and modules in production-linked incentive schemes to OEMs will encourage localization and increase value addition. Our assembly and test facility underway in Sanand is the first of its kind in India. The site will take advanced DRAM and NAND wafers from Micron's fabs and transform them into finished products, integrated circuit packages, modules, and solid-state drives. Not just for our customers here in Gujarat or India, but for the world. And Ma'am Marisa, that also includes Netherlands. Our facility in Gujarat will create 5,000 new direct Micron jobs, plus over 15,000 community jobs. This facility will be a tremendous complement to Micron's existing assembly and test sites in our network as we grow our capabilities to meet future demand. Micron's Sanand facility has catalyzed a cluster of semiconductor manufacturing investments in Gujarat. As these clusters develop, they require investments in physical infrastructure, logistics, special economic zones, and a skilled workforce to support a semiconductor manufacturing ecosystem. Micron has forged strategic partnerships with technical universities like NAMTech, PDU, PEC, and SEL to bridge the gap between academia and industry. Further, in collaboration with Learning Links Foundation and with the support of Niti Aayog and the Atal Innovation Mission, the Micron Foundation has established outfitting more than 2,000 government school students with advanced STEM learning tools, further strengthening our commitment to STEM education. Micron has also set up a state-of-the-art Micron STEM lab in Ahmedabad Science City, providing hands-on experimental learning for 2,700 underrepresented students in Gujarat. The semiconductor industry is both capital and resource intensive, and the construction of semiconductor facilities is unique and complex. This calls for highlighting opportunities to elevate skill sets and advancing the knowledge and capabilities required for constructing these advanced facilities in India. For India to continue developing its semiconductor ecosystem, it is imperative that semiconductor companies have access to quality, reliable power, and clean water. Equally critical is the development of civil infrastructure in Sanand, including convenient housing options for employees, high-speed rail connectivity, finished roads, public transport, hotels, international schools, and hospitals. As India continues to encourage global suppliers to consider localization, direct flight connectivity between Ahmedabad and established semiconductor hubs such as Taiwan, Korea, and Japan are essential to facilitate new investments. And we are very thankful for daily direct flights between Ahmedabad and Singapore. Seamless knowledge sharing and collaboration with overseas partners is very critical. Our collective vision for Gujarat as a pivotal hub for semiconductor manufacturing depends on developing robust infrastructure, a strategic procurement, supply chain, stringent compliance standards, and a continuous focus on capacity building. Together, we can and we will build a thriving semiconductor ecosystem that not only meets global standards, but also drives innovation and economic growth in India. Thank you very much.
Thank you very much, Mr. Singh, for Micron's commitment to India's semiconductor ecosystem. Moving ahead with the MOU exchange between the Government of Gujarat and Micron Semiconductor Technology India. For the same, we invite Ms. Elizabeth Olroy, Vice President Global EHS and Sustainability, Micron, to exchange the MOU, and Mr. Amrinder Sidhu, Director Assembly, Test and NMS Legal. We welcome you.
As a global technology leader, Micron manufactures some of the world's most cutting-edge memory and storage solutions. We are excited to grow our manufacturing footprint in the vibrant region of Gujarat, India, where we're building a state-of-the-art assembly and test facility, the first of its kind in the country. As we focus on our expansion activities in India, we are proud to sign this MOU anchoring on 3 key initiatives. First, our commitments around environmental stewardship and the benefits that we will bring to this community as we invest in sustainability. Second, our commitment to the safety anchor of our Live Safe program, based on the premise everyone deserves to go home safe every day. And third, bringing Micron's STEM education efforts to the local area as we develop the workforce of the future right here in India. We are dedicated to these initiatives at Micron, and we are excited to collaborate with our government partners as we grow our presence in Gujarat.
Can we extend congratulations to them? Thank you very much. I now invite Mr. Girish Chandra Chaturvedi, Chairman, CG Semi Private Limited, to share his insight with us. Welcome, sir.
Thank you. Honorable Chief Minister, Government of Gujarat, other dignitaries on the dais. Ladies and gentlemen, it's a great pleasure for CG Semi to be part of Semiconnect 2025. It is one of the largest semiconductor conclave in India. CG Semi is one of the youngest but most ambitious companies of Murugappa Group. Post-COVID, when India geared up to Honorable Prime Minister's vision of becoming a self-reliant in semiconductors, the group decided to contribute to this ambition by entering semiconductor manufacturing. With a 120 years legacy of establishing factories across India, the group has deep knowledge of the manufacturing ecosystem but needed expertise in technology and manpower. It onboarded Renaissance, a leader in microcontrollers and automotive solutions, as technology partner for advanced package and anchor customer. To accelerate manpower development, it partnered with Star Microelectronics for skill development and technology transfer. It was founded in March 24. We were inspired by Honorable Chief Minister's vision of establishing a semiconductor cluster in Gujarat and decided to establish it here in Sanand. As we all know that establishing any business, and particularly this one, in a new region requires strong initial support from both the central and the state governments in all areas like financial, non-financial, and operational assistance. The nodal agencies, ISM and DST in Ahmedabad, they have been very actively engaged with us. ISM is Government of India's agency. They offered essential administrative support in all respects. Almost every officer across the department from headquarters at Gandhinagar to field offices in Sanand had a critical role in fast-tracking our project. For example, GIDC proactively addressed land-related issues while GPCB expedited the necessary permissions. We are grateful, very grateful for your continued commitment to advancing semiconductor industry, and we trust that this invaluable support will continue. CG Semi is building a production facility in 2 phases, a mini plant and a main plant. Mini plant will be completed in coming months and production will start in 2026. The main plant will be completed in 2026 and the production will start in 2027. We all agree that the future of semiconductors in India is promising, and in a few years we will have a few OSATs and a fab in the country. To build a complete ecosystem, we need to have definitely 2 key developments to come along. One is the supply chain and the other is the talent. What I have heard here since morning, it is very gratifying that the government of Gujarat has already taken initiatives to develop these 2 areas. Gujrat Semicon 2025 will definitely play a key role in fostering collaboration among semiconductor companies, research institutions, universities, and supporting industry. Over the next 3 days here in Semicon, we will all ideate on developing the semiconductor ecosystem and lay the foundation stone for making Gujarat the epicenter of global electronic manufacturing industry. Thank you very much.
Thank you very much, Mr. Chaturvedi, for your insights on the evolving semiconductor landscape. Next, I invite Mr. C.S. Chua, President and MD, Infineon Technologies Asia Pacific, to share his perspective with us.
Honorable Chief Minister of Gujarat, ladies and gentlemen, good morning. As you know, water, especially the clean water, is a source of life. And today, in the modern world, electricity, as well as especially the clean electricity, will be essential to improve the quality of life in the modern world. Do we have the slide? It's working?
So you can just speak next and they'll do for you.
Ah, okay, sure.
Okay.
So, Infineon, and as you know that semiconductor will be an essential part of the modern life, because as you know that even in the hall today, whether it's the lightings, the LED, or the air condition, has improved the quality of our life. And semiconductor is an important element that contribute to the modern lifestyle that we have today. And Infineon is developing power electronics semiconductors that enable clean, safe energies. And we have basically three areas that we are addressing. One is on the mobility, on clean and safe vehicles. And second one is on the production of energy, the renewable energy, where our semiconductor enable clean and green energy. Last but not least, there is where all the electricity come into our household, where we use our modern equipment, whether it's home appliances, IoT devices, that require energy as well as a smart, secure element that enable us to use our IoT device in a safe environment. So as you can see that the modern lifestyle that we have today require a lot of usage of semiconductor. And today we are not new to India. In fact, we have been here for almost 30 years with more than 2,500 employees located in India. And we have been working with our ecosystem partner, whether it's a research institution, whether it's a startup, whether it's the partners that we have in India. And we will continue to do that in order to support the Visit Bharat 2047 that will come into place in the next 20 to 30 years. With that, thank you very much.
Thank you very much, sir. We appreciate it. Now I invite Mr. Matt Crawley, EVP Global Business Unit, Jabil, to address us. Welcome, sir.
Namaste, and very good morning to Chief Minister Bhupendra Patel, Government of Gujarat, esteemed dignitaries, distinguished guests, fellow colleagues, ladies and gentlemen. It is truly an honor to be here today and have the opportunity to address you. We're all here because we recognize the transformative power of semiconductors in driving technological advancements and economic progress. Not only do semiconductors power everything from smartphones to advanced medical devices, but the industry drives innovation, creates high-value jobs, and attracts significant investments. As I was traveling here from the US this week, it struck me just how impressive Gujarat's ambition to grow its state economy to $5 trillion by 2047 really is. And that journey will have opportunities along the way. There will be challenges, but Gujarat's ambition hinges on its ability to harness the potential of semiconductors. Business-friendly policies is the first step towards laying a strong foundation. To that end, I commend the state of Gujarat for its efforts in ensuring conducive environments for doing business. From the ease of setting up a business to responsive support and accessing capital and labor, we have experienced firsthand the state's enthusiasm in welcoming multinational companies such as Jabil. Having skilled talent and partners will be another opportunity. For those who are new to us, Jabil's a global leader in engineering, manufacturing, and supply chain solutions to more than 400 of the world's top brands. From semiconductor equipment to servers, racks, data center power, liquid cooling, electric and hybrid vehicles in automotive, pharmaceutical delivery solutions, such as GLP-1 auto-injectors in healthcare, and humanoid robots in warehouse automation, we serve a diverse range of industries through our technical and design capabilities, manufacturing expertise, supply chain insights, and global product management expertise. Our operations in India began in 2003. Today, we employ more than 7,500 employees in India, and we have 140,000 employees globally. Over the years, we've established a strong presence, leveraging our expertise to drive innovation and excellence in electronics manufacturing, playing a significant role in the Make India initiative. Our efforts have not only created job opportunities, but have also contributed to the development of a skilled workforce in the country. As we look to the future, we're very excited to announce that we have plans to open a factory in Gujarat, adding to our network of more than 30 countries with factories and 100 sites globally. As part of that, we're very excited to announce an MOU specific to silicon photonics manufacturing in the state of Gujarat today. We believe, thank you, we believe photonics holds immense potential in advancing industries like autonomous vehicles, health diagnosis and treatments, as well as 5G networks and all the technology that supports artificial intelligence. Jabil's been a player in photonics, in the photonics space for more than a decade. Besides new product introductions, we have years of experience in designing photonic devices and systems, developing amplifiers, transceivers, and laser packages, as well as developing optical networking, prototyping, and large-scale manufacturing services, reducing time to market for photonic solutions in telecommunications, data communications, and artificial intelligence applications. This MOU underscores our commitment to the support of the nation's aspirations in growing its silicon photonic capabilities by contributing to the overall development of the photonics ecosystem in India. We're proud to be a part of this journey and look forward to working closely with the Gujarat state government and other stakeholders to realize the full potential of semiconductors and photonics in India. Together, we can build a brighter future driven by innovation, technology, and collaboration. Thank you very much.
Thank you very much, Mr. Crawley, for your valuable insights into the semiconductor manufacturing landscape. We now have a MOU with Jabil, headquartered in St. Petersburg, Florida, a trusted partner to over 400 top global brands offering engineering, manufacturing, and supply chain solutions. We call upon Mr. Matt Crawley, Executive Vice President of Jabil's Global Business Units, Mr. Debashish Chaudhary, Vice President and Country Manager of Jabil, India, to exchange the MOU with Mona Kandar, Principal Secretary, DST, and his team will join.
Welcome to Jabil, a global leader in technology, supply chain, and manufacturing solutions, driven by a dedication to solving complex problems for the world's top product brands. And you'll find us in more than 25 countries with over 100 sites and a diverse team of more than 140,000 employees. At Jabil, we provide solutions that make products a reality in just about every industry you can think of, from electric vehicles and healthcare devices to renewable energy and AI cloud data centers. From first concept to final delivery and beyond, we innovate with our customers across the entire product lifecycle. Through collaboration, we turn ideas into products that power our daily lives through expert design and engineering, advanced manufacturing, and a sophisticated global supply chain, all while ensuring products have a sustainable second chance at life via material recycling and reuse. With a network of sites and suppliers that spans the globe, we seamlessly blend cutting-edge technology with our expert knowledge to create smarter, more efficient processes, no matter where our customers are located. Together, we make anything possible and everything better.
Ladies and gentlemen, let's congratulate them, please. Thank you. I now invite Mr. Ramesh Kannan, MD, Kaynes Technology, to share his thoughts with us.
Honorable Chief Minister, distinguished guest, esteemed colleagues, ladies and gentlemen. It is an honor to stand before you today as we embark on a new chapter in Kaynes Technology's journey. For 3 decades, we have been a steadfast player in the EMS landscape, witnessing firsthand the transformative power of technology. We have seen industries evolve, manufacturing processes revolutionized, and the lines between the physical and digital world blur. Through it all, one thing has remained constant: our unwavering commitment to innovation and excellence. Today we stand at the cusp of another technological leap driven by the convergence of artificial intelligence and process automation with manufacturing. This fusion is reshaping the very fabric of how we design, produce, and deliver products. It is enabling us to achieve unprecedented level of efficiencies, precision, and customization. At Kaynes, we are all not merely observing this transformation, we are embracing it. Our expansion into OSAT and bareboard manufacturing is a testament to our commitment to staying ahead of the curve. We recognize that these are critical components in the semiconductor ecosystem, and we are determined to play a pivotal role in India's semiconductor revolution. This move aligns perfectly with our vision of becoming an integrated electronics solution provider. We are building a future where we can seamlessly cater to the entire spectrum of electronics manufacturing needs, from design and prototyping to assembly, testing, and packaging. We understand this journey will be filled with challenges, but we are confident that our experience, expertise, and unwavering commitment to innovation will enable us to navigate these complexities and emerge as a leader in this new era of manufacturing. I express my profound gratitude to our dedicated team, valued partners, and esteemed customers for their unwavering support. This journey would not have been possible without them. We at Kaynes Technology would like to thank Honorable Chief Minister Bhupender Patel ji, CEO ISM Sushil Pal ji, Mona Madam, CS Pankaj ji, Ajit from Semi, friends from Tata, Micron, and CG Power, Professor Rao, ISA team, and the various association organizers. We would also like to thank GIDC team, GSM team, and DST team for the help and support they have given. So far, I have to mention this, they have been very helpful, and we are really happy with the support we are getting from this team. We want to thank you, Dr. Rajul, BC GTU, Professor Kiran Amin from Ganpat University, Nandini Das Gupta ma'am from Namtech, Professor Rajat Mohana from IIT Gandhinagar, Professor Bosco from Shastra, Professor Nilesh from IIT. All the academia support what we are getting so far has been good, and we want to build our skills using all of them. Thank you once again, and thank you once again. The future of electronics manufacturing is intelligent, integrated, and innovative, and Kaynes Technology is proud to be at the forefront of this exciting transformation. Thank you.
Thank you very much, Mr. Kannan, for Kaynes Technology's role in driving indigenous semiconductor manufacturing. Now, a milestone moment as Kaynes sets for the foundation stone laying for a state-of-the-art semiconductor OSAT facility in GIDC Sanand. I request Mr. Ramesh Kannan, Promoter and Managing Director, Kaynes Technology, Mr. Raghu Panikar, CEO, Kaynes Semicon, to join, and humbly request Honorable CM Sir to unveil the plaque with the remote. Many congratulations. Thank you. And I now request Honorable CM Sir to hand over the foundation laying brick to Mr. Kannan and Mr. Panikar. Thank you. Mr. Raghu and Mr. Kannan, please stay back on the stage. Now let's take a closer look at the driving forces behind their vision, their innovative customer and technology partners, and the exciting construction timelines that are shaping their future. The announcement for the date of operation.
Kaynes Technology is an integrated electronic solutions provider valued at approximately $5 billion, have achieved a 40% plus CAGR in recent years with a global presence. We have partnered with the Indian government on strategic initiatives and are establishing the Ivara OSAT Semicon Center, a 1.80 lakh square feet facility with an annual capacity of 2.3 billion units. Today, Kaynes Semicon proudly announces that it will launch the pilot line in June 2025. We are expediting the qualification process to ensure a seamless transition to full-scale production line by January 2026. Kaynes Semicon is also pleased to announce another milestone, a significant partnership with Alpha Omega Semiconductor. The two companies have signed a multi-year, multi-million-dollar manufacturing agreement to assemble, package and test semiconductor products including power MOSFETs, IGBTs and IPMs. Uniting tech partners and supply chain to accelerate India's semiconductor innovation.
Let us now watch a video of Mr. Stephen Chang, CEO, Alpha and Omega Semiconductor, about their engagement with Kaynes.
AOS is thrilled to announce our newest partnership with Kaynes Technology to build a state-of-the-art manufacturing facility. This marks a major milestone in our journey to strengthen semiconductor manufacturing and innovation. AOS is thankful to Ramesh and Raghu for their leadership in forging this partnership together with AOS. This move is not just an expansion. It's a strategic step that aligns with our long-term vision of tapping into India's rapidly growing semiconductor market. India's booming electronics and power semiconductor market presents an incredible opportunity, and we are excited to partner together with Kaynes and our customers to drive cutting-edge advancements. With a strong focus on power semiconductors, this facility will play a crucial role in addressing EVs, renewable energy, and industrial applications, ensuring a robust, future-ready semiconductor ecosystem.
Thank you very much. Now let us invite on stage Mr. Madhur Bobde, the CTO of Alpha and Omega Semiconductor, and request Mr. Kannan and Mr. Panikar to exchange the agreement. Thank you and congratulations. Moving ahead, we now have a joint presentation of TEPL, PSMC and HiMax. Would foremost request Mr. Dr. Randhir Thakur, CEO and MD, Tata Electronics, to share his thoughts with us.
हमारे मृदु और मक्काम, humble and strong मुख्यमंत्री भूपेंद्र पटेल जी, Chief Secretary, Government of Gujarat, Shri Pankaj Joshi ji, CEO, India Semiconductor Mission, Shri Sushil Pal ji, Tata Electronics employees who are here today, esteemed dignitaries, friends from the industry, ladies and gentlemen, my congratulations to Government of Gujarat for hosting Gujrat Semi Connect Conference 2025. The Government of Gujarat, under the leadership of Honorable Chief Minister Bhupendra Bhai Patel ji, has taken decisive steps to establish a vibrant domestic semiconductor manufacturing ecosystem to fulfill Honorable Prime Minister's vision of Viksit Bharat. Honorable Chief Minister जी, व्यक्तिगत लेवल पे मैं आपका बड़ा आभारी हूँ कि जब भी हमने टाटा इलेक्ट्रॉनिक्स ने आपके पास कोई भी रिक्वेस्ट की, आपने हमेशा उस रिक्वेस्ट का अप्रूवल दिया. Thank you very much. Thanks to Chief Secretary, Government of Gujarat, Shri Pankaj Joshi ji, for the professionalism and execution focus demonstrated by multiple agencies of the Government of Gujarat. Principal Secretary, Department of Science and Technology, Srimati Mona Khankar ji, thank you for your continued support and dedication to the Gujarat Semiconductor Mission. I want to thank Ministry of Electronics and IT and CEO of India Semiconductor Mission, Shri Sushil Pal ji, for the commitment and leadership for India's semiconductor journey. It is now my privilege to introduce my dear friends and trusted partners, Martin Chu, President, PSMC, a veteran of the semiconductor industry with over 30 years of experience in semiconductor manufacturing. Jordan Wu, co-founder, CEO, and president, Himax Technologies, a leading display IC design company, probably the only customer on the stage today. Their expertise and collaboration will have far-reaching impact on India's semiconductor mission. Today, I'm delighted to announce a signing of a MOU between Tata Electronics, PSMC, and Himax to revolutionize India's display products and technology ecosystem. With PSMC's proven manufacturing technology, Tata Electronics will manufacture display chips for Himax right here in Dhulera, Gujarat. I would now request Martin to say and share a few thoughts with us.
Thank you, Reindeer, my friends, with this warm introduction. Good morning, humble Chief Minister Bhupendra Bhai Patel, ambassadors, distinguished guests, and esteemed colleagues from the semiconductor industry. On behalf of Powerchip Semiconductor Manufacturing Corporation, I would like to begin by expressing my deepest gratitude to the government of Gujarat, ISA, and Semi for their warm hospitality and for creating such an important platform to shape the Indian semiconductor industry's future. The government of India rapid strides in establishing a strong domestic semiconductor industry are truly commendable. Under humble Prime Minister Sri Narendra Modi's visionary leadership, proactive policies and strategic initiatives have created a welcome environment for international companies like PSMC and the ecosystem which is conducive to investment, innovation, and long-term success. Chief Minister Mr. Patel, your guidance has created a strong execution-oriented environment that enhances the ease of doing business for semiconductor business in Gujarat. These remarkable efforts have encouraged PSMC to engage actively in this transformative journey. We are proud to partner with Tata Electronics to build India's first commercial 12-inch semiconductor wafer fab in Dholera. We have already begun collaborating on multiple fronts, from fab construction and technology transfer to talent development and ecosystem building. We are actively bringing fab construction suppliers from Taiwan to Dholera, doing our best to build India's semiconductor ecosystem. As the semiconductor manufacturing industry requires a complex supply chain involving thousands of companies to achieve international competitiveness, we are confident that the government of India and the government of Gujarat will provide a favorable business environment and investment protection for Taiwanese enterprises interested in investing in India. We encourage more international partners to join us in this endeavor and support the development of local suppliers and capabilities. On the theme of partnership, I'm delighted to announce the signing of a three-party MOU between PSMC, Tata Electronics, and Himax, who is one of our most valued customers. This collaboration marks a new chapter in our relationship and is a step towards Made in India chips, particularly in the display IC and AI smart sensing market. Now, I would like to invite Mr. Jordan Wu, the CEO of Himax, to share a few words with us. Thank you.
Honorable Chief Minister Patel, all distinguished guests, and my fellow semiconductor practitioners, good morning. First and foremost, I'd like to thank my dear friend, my partner, Randhir of Tata Electronics, for trusting us and bringing us together to explore the very exciting, promising, and hopefully very rewarding semiconductor market in India. I always believe in any business, new business venture, having a good, solid partner that you can fully trust is more important than anything else. And for that, I believe we couldn't have hoped for better than Tata Electronics. So thank you, Randhir, for the trust and partnership. And equally important, I want to thank my friend, long-term friend and partner, Martin Chiu of PSMC. PSMC is the party who bring us all together because we've been in Taiwan working with TSMC as partners for 2 decades already, shipping billions and billions of ICs together. So it is with Martin and PSMC's introduction that we get to know each other and get to build up the trust and get to form these 3-year partnerships together. And in my earlier talk today, I talked about Himax having expertise, in particular, in providing semiconductor to enable all kinds of displays, for which we are one of the global leaders. So we have shipped over 1 billion ICs a year for many years in a row, many of which we actually together manufacture them with PSMC. Together with Tata and PSMC, we hope to duplicate that success and now bring, hopefully, billions of more ICs to enable the world's displays and have them now made in India. And in today's talks, many people talk about the importance of ecosystem. And in ICs for displays, we do require a very different kind and very special kind of testing and packaging. So we are already in discussion with my partners in Taiwan who are world leaders in their respective areas about the opportunity of coming to India. And I hope when they do come, they will receive the same kind of hospitality and support from the government. And finally, I really look forward to our first chips manufactured in the first commercial specialized foundry semiconductor fab in India, right here in the great state of Gujarat. Thank you.
Thank you, gentlemen, and I now request all three of you to kindly proceed for the tripartite agreement. Congratulations to all the three companies. Ladies and gentlemen, today marks a landmark moment in India's journey towards self-reliance in the semiconductor ecosystem, as we announce the signing of the fiscal support agreement between India Semiconductor Mission, Tata Electronics and Tata Semiconductor Manufacturing Private Limited. We now call upon Shri Sushil Pal, CEO, India Semiconductor Mission, Dr. Randhir Thakur, CEO and MD, Tata Electronics, to exchange the copies of the FCA. This occasion stands as a testament to the visionary leadership of Honorable Prime Minister Sir and the unwavering commitment of the Government of India and Government of Gujarat to position India as a global hub for semiconductor manufacturing. We all can applaud for this. We now move ahead for the next MOU, a significant step towards research excellence. We welcome on stage Professor Rajat Moona, Director, IIT Gandhinagar, to exchange the MOU with TEPL. I request Dr. Randhir Thakur to do the honors, please. Tata Electronics is entering into an MOU with IIT Gandhinagar to drive semiconductor R&D, capacity building, and industry academia collaboration. This will enable groundbreaking innovations and nurture India's next-gen semiconductor talent. Congratulations. Thank you. I now invite Mr. Ishiguro Norihiko, Chairman and CEO, JETRO, to deliver his address. Welcome, sir.
Honorable Chief Minister, Mr. Bhupendra Patel, and esteemed leaders driving the global semiconductor industry, good morning. I'm Norihiko Ishiguro, Chairman and the CEO of the JETRO. JETRO was established in 1956 as a governmental affiliate organization, has been dedicated to promoting two-way trade and investment. Our teams across the 5 offices in India, New Delhi, Mumbai, Ahmedabad, Bangalore, Chennai, work tirelessly to bridge Japan and India, fostering deeper collaboration between our two nations. In the 1980s, Japan led to the global semiconductor market, holding the half of the market share. While this share has declined, Japan still holds a 30% share of the global semiconductor manufacturing equipment market and 50% of share of the key materials. In recent years, Japan's semiconductor industry has been experiencing a significant resurgence driven by the proactive governmental initiatives. At the same time, under the visionary leadership of the Prime Minister Modi and the Chief Minister Patel, India, particularly Gujarat, is rapidly developing its semiconductor ecosystem. Dorera was once a relatively underdeveloped region due to its natural conditions. However, efforts to develop the infrastructure laid the foundation for the semiconductor industry and build a cutting-edge smart city are transforming this vision into reality. With decades of the accumulated knowledge and expertise, Japanese semiconductor-related companies are well positioned to contribute significantly to India. Semiconductor manufacturing may be a new challenge for India, but the Indian semiconductor talent has been long played a leadership role on the global stage. I have no doubt that the wealth of the expertise will be fully leveraged within India itself. JETRO is committed to working this path alongside India, embracing challenges and opportunities together. I hope that this conference will serve as a powerful momentum for the further strengthening Gujarat's semiconductor ecosystem. Thank you very much.
Thank you very much, sir, for your valuable perspective on Indo-Japan cooperation in semiconductors. Moving ahead with the next MOU exchange between Japan External Trade Organization, JETRO, and India Electronics and Semiconductor Association, ISA. I invite Norihiko Ishiguro, Chairman JETRO, Takashi Suzuki, Chief Director General JETRO New Delhi, Dr. V. Virappan, Chairperson ISA, and Mr. Ashok Chanda, President ISA. ISA and JETRO signs MOU to enable, support and fast-track the adoption of electronics and semiconductor technologies and establishment of industries as per agreed scope. Both parties agreed to work together to develop solutions appropriate for not only India and Japan, but other regions across the world. Many, many congratulations to both of you. Thank you. Now I request Shri Pankaj Joshi, IS, Chief Secretary, Sir, Government of Gujarat, to share his thoughts on this significant occasion. Welcome, sir.
Good morning and a warm welcome from the Government of Gujarat to respected Shri Bhupendra Bhai Patel, Honorable Chief Minister of Gujarat, Her Excellency Marisa Gerards, Ambassador of the Kingdom of Netherlands to India, Mr. Ishiguro Norihiko, Chairman JETRO, Professor Rao Tumulla, Advisor, Indian Semiconductor Mission, Shri Ajit Manocha, President and CEO, Semi Global, our event partners, anchor investors, industry leaders, and members of the media. As you all are aware, Gujarat is recognized as one of India's most industrialized state, significantly contributing to the country's GDP. As a key economic and industrial hub, the state benefits from its strategic location and world-class infrastructure. Gujarat maintains a low fiscal deficit of approximately 1.9% and a very low debt to GDP ratio of around 15.3%. These macroeconomic strengths of Gujarat provide requisite fiscal space for policy incentives and investment in infrastructure and human resource development. Gujarat has become a key hub for the semiconductor industry, fueled by its abundant pool of engineering and high-tech essential talent essential for semiconductor innovation. The state alliances with the top educational bodies support a steady flow of industry-ready graduates. I wish to highlight some of the proactive steps Gujarat is taking under the able leadership of Honorable Chief Minister to establish a semiconductor ecosystem. Our focus is on advancing infrastructure and crafting policy frameworks that attracts leading industry players, thereby fostering technological innovations within the state. Gujarat, renowned for its strong infrastructure, is executing significant initiatives to further augment accessibility and infrastructure to address the needs of the semiconductor industry. The Dholera Special Investment Region has been extensively developed as a semicon city. This development includes the augmentation of infrastructure to create a conducive environment that promotes growth and development of the semiconductor industry. The expressway connecting Dholera to Ahmedabad city is in the final stages of its completion. And once operational, it will substantially reduce the travel time between the two cities. Bhimnath railway station, which is a node of the dedicated freight corridor, is being connected to Dholera. This will significantly improve logistics connectivity. The first phase of the Greenfield International Airport at Dholera will be operational for cargo movement by July 2025. Dholera is currently served by 2 power discoms, and in an effort to enhance redundancy, it is now being connected to the national grid. New power transmission lines from Vatamand substation are being erected to offer redundant layer of backup power. This infrastructure development is critical to ensure an uninterrupted and redundant power supply for the semiconductor industry. The state government is ensuring an uninterrupted and redundant gas supply through its robust industrial gas supply network. The government has committed supply of 100 million liters per day of water for industrial usage at Dholera, supporting water supply infrastructure which is already constructed as well as commissioned. The government is augmenting the existing common effluent treatment plant to support global standards of the semiconductor ecosystem and tertiary treatment to facilitate the sustainable processing of effluent. In addition, GIDC Sanand is being developed as a hub for semiconductor packaging with recent initiatives to transform the estate into a smart industrial park with cutting-edge infrastructure that meets global benchmarks. This includes the establishment of a central integrated operations center, a comprehensive surveillance system, a dedicated transport hub, well-planned internal roadways, and a robust physical and cyber security network. We are working on a triple helix model where government, industry, and academia are working together for socio-economic development of the state. The ATMP Training Center at Pandit Deen Dayal Energy University, a joint venture with Micron Technology and supported by Government of Gujarat, stands as a prime example. It seeks to provide training to over 1,000 Micron employees through courses that have the backing of Pandit Deen Dayal Energy University, Micron, the National Skill Development Corporation, and the Gujarat Department of Science and Technology. All these efforts put us at a competitive edge in comparison to other Asian countries as far as land, utilities, and human resources are concerned. As we continue to build upon these strengths, we look forward to a future where Gujarat is synonymous with innovation, efficiency, and excellence in this dynamic industry. Thank you once again for your kind attention and for being a part of this transformative journey. Thank you very much.
Thank you very much, sir, for your inspiring words. Moving ahead to the next MOU exchange with Taiwan Surface Mounting Technology, TSMT, and take us a step closer to a brighter future for EMS in India. Let us now invite Mr. John Wu, President and CEO, TSMT, and Ms. Mona Kandar to exchange the MOU. Based in Taiwan, TSMT is recognized for providing comprehensive OEM, JDM, and ODM services, making it a trusted partner for clients worldwide. With decades of experience in the electronics manufacturing industry, TSMT operates more than 200 SMT lines spread across 12 manufacturing sites around the globe. Its manufacturing capabilities are built around state-of-the-art equipment designed for high-speed, high-quality production. It thrives because of its integrated teams, combining strong FA capabilities, robust IT systems, and the ability to scale production quickly. Many congratulations to you. Up next, I'm excited to announce about the next MOU exchange with the next-gen high-tech semiconductor exploring establishing a new compound semiconductor fab and optoelectronics facility in Gujarat. I now invite Mr. Nirmal Agrawal, founder, Next Gen High Tech Semiconductor, Mr. Manoj Agrawal, founder, Next Gen High Tech Semiconductor, Mr. Rajesh Khanna, advisor to Next Gen High Tech Semiconductor, Mr. Chen Chian Chow, President, Solidit Corporation, Ms. Yushi Aliyama, COO, Hitachi India Private Limited, and to exchange the MO, we'll request Ms. Mona Kandar ma'am to come forward. On this auspicious day, Next Gen High Tech Semiconductor declares intention to participate in India's journey to becoming a semiconductor hub by exploring a new compound semiconductor fab and optoelectronics facility in Gujarat with their technology partners Hitachi India and Solidit Corporation. We wish them good success and hope the proposed project will receive approval from India Semiconductor Mission ISM soon. Many, many congratulations to all of you. Thank you. Ladies and gentlemen, it is now my privilege to invite Mr. Tan Soon Kim, Deputy Managing Director, Enterprise Singapore, and Ms. Mona Kandar, Principal Secretary, Department of Science and Technology, for signing of a significant MOU, which marks a new chapter in the economic collaboration between Singapore and Gujarat, focusing on expertise sharing, establishment support, capacity building, and infrastructure development. By strengthening business relations, this partnership will drive innovation and create new opportunities for both regions. Can we extend a round of applause for both the countries? Congratulations and good luck. I now invite Her Excellency Marisa Gerards, Ambassador of the Netherlands to India, to address us. Welcome, ma'am.
Thank you very much. Namaskar. Namaskar. I'm very happy to be here with you. Honorable Chief Minister of Gujarat, Patel. Very nice to be here. Chief Secretary, Joshi, thank you so much. The President of ISA, all these distinguished industry leaders here and leaders of government, very happy to be here with you today. Let me start by also commending the visionary leadership of Prime Minister Modi ji and the CM and the government of Gujarat for taking these defining steps for shaping India's semiconductor future. I think it's very important. And it's an honor for me to be here. I'm not here alone. I'm here with a delegation from the Netherlands. We have a high-level delegation with people from the business community. We have a few professors with us from the technical universities in the Netherlands, and also we have some representatives of government here. And I would like to raise 3 points to explain to you why it's important for us, for the Netherlands, for me, as the ambassador of the Netherlands, to be here with you today. The first one is 2025 is going to be an important year for us because we have a very strong bilateral bond already, these two countries, India and the Netherlands. But this year in 2025, we will work together to actually elevate our cooperation to a strategic level. We think that in these geopolitical difficult times that we need trusted friends, and India for us is a very trusted friend. And we have many high-level visits taking place right now to prepare a leaders' meeting. And for us, this partnership, there are 3 points that are very important. Trade and investment, as always. Security, also including supply lines. We've been learning that lesson during COVID times, how important it is. And of course, innovation and high tech. And that's also across all the sectors where we work together, like agriculture, like water, health, energy, climate, ports and logistics. All these sectors, also innovation is very important. Now, the second point I want to make is why we're here today. The key enabling technologies, and semiconductors is of very high importance to us in this strategic partnership. We have witnessed how India is making rapid strides in the semiconductor manufacturing and design. With strong government support as well through India Semiconductor Mission, very important. And the Netherlands is a global hub, is a semiconductor powerhouse, I dare to say. We are the home of ASML, the sole supplier of IUV lithography machines that's critical for making advanced chips. We have NXP semiconductors with over 4,000 engineers, I should say, and expanding at this moment here in India. They're the leader in automotive and IoT chip design. We also have in the Netherlands ecosystem, a strong ecosystem of chip equipment manufacturers like ASM International and BC. But there's a whole ecosystem around Eindhoven. I don't know if you ever visited the Brainport Eindhoven. There's a whole ecosystem of 300 different companies, but also research institutes and of course academia as well. Now, India and the Netherlands, I think we have complementary strengths. I think India is strong in the area of semiconductor design, software, and it has a massive skilled workforce. The Netherlands, on the other hand, excels in high-end manufacturing of semiconductor equipment and deep tech R&D. So we see that there are a lot of opportunities to strengthen this partnership. And that brings me to my third point. Because together with ISA last year, we have drawn up this report to actually do a scoping mission and see where there are opportunities for us to do more and to work closer together. And now also, because of the time, let me just highlight 3 of them, where we think when we can do better. And we are now in the run-up to an MOU and to actually have a leaders meeting, trying to see how we can make that very practical as well. Of course, first of all, is research and innovation. Through collaboration between technical universities, research institutes, we think that we can actually step up. We can focus on chip design, on AI-driven semiconductors, photonics, and quantum computing. These are few of the subjects where we can think that we can actually expand and deepen our research cooperation. Then the second point is talent development. We are exploring now joint semiconductor training and workforce development programs. We already had one pilot running last year in December, where we set up an Indo-Dutch semicon school. This was a virtual school, actually. It was led by government and our technical universities. It included 7 universities. We had 4 IITs on board as well, but also leading industries. We had ASML on our side and NXP, who were actually delivering speeches and lectures, but also Tata on your side. They were all on board, and it was really a big success. I could really see that all these students who were following were actually totally energized, and we think we will do it again. It was a pilot, we will do it again, and we will do it bigger, and we will do it better. I think this is really a good opportunity. And then the third point I want to raise, and the last one, is the supply chain and investment. Dutch semiconductor equipment companies, they can support India's new fab ecosystem. I think we can also, I see opportunities as well to strengthen India's semiconductor supply chain with Dutch expertise in lithography and high precision manufacturing. And I think for all of this, we always need to combine government, business, and our knowledge institutes. And then I think we can actually solve any problem that we have in the world today. Because I think there was one speaker this morning who said it's not about competition, it's about collaboration. And I couldn't agree more. So let me conclude. I think India is one of the fastest growing semiconductor markets. I think Gujarat is leading in this respect. The Netherlands is committed to being India's trusted partner in this semiconductor journey. Please watch for the leaders meeting later this year in The Hague. And let me conclude by saying, please stay in touch with the Dutch. Thank you very much.
Thank you, Your Excellency, for emphasizing the Indo-Dutch partnership in semiconductors. We appreciate it. It's now time to release a compendium. We request Honorable Chief Minister, Sir, to unveil the compendium, a knowledge powerhouse for Gujrat Semi Conference 2024. This publication captures invaluable insights, key takeaways, and strategic roadmaps for the future of semiconductor and electronics manufacturing in India. I request all the dignitaries to kindly join for the same. Thank you. Thank you very much. Beyond industries, we build communities. Today, we announce key social infrastructure projects in Dholera, ensuring world-class amenities, sustainable living, and a thriving ecosystem for professionals and residents alike hospital, schools, and fire station. I now humbly request Honorable Chief Minister, Sir, to unveil the plaque using the remote and do the groundbreaking of hospital, school, and fire station. Thank you, Honorable Chief Minister, Sir. अब उस व्यक्तित्व को आमंत्रित करने का समय है जिनकी दूरदृष्टि और नेतृत्व में गुजरात ने विकास की नई ऊंचाइयों को छुआ है। माननीय मुख्यमंत्री श्री भूपेंद्र भाई पटेल जी, जो गुजरात को टेक्नोलॉजी और इनोवेशन का हब बनाने के लिए प्रतिबद्ध है। मैं सादर आमंत्रित करती हूं माननीय मुख्यमंत्री श्री भूपेंद्र भाई पटेल जी को कि वे अपने प्रेरणादायक विचारों से हम सभी का मार्गदर्शन करें।
गुजरात सेमीकंडक्टर 2025 कॉन्फ्रेंस के उद्घाटन सत्र में हमारे साथ मंच पर उपस्थित नेदरलैंड के एम्बेसडर हर एक्सेलेंसी मरीशा गेरार्डन्स, राज्य के मुख्य सचिव श्री पंकज जोशी जी, जेट्रो के चेयरमैन श्री इशिगुरु नोरिहिको, हिमेक्स टेक्नोलॉजी के सीईओ श्री जॉर्डन व्यू, पीएसएमसी के प्रेसिडेंट श्री मार्टिन विचू, टाटा इलेक्ट्रॉनिक्स के एमडी श्री डॉक्टर रणधीर ठाकुर, केनेस टेक्नोलॉजी के एमडी श्री रमेश कन्नन जी, जैबिल ग्रुप के ईवीपी श्री मैट क्राउल, माइक्रोन टेक्नोलॉजी के सीनियर वाइस प्रेसिडेंट श्री गुरुशरण सिंह, सीजी सेमी प्राइवेट लिमिटेड के चेयरमैन श्री गिरीश चंद्र चतुर्वेदी जी, सेमी ग्लोबल के सीईओ श्री अजीत मानोचा, ISN के सीईओ श्री सुशील पाल, अग्र सचिव श्रीमती मोना खंदार, मंचस्थ सभी महानुभाव, आमंत्रित अतिथिगण, देश विदेश से पधारे हुए सेमिकॉन क्षेत्र के अग्रणी, प्रेस मीडिया के मित्र, आप सभी को मेरा नमस्कार। सवारे बहु वहेलाथी शरू थई गयुं छे। वैश्विक नेता और यशस्वी प्रधानमंत्री श्री नरेंद्र मोदी जी की जन्मभूमि गुजरात में देश विदेश से पधारे विभिन्न उद्योग क्षेत्र के अग्रणी और अन्य सभी महानुभावों का मैं गुजरात की सेमीकंडक्टर कॉन्फ्रेंस में स्वागत करता हूं। आज के आधुनिक विकास के इस युग में सेमीकंडक्टर के बिना किसी भी औद्योगिक और आर्थिक विकास की कल्पना ही नहीं की जा सकती। ऐसे महत्वपूर्ण सेक्टर में भारत विश्व का नेतृत्व करे, यही हमारे माननीय प्रधानमंत्री जी का विजन है। प्रधानमंत्री श्री नरेंद्र भाई मोदी जी के नेतृत्व में सेमीकंडक्टर, आर्टिफिशियल इंटेलिजेंस, मशीन लर्निंग और ड्रोन टेक्नोलॉजी जैसे उभरते सेक्टर्स में भारत की वैश्विक स्थिति दिनों दिन मजबूत होती जा रही है। आज का यह गुजरात सेमी कनेक्ट कॉन्फ्रेंस भी भारत में सेमीकंडक्टर सेक्टर को नई ऊंचाई देने में एक नया माइलस्टोन साबित होगा, ऐसा मेरा विश्वास है। भारत में सेमीकंडक्टर सेक्टर के ग्रोथ के लिए इससे पहले भी काफ़ी प्रयास हुए हैं, लेकिन इसमें सफलता हमारे यशस्वी प्रधानमंत्री श्री नरेंद्र भाई मोदी जी को ही मिली है। हमारे प्रधानमंत्री जी का विजन है कि हम ऐसे विकसित भारत का निर्माण करें जहां हमारा देश सेमीकंडक्टर्स की ग्लोबल डिमांड सप्लाई चेन का महत्वपूर्ण हिस्सा बने। मेक इन इंडिया, मेक फॉर द वर्ल्ड और लोकल टू ग्लोबल वैल्यू चेन को संकलित करके वैश्विक मांग की आपूर्ति में भारत और गुजरात सबसे आगे रहे, इसी दिशा में प्रधानमंत्री के दिशा दर्शन में हम आगे बढ़ रहे हैं। भारत सरकार की तर्ज पर हमने भी राज्य में गुजरात स्टेट इलेक्ट्रॉनिक्स मिशन कार्यरत किया है। हमने इलेक्ट्रॉनिक और सेमीकंडक्टर सेक्टर से जुड़े कई स्टेट ऑफ द आर्ट फैसिलिटीज भी स्थापित की हैं। गुजरात देश का पहला राज्य है जिसने सेमीकंडक्टर सेक्टर के लिए 2022 में ही डेडिकेटेड पॉलिसी लागू कर दी थी। हमारी इन्हीं प्रयासों का ही नतीजा है कि अधिकतर सेमीकंडक्टर कंपनियां ने अपने यूनिट्स की स्थापना के लिए भारत में गुजरात को अपनी पहली पसंद बनाया है। वर्तमान में भारत में स्थापित होने वाले 5 में से 4 सेमीकंडक्टर मैन्युफैक्चरिंग यूनिट्स गुजरात में स्थापित हो रहे हैं। सेमीकंडक्टर कंपनियां अपने प्लांट के लिए धौलेरा को प्राथमिकता दे रही हैं। धौलेरा भारत में डेवलप हो रही पहली ग्रीनफील्ड स्मार्ट सिटी है, जहां प्लग एंड प्ले फैसिलिटीज के साथ कई इनिशिएटिव्स की सुविधा दी जा रही है। आज के कार्यक्रम में भी कई कंपनियों ने धौलेरा में इन्वेस्टमेंट के लिए MOU किए हैं। मैं उन्हीं सभी कंपनियों का गुजरात में स्वागत करता हूं और आश्वस्त करता हूं कि गुजरात सरकार आपको हर संभव मदद करेगी। हमारी सरकार ने हाल ही में ग्लोबल कैपेबिलिटी सेंटर पॉलिसी की भी घोषणा की है। इसमें प्रदेश में AI, मशीन लर्निंग और एनालिटिक्स जैसी टेक्नोलॉजी के उद्योग और स्टार्टअप को बढ़ावा मिलेगा। हमने इनोवेशन को बल देने के लिए गिफ्ट सिटी में AI सेंटर ऑफ एक्सेलेंस भी कार्यरत किए हैं। इन सब के कारण आने वाले समय में ग्लोबल सेमीकंडक्टर वैल्यू चेन में गुजरात का स्थान अवश्य ही अग्रिम रहेगा। आज हमारे देश में सेमीकंडक्टर और इससे संबंधित क्षेत्रों में कौशल्य विकास और स्टार्टअप्स के कई नए अवसर खुल रहे हैं। इन सभी विशाल संभावनाओं को ध्यान में रखते हुए गुजरात सेमीकंडक्टर सेक्टर में हाईटेक मैन पावर तैयार करने की दिशा में तेजी से काम कर रहा है। गुजरात टेक्सटाइल, फार्मा, डायमंड, केमिकल्स एंड पेट्रोकेमिकल्स, सिरामिक, ऑटोमोबाइल्स और रिन्यूएबल एनर्जी जैसे सेक्टर में पहले से ही वैश्विक केंद्र बना हुआ है। हम अब इनोवेशन में वैश्विक सहभागिता से गुजरात को भारत के हाईटेक मैन्युफैक्चरिंग रिवॉल्यूशन का केंद्र बनाने की दिशा में काम कर रहे हैं। गुजरात अवसरों के भूमि है, असीम संभावना का केंद्र है और उभरते हुए क्षेत्रों के लिए गेटवे टू द फ्यूचर है। आज से शुरू हो रहे कॉन्फ्रेंस में होने वाले चर्चा मंथन भारत में सेमीकंडक्टर सेक्टर को नया आयाम देंगे। प्रधानमंत्री जी के विकसित भारत के सपने को साकार करने में सेमीकंडक्टर सेक्टर की ग्रोथ भी एक अहम भूमिका निभाएगी और इसमें हम सभी को साथ मिलकर आगे बढ़ना होगा। इस कॉन्फ्रेंस की सफलता की शुभकामनाएं के साथ मैं अपना उद्बोधन पूर्ण करता हूं। भारत माता की जय, वंदे मातरम, जय जय गरवी गुजरात।
धन्यवाद माननीय मुख्यमंत्री श्री, आपके प्रेरक शब्द हमें आगे बढ़ने की शक्ति देते हैं। गुजरात के उज्जवल भविष्य के लिए आपके नेतृत्व और विजन को कोटि कोटि नमन। हार्दिक धन्यवाद। As we conclude this inaugural session, I extend my heartfelt gratitude to our esteemed Chief Minister of Gujarat, Honorable Shri Bhupendra Bhai Patel, and the Chief Secretary, Government of Gujarat, Shri Pankaj Joshi, for gracing this occasion with their presence and insightful addresses. A sincere thank you to all its distinguished speakers, industry leaders, and dignitaries for their valuable contributions. Your words have set a powerful tone for this summit, driving India's vision for semiconductor excellence forward. With this, we embark on an exciting journey of knowledge exchange, collaboration, and progress. Thank you, everyone, for being part of this remarkable beginning. Thank you once again, sir. Ladies and gentlemen, kindly be seated. We have a visionary keynote by Mr. Takatoshi Ikuchi, Director, Electronics R&D Center, Resonic. I request everyone to kindly settle down, please. We have a visionary keynote. Please, we just ask for a couple of minutes of yours. Ladies and gentlemen, please help me welcome the visionary keynote speaker, Mr. Takatoshi Ikuchi, Director, Electronics R&D Center, Resonic. You please. A humble request, everyone, that we shall have the networking during the lunch. Kindly settle in for a couple of minutes more. Thank you.
Good afternoon, everyone. It's already afternoon, but I appreciate to wait until my keynote presentation. Anyway, it's a pleasure to have this opportunity to speak about our keynote. I'd like to talk about Resonac's recent activities. Resonac is just a chemical company in Japan, but we recently started a little unique activities to contribute to semiconductor industry, and we believe this activity help us contribute to Indian industry as well. So let me get started with my presentation.
Video team, can we have the presentation, please?
Okay.
Thank you.
I'd
So
like-
just a moment. Ladies and gentlemen, a humble request to give your 5 to 6 minutes now before the lunch. Thank you and settle in. Over to you.
Thank you very much. And I'd like to start with company introduction, Resonac. Resonac was established in 2023 through the merger of Showa Denko and former Hitachi Chemical. The name of the company is Resonate, and C from chemistry. We are aiming global top-level functional chemical company with co-creation. Our company purpose is change society through the power of chemistry, and we have 4 values: passionate and result-driven, agile and flexible, open minds and open connections, solid vision and solid integrity. Here is our competitiveness. We originally have essential technology on chemicals, organic synthesis, or particle design, resins and fillers. And then we have formulation functional design for semiconductor materials, as well as processing industry technology, like coating, mixing, dispersion, laminate, molding. And also, we are recently updating a lot on evaluation analysis technology, especially for advanced packaging, to provide values to the market and to qualify customer needs. Those are our strengths as a chemical company. And this is the company consolidated net sales. We saw a good sales last year because of the AI-related material growth. The sales last year was about 1.4 trillion Japanese yen, no, 9.1 billion US dollar. The area of semiconductor and electronic materials dominates 32% of the sales, and then we are aggressively invest in growing semiconductor business. Then we are aiming 45% in 2030. Resonac is supplying a lot of materials in the electronics field, like this: servers, cars, PC, cell phones. Especially in advanced semiconductor material area, we are supplying many excellent materials for wide range of semiconductor processes, starting with high purity solvent in wafer process. We have high purity gas, global #1 for etching, CMP cellular slurry, global #1, PID, photo-induced, photo-imageable dielectric, global number one is supplied from HDM, our joint venture with DuPont. And also, we have CCL, global number one for flip chip BGA in substrate manufacturing, dry film resist, solder resist, also global number one. And then in interposer and packaging process, die bonding film, NCF, global number one, and then CAF, epoxy molding compound, global number two, and then thermal interface material in C-type, we dominate the market. This way, especially in packaging substrate materials, we have global number one market share. Then I'd like to explain about our unique activities as a chemical company. We have a lab for advanced packaging. We call it Packaging Solution Center, or PSC. PSC has a capability for evaluating new packaging materials, materials combination, and developing packaging process. PSC can support customers' packaging development with our various materials by many cutting-edge equipments. PSC target advanced packages like 2.x3, 3D, fan-out, WLP, PLP, like those advanced packages. And the function is making TV design, modeling, simulation, substrate, audio, wiring, assembly, packaging, reliability, evaluation, and of course, evaluating material properties. We recently formed a creation platform to enhance our capability for advanced packages, which consortium name is Joint 2. We actually set up this consortium 4 years ago. It's a collaboration between leading equipment and material companies. There are 13 companies, 13 equipment and material companies without semiconductor device manufacturers. It's our customer. So objective of this consortium is to enhance equipment and the materials to accelerate the development at semiconductor device customers. There are 3 working groups in Joint 2. Working group A is pursuing fine bump interconnection down to 10 micron bumpage. Working group B is pursuing fine circuitry interconnection, line space 1 micron, and then working group C is pursuing high reliability large package, which substrate size is up to 140 square millimeter. This is just an example of the outcome from Joint 2. We created multi-layer audio interposer like this. Here's the process flow. We use SAP. We prepared glass carrier, and then we put direct release layer on it, and then seed metal, photoresist, copper plating, and seed etching. We put directly on it, lithography. Then we created a copper circuit with line space 1.5 to 1.5 with a beer of 10 micron or less. And then we did 3-layer copper RDO. Then here's the result. We created 320 millimeter multi-layer RDL interposer, which is very useful for large interposer. And then here is a cross-sectional view of copper RDL, and then the data of the copper circuit line with accuracy. We are pursuing line space 1 micron, 1 micron. Oops. And then we also created 2.5D silicon interposer. This is a kind of mock-up package, but we prepared 2 large die. It's a mock-up of logic die, chiplet logic die, and then 8 small dies as a HBM mock-up. We attach those chips on wafer, and then we mold and we grind, and then we cut away the interposer. We put that interposer, attach interposer to the package substrate, and then attach stiffener, and then we mount that package to the motherboard. We did a reliability test with that package, 2.5D advanced package, with a package substrate size of 120 millimeter, 120 millimeter. Other specifications are like this, and we observed no crack, no delamination, and then good electrical property until 1,000 cycle. This way, we can evaluate advanced packages, even though we are just chemical companies, together with equipment company and then other material companies. We are also trying to extend our co-creation activity to the US. We will open new co-creation platform in the later part of this year in the US. We built up a smaller lab in the US, Silicon Valley. The purpose objective is to co-create and then validate the concept of packaging with hyperscaler or GAFAM. US has advanced packaging technology, so we try to enter into that market, or we want to get those information in advance. Now, 11 companies together with us agreed to join US Joint. We call this consortium US Joint. And also, it's on the right-hand side. We are trying to reach out to the outside consortium, and then we try to extend our ecosystem with the semiconductor device companies or equipment company. Okay, then the last part is materials for power module or package. Let me introduce our technical support sites for India. In addition to Packaging Solution Center for advanced packaging, we have Power Module Integration Center in Japan, as well as material development sites. And also, we have some locations in Malaysia, manufacturing sites for epoxy molding compounds or die bonding paste or dry film reduced. Those locations also have R&D center in-house, and then which can evaluate conventional package or dry film full process. We are supplying some power device related materials, SiC, we sell SiC, epitaxial wafer, high heat dissipation cooler. We have sintering copper paste, heat resistant insulation coating, or high TG epoxy molding compound. Power Module Integration Center, or PMIC, can prepare a case type of module by fabricate cooler parts, do reflow process, case bonding, wire bonding, degassing, sealing, and then PMIC can test transfer molding type of module like this. So this way, Resonac want to help customers shorten development and evaluation time by our own evaluation technologies together with our related materials. This is just a capability of PMIC. We are trying to utilize simulation technology or the modeling technologies. Then, as for materials, we have high TG epoxy molding compound to enhance the reliability of power packages and modules by high heat resistance and TG control technology, which TG is up to 270 degrees C, and it shows a good temperature cycle reliability and then high temperature storage reliability up to 200 degrees C like this. We also have high heat resistant coating material, which name is HIMO, to improve the reliability with high heat resistance and high adhesion, high stress relaxation, and high insulation property to prevent delamination between molding materials and various materials, or to reduce the stress on parts such as wires. Of course, insulation is secured with this material. This right bottom side chart shows power cycle life, and then by using this coating or primer, extend the life about triple. We also have various materials like this for legacy packages, molding support tape, die bonding paste, EMS epoxy molding compound, coating material, mold release film, die attach film. Yeah, this is a summary. As I explained, Resonac is #1 supplier of packaging materials. And then Resonac is promoting collaborative activities with various partners. We want to contribute technically to semiconductor industry to India with this kind of framework. And then additionally, Resonac established a marketing office in India quite recently. And then we are aiming to contribute to advancement of India's semiconductor industry. We appreciate this opportunity to present at ISPEC 2025. This is my last slide. As I said, we recently opened our marketing office in Gujarat. And then those are the guys at the office. We opened this afternoon a booth at the location of 114. So if you have any questions, please come to our booth and then ask some questions to us. Thank you very much for listening, and then have a good day. Thanks.
Thank you very much, sir, for your presentation. And thank you all of you for giving your valuable time over here. And you can now proceed for the lunch. And we join over here, and sharp at 2 we start the next session. Thank you so much. Sir. I request Dr. Manoj to kind over the memento to Sir, please. Thank you very much, sir, once again. And ladies and gentlemen, you can proceed for the lunch. Thank you.
the next generation of minds, thanks in part to Keynes Technologies. As a future technologies enabler, Keysight goes where the electronic signal goes, helping to unlock measurement insights at leading.
The world is facing bigger and more challenges every day. With our semiconductors, we are part of the answer to many of these challenges. Our innovative products are creating sustainable value for society by driving decarbonization and digitalization. We are everywhere. You may not see us, but we are always there, making life easier, safer, and greener. Our microelectronics contribute towards energy efficiency, making it possible to achieve more with the same or even less resources for a sustainable future. Semiconductors are at the heart of the transition towards green, safe, and smart mobility. We make mobility electric,
frequencies, greater thermal and voltage capabilities, and advanced materials and packaging. Driving each country's investment in these technologies is the push for what some refer to as nearshoring, which is essentially building semi-competencies in country, which we've seen and talked a lot about already here today. Semiconductors are a massive opportunity not only for economic growth for countries, but are also becoming increasingly a matter of national security. This means every nation, like India, sees the need to develop their own expertise around semiconductor technologies and production capabilities. So what we're really seeing in today's world is a confluence of both technological, economic, and security factors driving increased demand and complexity. And dealing with this complexity is taking the collective efforts of many nations and hundreds of companies around the globe, many of which are here today. So in line with this trend of each country taking action to define their role in this ecosystem, India has obviously already been hard at work for over the last 2 decades. I first came to India in 1997, which is just about 30 years ago, and that was about 10 years before the first instance of this particular conference. And it's impressive to see the acceleration and the momentum that we've seen over the last decade or so in the semiconductor technology and industry. India's semiconductor market is estimated to have reached approximately $52 billion in 2024, with future growth in India projected to outpace the global market, driven by more investment in semiconductor test, design, and packaging businesses. This growth will be aided by a second phase of investment that's already been announced, approximately $15 billion in government support provided through the India Semiconductor Mission, as well as you know, India's first fab, which is coming online here in Gujarat, with others to follow, in addition to ATMP plants, which are planned, and other investments in the design and production ecosystem. India has made strong investment commitments, and its semiconductor roadmap is certainly progressing quickly. I now want to dive a little bit more specifically into the market trends and then cover the technologies that are needed to support them, to show how no single company or nation can serve the growing demand alone. Partnerships are going to be crucial to enable innovation, and Keysight is one of those key partners working with companies around the globe to bring new technologies to market faster. The semiconductor market is at a pivotal moment. Strong growth provides room for many players, and success is about capitalizing on those areas of strong growth. Applications for industrial, aerospace defense, automotive markets are driving the need for wide bandgap semiconductors using materials such as gallium nitride and silicon carbide, which provide better efficiency, higher frequency, and the ability to operate at higher power, resulting in demand for wide bandgap semiconductors outpacing traditional power semi demand. Concurrently, the AI boom is driving demand for high-performance computing, high bandwidth memory, and evolving silicon photonics technologies and capabilities. The higher networking speeds and more intense compute workloads are required, driving massive investment from hyperscalers and the broader ecosystem. Supporting these trends will require leading-edge design, manufacturing, and test capabilities. This next slide is one way to represent that. I know there are many others that you have individually seen referenced before, but this is just one way to look at this across the end-to-end workflow, as well as different solutions that Keysight offers and intercepts. While many of us take semiconductors for granted, they're obviously proliferating at amazing rates. And each chip is the result of a complex and interdisciplinary design and production ecosystem. Starting with design, highly advanced simulations of chip architectures are put together. These need to account for a variety of parameters, not the least of which include thermal stresses, electrical performance, and certainly manufacturing yield. This design becomes increasingly important and difficult as node sizes shrink further and further. When you look at the wafer production phase, there are only a few fabrication facilities today in the world capable of advanced node production, but there's a vast number of mature node capabilities within the market, and every step of that wafer production process, from material deposition to etching and doping and other aspects of lithography, must be executed with perfect accuracy. A single defect, even if it's at the nanometer scale, can impact chip yield, which is critical for the manufacturing process. Once a wafer is completed, it goes through an assembly, testing, marking, and packaging process, which also continues to get more complex as new technologies are introduced. Covering this entire workflow is crucial, which is why we at Keysight offer solutions at nearly each stage, ensuring full end-to-end coverage. So let me talk a little bit about Keysight. For those of you who don't know us, Keysight is a market leader in design and test solutions that traces its history all the way back to Hewlett-Packard's legacy test and measurement business that was started in 1939 in Silicon Valley in what we like to call Dave and Bill's garage. We've only been a public company since 2014 when we spun out of Agilent, but we've been in business for over 85 years and have deep relationships and engagements with the top customers across all industries. Particularly within the semiconductor industry, we work and collaborate with the top 25 customers and beyond. As I mentioned, our solutions cover industries ranging from telecoms to aerospace defense and to quantum computing. We have a motto that drives us internally within the company that's outlined in the simple phrase, accelerating innovation to connect and secure the world. This really speaks to our core mission as a company to helping our customers bring their products, their leading edge technology, and their devices to market faster. And this approach is critical in a world of increasing complexity, faster technology refresh cycles, and shrinking design time. While Keysight has a broad portfolio of solutions, I want to focus today on a few that are more specific to semiconductor manufacturing and how they align with the trends that I've referenced. So this is a little bit difficult to see here, but the incredible market demand we are currently seeing is requiring higher throughput testing in the manufacturing process. Fabs need wafers validated quicker than ever before, and Keysight offers the highest throughput parallel parametric wafer tester in the market today. It quickly testing for key parameters like threshold voltage, current, and capacitance. As semiconductor components size gets smaller, validating the placement and integrity of the microscopic wires connecting chip to substrate gets more difficult. This is especially critical in the ATMP process, where India is investing today. This is why we developed a novel approach to electrical structural test that replaces X-ray scans with a capacitive-based solution. This method is non-invasive, highly accurate, and can also be operated at scale and parallel. And once you have your validated chips, they need to be packaged into PCBs or other types of form factors. The design of these high-density interconnect PCBs continues to be more intricate and complex, which is why we offer our in-circuit test solutions, which have the ability to test all types of PCB designs and provides high throughput as well. We also have an array of device analyzers, RF, high-speed digital, general-purpose measurement solutions used in the design validation phase and later in the testing process. In addition, we have analysis software solutions for production and manufacturing analytics to quickly and efficiently identify process and yield issues. And more broadly, embedded software in our applications and instruments across solutions that enhance your engineers' usability and functionality, ultimately making them more efficient. This level of complexity demonstrates the need for strong partnerships across countries as well as companies, and where Keysight intersects in this complex process, we are typically a partner of choice. To wrap up and hit a few highlights, what differentiates Keysight's solutions comes down to a few things. First, as you can see on the left-hand side, our leading edge technology. Again, spanning multiple markets, but specific to semiconductor, we work with new wide band gap materials, We're heavily engaged in emerging use cases such as quantum. We're engaging with customers in the AI data center network ecosystem, all the way from network silicon customers to network equipment manufacturers, as well as the hyperscalers, from R&D to manufacturing, and particularly in the evolving area of silicon photonics. We enable the commercialization of new technologies that frankly may not be introduced to the market 2 to 3, maybe even 4 to 5 years from now, which requires us to invest alongside of our customers. This is why we invest nearly $1 billion annually in R&D, and we foster a culture of innovation and high collaboration with our customers. This collaboration and innovation provides us with key insights to market and customer requirements so that we can provide solutions tailored to specific industry use cases and needs. Second, Keysight has design, test, and validation solutions across the entire workflow. This provides another unique vantage point. This end-to-end alignment is increasingly crucial as the ecosystem gets more complex. Doing this well also requires that we meet our customers where they are at, and India is no exception. We have R&D teams and offices throughout the country and in major cities. You may be surprised to learn that 10% of our 15,000 employees are in India, and approximately 50% of those employees are in R&D. We believe India is a strong market, investing in key technologies, and we're here to support that. And finally, as I mentioned earlier, our products are software-defined. We're focused on usability, functionality, and automation to increase productivity. We've integrated manufacturing and process analytics using AI to improve your design and manufacturing test workflow. And we're investing further in our own design engineering software solutions, enabling real-world simulation and emulation in R&D. Today, approximately 40% of our revenues come from software and services. In closing, I'd like to highlight 3 points. As I've said, the semiconductor market needs are advancing quickly, driven by AI and the ubiquity of semiconductors across industrial and consumer markets. Number 2, India and other countries are investing heavily to capture and contribute to this growth and technology evolution, not only locally, but on a global scale. And third, Keysight is well positioned to accelerate and enable this innovation through our own leading-edge capabilities, ongoing R&D investment, and strong customer collaboration. Our customers, many of whom are you, are the world's technology visionaries, innovators, and leaders. Keep pushing the boundaries of technology, and we'll be there to help you accelerate innovation to connect and secure the world. Thank you again for inviting me to speak with you today and the opportunity to share a little bit more about Keysight. Please visit our booth where you can learn more about our solutions and capabilities, and we look forward to meeting with you in the future. Thank you.
Thank you, Mr. Jason Carey, for your valuable insights. Your expertise and vision are truly inspiring and set the tone for the discussions ahead. Can you stay back, please? I now request Mr. Manoj Kumar from ISA to present a token of gesture, memento, to Mr. Carey. Thank you very much. Next, we are privileged to hear from Mr. Mridul Kochhar, Vice President of Engineering, SanDisk. His contribution to technological advancements in storage solutions have been remarkable. Mr. Kochhar, the stage is yours. Can we please welcome him? Let's extend a warm welcome. We've just had proteins and carbs and whatnot in Swedish, and let's use the energy. Yes. Okay, sir.
We're at Investor Day 2025 for SanDisk.
Today is a significant milestone, and how are we going to succeed as a new company?
We live in a very dynamic world. I mean, what we build is flash storage and something that's in every single device that people use every day, from PCs to smartphones to the cloud they use. We're building the best technology in the world. The world is now infused with AI, and we have a big part in that ecosystem, and we couldn't be more excited about bringing our innovation to life.
I think SanDisk as a separate company unlocks an amazing amount of possibilities for us. We can own our own destiny, we can create value to our customers and to our shareholders, and it's going to be an amazing journey going forward.
We're bringing back SanDisk, and now as an independent company entirely focused on storage semiconductor technologies.
I think the biggest game changer is just being a standalone, NAND flash supplier now, following the separation, and being able to just focus on this industry and what we need to do strategically to enable our customers and hopefully deliver great results for our shareholders too.
I think being our own company will make us much more agile and also more creative.
The biggest change in this chapter is really the technology and the people who are driving.
SanDisk is headed for greatness.
SanDisk is a loved and trusted brand, and now we have a new opportunity to write a whole new chapter of SanDisk.
Woo! SanDisk 2.0. SanDisk 2.0 is back. SanDisk is back, and I would say it's stronger than before. But before I start, let's get the lawyers out of the way with the harbor statements. I'm Ronald Kocher. Before I start my presentation, I would like to thank the IESA and Government of Gujarat to give SanDisk and me the opportunity and to come and present before you. I'll be talking about from data to intelligence. This is the world of AI, right? Everyone is talking about artificial intelligence. The internet, the IoT of things, all is gone. The in thing is AI. So I'll be talking about how does SanDisk flash storage empowers AI, which is the most interesting to you. How the innovation SanDisk has done throughout these years have fueled various applications, and now how SanDisk is going to become one of the strongest players in storage in AI. When we talk about SanDisk, for those of you who don't know, the founder of SanDisk was Eli Harari. And Eli Harari, when he got the Lifetime Achievement Award at the Flash Memory Summit, he said 3 things made SanDisk the strongest. One was the system usage of Flash. Flash is an imperfect device, and what makes it great is the system techniques which go behind it. Second is the people, the technology know-how, which SanDisk has. And third is the innovation on Flash. So let me start with a little bit of modern Flash innovation, which is very important for you to understand how all of this will come together to fuel the AI storage. It's very important to understand where NAND flash lies in the storage hierarchy. When you think about AI, everyone thinks about NVIDIA, AMD, and the GPUs. But storage plays, if not equally, a more important role in the AI. If you look at the memory and storage tiering, NAND flash has a significant and important role to play in the storage space. I would say in the storage space, it's one of the most dominant places it holds. And that comes because of its non-volatile nature, because the cost density, because the cost it offers because of the density and its performance and the small form factor. All of this makes NAND flash a very attractive solution for storage in the AI world. But this is not only in AI. NAND flash has fueled innovation in many spaces. Can you even imagine, I think everyone has a smartphone here, can you even imagine having your smartphone without the flash storage? Can you imagine a USB stick being so small without flash storage? Similarly, you cannot even imagine how the AI industry will look like without the flash storage. So if you look at the 30 years of innovation, SanDisk has fueled various applications to take off and become mainstream, starting with the USB and the digital imaging which came out in the digital cameras, which left Kodak behind. And then came out the smartphone evolution and the PC laptops. The ones you are typing in is fueled by, the storage is fueled by flash, going on to the cloud, and now on the AI boom. It's just amazing to see 10 years of innovation has taken the flash output by more than 5x. Where we were, if you go back 10 years, around 2010, where we used to ship 400 exabytes, and you go to 2030, we'll be shipping close to 2.4 zettabytes. That's humongous. I don't see if we have seen growth in any other industry just like this. Even a staggering number is this. If you look at the last 25 years of innovation, we have had 17 generations of flash. And for those who thought the Moore's law is dead, think again. SanDisk has defied the laws of Moore's law, okay? We are continuing to innovate in this space to fuel the AI growth. Going from 2000 to 2025, you can see 17 generations of NAND. I have been a part of about 30 generations myself. I started my career on working on USB drives, and today I'm working on the latest storage which goes in the data centers which the hungry GPUs need. In the 17 generations of NAND, we have seen 1000x cost reduction. In the last 25 years, we have seen 1000x cost reduction per bit. Which industry can tell you that? The last time I went, everything is much more expensive than what it was before. But the way flash empowers the new application is by doing innovation which can give you the cost reduction and the bit output. So how does all of this work? And I'm going to talk about the 3D NAND scaling. 2D is behind us. So let's talk about the 3D NAND scaling. On the 3D NAND scaling, there are 4 vectors where you can innovate and get more cost reduction and more bit output. What I'm sharing here are the 4 methods of NAND scaling. The first one is the lateral NAND scaling. On the right-hand side, what you would see is a ratio we closely track, which is cost reduction per bit output. Usually, what you wanted, where you want to be is on the ratio 1. That means for a 10% cost reduction, you are getting 10% bit output, and everything is good. The supply and demand remains in balance. And that we do by lateral scaling. Today, the lateral scaling is done by making the memory hole more compact, more dense, and giving a smaller die size. The ratio we get there is 1. The other one is the logical scaling. Logical scaling, those who are familiar with the NAND flash might have heard, hey, they are talking about TLC NAND. We are talking about QLC NAND. We are talking about PLC NAND. It might be a little smaller here for people to see. What does it all mean? What it means is you can take a bit, and with the voltage level differentiation you can bring about by sensing, you can differentiate that bit into many states. In the same voltage window, if you can differentiate one bit into many states, it can give you various bits. That's all it means. And that will take us into more denser NAND. Today, the world is on QLC and looking into PLC. QLC is quad level cell. That means one cell can have 16 states. That's what it means. That is the QLC state. And we are moving into PLC, which is a penta-level cell. What that means is one cell can be differentiated into 32 states, which is really amazing. The next one is the vertical scaling. Now, most of the NAND vendors will razzle and dazzle you with this because that's the easiest metric for them to say, right? This is a layers race where people will say, I'm on a 200 layer. You can think about layers as floors on your building, right? And that's the other ways to get cost reduction, right? SanDisk is on, if you have heard the latest news, SanDisk just published its 300 plus layer NAND. The fourth way is architecture scaling, where you have different type of technologies going from CMOS next to the array, CMOS under the array, CMOS bonded with the array to get the architecture scaling. Here, the cost reduction versus the bit output is variable. But these are the ways which can drive the innovation, which really can drive various applications that all of us want to have, whether it's the internet, whether it's the IoT, or whether it's the AI. So that's about NAND. So how does NAND participate in the AI cycle, one may think, right? We all know about GPUs and what is their role in the AI cycle, but you may wonder, all this is good, but what do you do? How do you participate in the AI cycle? So let me go through the AI cycle. Basically, the AI cycle, it works in 6 stages. The first stage is where the data is, you have the raw data in the storage systems, in the big data lakes. That data needs to be sanitized, needs to be transformed, needs to be vectorized. That is step 2. And from there on, that data needs to be moved to the GPUs, closer to the GPUs, where training can happen, right? That's where various models like ChatGPT-4, Llama 4, Llama 2 are trained on the data. From there on, once the data is trained, that's where all of us go into the ChatGPT, DeepSeek, and type in what our query is, and it does interface and prompting, does inference, and generates data for you, which is your data, right? That means you have created new data based on the previous data, right? So now this data gets back stored again. And this is a vicious circle. This is what fuels the accuracy or the hallucinations to go down even. But for a storage company, this is pure bliss. This cycle wants more and more storage, and companies who are participating in that, we love it. So I don't know if you have looked before, you may wonder how an AI cluster might look like. This is a picture of an AI cluster, and the picture I'm presenting here is to give you a scale of how storage participates. What's the scale of storage which is needed for this AI cluster? And this, by the way, is just a medium-sized cluster. As you can see, each rack in there has 16 GPUs, which needs a direct attached storage. There are 252 racks in there. So to fuel those GPUs, to fuel all the data they require, we need about 4,032 direct attached enterprise data SSDs. 4,000 in a medium-sized AI cluster. Just imagine how many AI clusters are in this world. Just imagine what is the need, what will be the need of the storage in this world when you are looking at such high amounts of storage. And with DeepSeek coming in, this is going to be even more because it will proliferate. DeepSeek, by its nature of the cost, will proliferate that even more. I talked about the compute SSDs, which are the 4000, but like I said, all of this data is stored in data lakes, huge, huge data lakes. For a medium cluster like that, we need about 100 petabytes of storage for having the data stored for this AI cluster. As you can see from this picture, the demand is huge. So how do we look at this cycle, and what products can we make to make sure that we are making products, innovative products, which can work on your query and can answer your query faster? As you know, there is a memory wall problem where the GPUs are starved. So we need to work on solutions which can really give you your data, your AI queries in the fastest and the best way. Here is a mapping of the AI data cycle and the products SanDisk has to offer from the edge to cloud. I'll go one by one in them. I talked about interface prompting and inference. This is the one which is most common to all of us, those who have opened your mobiles and laptops and typing in ChatGPT or DeepSeek or any other Gemini model and asking for queries. This is the storage which fuels that. The SanDisk performance SSD is one of the best in class for these applications. As you can see, it's offered from 2 terabyte to 16 terabyte. It's industry-leading performance with lowest latency and the best throughput. We ran some machine learning algorithms on this and benchmarks, and we can see we got industry-leading performance. This is apt for where India is beating their servers in the CDAC systems. This storage is apt for fueling those GPUs with server systems which India is building. The second one is the one which goes into the fast data lakes. And the next slide, which is going to surprise all of you, is introducing our new high-capacity enterprise storage device, which is coming at the end of the year, which will offer 256 terabyte of storage. I believe we'll be the first in the industry to offer 256 terabytes of storage. Just for a comparison, what does 256 terabyte means? Most of you in your laptops today have from about 256 gigabytes of storage. The SSD, which we are producing here, is 1000x the capacity. Can you imagine that? Is 1000x the capacity on a similar form factor. We have a proprietary technique where we are making this SSD and we call it the Ultra QLC. Remember the lateral scaling I talked about? And this is on the QLC device, which has 4 bits per cell. We call it the Stargate. Don't confuse it with the Stargate of the US where Elon Musk and Donald Trump have started. And you can see the staggering numbers it has as compared to the competition Gen 5 QLC SSD. Going forward, how do we do that? To get the best density, performance, and power efficiency, we have an optimized controller, an advanced system design, and the most important, the world's highest memory capacity, a BiCS 2 terabit QLC in production as of today. And you can see the numbers. When we were thinking about AI about 3 to 4 years back, this die takes time to manufacture, and we were thinking about this die, and we worked on this die specifically for the high cap SSD, and you can see the staggering numbers it can achieve. With that, I talked about the 256 terabyte, but we are in sight for the 1 petabyte by the end of the decade. Not forgetting the edge devices, your laptops and your mobile phones. We have solutions for that in Gen 5, in Gen 4, in QLC, in the value, in TLC with DRAM in the mainstream, which can have staggering performance to meet your AI needs. I'm sorry I'm hurrying up a little bit as we are running out of time. and I want to cover all the material. The next segment of AI, which will be there, is autonomous driving, and SanDisk is producing quite a few products ranging from eMMC to PCI BGAs to UFS 4.1 and 5.1 to meet the AI needs of the automotive sector. We don't stop here, we take it further. We reimagine NAND. NAND was always thought to be cost optimized. No more. AI needs something else. AI needs cost, but AI needs bandwidth. So we have reimagined NAND, and this is a picture showing how the NAND can be reimagined, and we call it high bandwidth flash. And just imagine if your cluster of AI was replaced with, the HBM was replaced with this high bandwidth flash memory, the cluster which was giving you 192 gigabytes of memory can give you up to 4 terabytes, which is 4 to 5x increase in capacity. And that's what the GPUs want. They want more data. They can have more models stored on them. Their hallucinations rate will decrease. And that's what the AI is looking for. And we are reimagining all of that going into the SanDisk 2.0. As I showed, SanDisk is not limited to NAND. We are getting into the spaces where we are covering with HBF, we are covering the DRAM space, and also with the enterprise SSD high cap, we also cover the HDD space. So this is my last slide, and I was doing an experiment, and I thought, why don't I go to ChatGPT and ask it a question? So I asked to a completely unbiased LLM, that's my name, hey LLM, I have a question for you. Said, how can I help you, Mrinal? I said, tell me which storage brand is the most innovative. Any guesses? Said, let me study. And it came back with SanDisk is a leading pack with the innovation. That's what the LLM answered. So that's what I would leave you with. Thank you so much.
Thank you very much. And Mrinal, you can just stay back for a while. Thank you, Mr. Mrinal, for your enlightening address. Your thoughts on innovation and the future of semiconductor storage technology are greatly appreciated. And good luck to SanDisk. And I now call upon Naresh Rana from ISA to kindly present a memento to Mr. Mrinal. Thank you very much. We now move on to a crucial discussion on the role of government in policy and infrastructure. I am pleased to invite Mr. Utpal Shah, Senior Vice President, Strategy and Business Development and Head of Foundry Business, Tata Electronics, to share his perspectives with us. Welcome, sir. Anywhere, whatever is comfortable. You can climb from there as well. I think you guys miss on something. Can we extend a warm welcome, please? Thank you.
Can I use the mic?
Yeah, you can use it.
Yeah. Good afternoon, everyone. My name is Utpal Shah. I'm from Tata Electronics. Thank you, ISA, Semi, and Gujarat government for organizing this event. It is my distinct pleasure to address the audience today on the topic of the role of government for establishing the semiconductor industry in India. What I'll do is I have a few slides, and I know I have 15 minutes, so I'll make sure I finish it in time. First, we'll talk about why semiconductor is important for a country like India. Secondly, what is Tata Electronics doing to bring this industry to our country? And third, where I will spend majority of my time, is what is the role of the government in helping bring this industry to India. So with that, let's start. If you go to the next slide. So semiconductors, I think today in the conference earlier during the inaugural session, there was a lot of discussion on semiconductors. It's obviously a very key industry for any emerging and developing country. With the advent of artificial intelligence, the importance of semiconductor has only gone up. I presented this slide 6 months ago, and there was not that much of ChatGPT at that time. Fast forward now, and with the integration of AI in our daily lives and what's projected to be the consumption of AI, the utilization of semiconductor will only explode going forward. So it's becoming very, very important. If you go to the next slide. We also looked at what is semiconductor industry doing to the countries that have the presence of this industry. Now, as far as US, Taiwan, Japan, some of these countries are concerned, semiconductor industry has been established in those countries for many years. And it has a tremendous impact on these countries. Like if you look at Taiwan, for example, 25% of their GDP, overall country GDP, is coming from semiconductor industry. It's a whopping number. Similarly, if you look at the employment, there are over 2 million jobs in United States for the semiconductor manufacturing industry, over 1 million jobs in Taiwan. This is the kind of impact we can expect also in a country like India. Every job that we create, for example, our plant in Dholera will have about 2,000 direct employment. We are looking at having roughly 20,000 employment overall in the ecosystem. So the ratio is 1 to 10. For every employee that we hire, there are going to be about 10 jobs in the ecosystem. So what this industry does is it provides an economic growth to the country that is very essential. It provides that economic security for countries as we look forward into the future. The other very strategic aspect of semiconductor is the utilization, usage of these technologies in areas like defense, military, the digital infrastructure, smart cards, and whatnot. So the entire backbone of a country can be now based on digital infrastructure. Some of the industries like defense will rely on this, so it also becoming a very important industry from the defense standpoint. Tata Electronics, so we look at semiconductor industry as one of the key focus areas that the Tata Group at the group level is heavily focused on. There is a very long-term commitment from the group. When it comes to semiconductors, we know that it's not an industry that is light on capital. It's very, very capital intensive. So we have started this company in 2020, in the middle of COVID. We have a vision to provide end-to-end solution for the entire manufacturing value chain for electronics. So it starts with design services, where we support our customers for any type of design need they have. We then go to chip making, which is our foundry business. We then follow it with chip packaging, broadly known as OSAT in the industry. And then finally, we have a system-level manufacturing, where we do both component manufacturing as well as full system manufacturing, broadly known in the industry as FATP, final assembly, testing, and packaging. There is probably not any other company on the planet that actually provides this. In each of these categories, you will have companies that do design services, companies that do foundry, companies that do OSAT and EMS. Tata Electronics, with this unique offering, is also distinguishing itself as a company that can provide a one-stop solution to the customers for the entire electronics manufacturing value chain. We started our fab construction last year in March. It's exactly 1 year that the Prime Minister laid the foundational stone for our fab. This will be literally the first commercial fab in India with the capacity of 50,000 wafer starts per month. It's an $11 billion project investment. We have several nodes that we are targeting from the process technology standpoint, from 110 nanometer all the way down to 28 nanometer. And we will be essentially working with our technology partner in Taiwan to replicate the fab they have in Taiwan in Dholera. When the fab is up and running, we will be manufacturing chips in these 4 markets. These are very high growth markets: power management ICs, display drivers, standard logic, and embedded non-volatile memory, which are very central in the automotive applications. Now let me switch gears to the role of the government. When you're talking about semiconductor, when you're talking about an industry of this magnitude and scale, it is impossible for companies to bring this kind of industry without the support from the government. So the government support and the policy framework, infrastructure support, all of these things are extremely, extremely crucial for an industry like semiconductors. I would like to talk about mainly these 4 areas that are, as we have started the journey of building the semiconductor fab in Dholera. These are the 4 areas that are really emerging as very, very crucial. The first one is capital intensity, which means that this project, like I mentioned, it's highly capital intensive. Building a single fab for the technologies that we are targeting costs us around $10 billion. If there was no government support, it would take the company more than 20 years to recover that investment. So it's financially not feasible. That's where the capital and fiscal policies are very, very important for building the fab. The infrastructure is very important. I want to say that for a semiconductor grade infrastructure, it was literally non-existent in India a few years ago. But like I'll talk about Dholera in a couple of slides, the government has done a phenomenal job in establishing semiconductor grade infrastructure that has made our project viable from the infrastructure standpoint. It has also reduced the schedule of building a fab because of the readiness of the infrastructure. Third is talent. We need to make sure that the talent is available. Again, because the industry does not exist in India, companies like Tata Electronics, we have to partner with government and academia to make sure that we create that supply of trained workforce on a consistent basis so that we can thrive in an industry like this. And last is the ecosystem development, because nothing happens without having the ecosystem localized in India. And I'll talk more about that in a minute, but ecosystem is also very important. So on the fiscal front, again, I think all countries have realized that for bringing this industry in a country, the governments have to take an action. Many governments have taken actions in terms of how they are supporting the industry fiscally. India, with its India Semiconductor Mission, thanks to our mighty organization, have come up with a very holistic and very aggressive semiconductor mission policy, which we are a beneficiary of. And what I would like to say is that the policy that has been put out from ISM, India Semiconductor Mission, is very holistic in nature. They've thought about not just building the fab, but also the support that goes into that, the land, the equipments, the construction spending. So it's quite comprehensive in that sense, and we are very, very appreciative of having a policy like that. You will see that Tata has taken a big advantage or big portion of the subsidy that the government of India has come up with. Now, on the policy front, the policy that ISM came up with, clearly there is nothing like this if you compare with other countries. In India, for a semiconductor project, you get 50% subsidy on your eligible project cost from the central government. And you get additional 20%, 20 to 25% from the state government on your eligible project cost. So put together, there is a 70% subsidy for a project. And this is quite massive, right? There is no other country that offers this level of subsidy, and that becomes a strategic advantage for us in India in terms of establishing or conceiving this industry and at least getting started with it. I really want to have a big round of applause for all the government dignitaries that are sitting here in the audience. It is great that India has come up with this policy. Like I said, it's unparalleled in terms of the subsidy, the generous subsidy that is being offered to projects. And we at Tata really appreciate that deeply. In terms of what can be done from the opportunity standpoint, obviously the one fab is not economical. We need to have multiple fabs. So we are seeking more support from the government in terms of building more fabs and providing more incentives. Also, the incentives for ecosystem development. So supplier ecosystem is very important. Many of the suppliers are in the audience today. For them to set up their infrastructure and their facilities locally, they will also need that kind of support from the government. And lastly, for doing business in semiconductors, you are pretty much dealing with global customers. Majority of our customers, when we build this fab, are going to be global customers. So there will be a lot of exports. There will be a lot of export when it comes to selling what we make. And there is a lot of import in terms of machinery that we need to bring into this fab. So how the government devises the policy in the area of export and import so that tariff implications are maintained. I mean, they're taken care of from not making an impact to the project. Special economic zones is one of the solutions that we are pursuing with the government, and those kind of initiatives will be very meaningful to make sure that import-export implications are taken care of. Now, Dholera, like I mentioned again, highly, highly appreciative of what the government has done, Gujarat government, and particularly the DICDL and the Dholera Special Investment Region. They have envisioned and anticipated what the semiconductor industry requires in terms of uninterrupted and redundant power, uninterrupted and redundant supply of water, supply of gas, effluent treatment, expressways, airports, seaports. This region, this state, and especially the Dholera Special Investment Region, they are an order of magnitude ahead of other places in India in terms of infrastructure readiness. So again, a big round of applause to our Gujarat government officials in the audience for really making an impact here. We are very, very pleased with it. In terms of what can be done, we want to focus, have the Gujarat government focus, and for that matter, any other state government, to also focus on the social infrastructure. The industrial infrastructure is only one side of the coin. You need to have social infrastructure also ready at the same time. This means schools, hospitals, residencies, a good lifestyle, restaurants, playgrounds, and those kind of things are becoming extremely important now that we have started dealing with some of the ecosystem partners who are looking at Dholera. One of the first queries from them is the social infrastructure. So we need to get ahead of that and get that ready. Secondly, even though the infrastructure is there from the Gujarat government, there are still places where the semiconductor requirements are more stringent than what the government has anticipated in the past. So we are working with the government in terms of making sure the stringence of the requirements are met in terms of the basic infrastructure needs. And then lastly, there are things like a common warehouse for spare parts storage that can be built. Again, we are collaborating with Gujarat government on things like shared facilities as well. In terms of ecosystem development, so the good news here is that the Gujarat government is very, very active. The fact that we are all gathered up here in this room today for the Gujarat Semiconductor conference is an example of that. There have been Semicon India, Gujrat Semiconductor last year. So this is the platform that is bringing the entire industry together, and the government should continue doing this, providing this kind of platform to the industry. Also, the government of Gujarat and the central government and other state governments also have been very active in terms of sending their delegation to some of these international locations like Taiwan, Japan, Singapore, where they can learn from these countries and bring the best practices back to their local government. And more of that needs to be done. In terms of what are the opportunities for Gujarat, for the state government and central government, is to localize the supply chain. Local ecosystem is going to be very, very important for this industry. And we are, I think many of the equipment, materials, chemical, gases, automation suppliers are in the audience. For them to localize their presence is going to be extremely crucial for us for our first fab as well. We don't want to wait for a week or 2 weeks to get a spare part from somewhere, right? It needs to be in the close vicinity and proximity of the fab. Promoting local Indian product companies and made in India requirements are other two things that we are working with government to generate that local demand from within India that will further contribute to the ecosystem development. So I'd like to summarize by saying that semiconductor is a very important industry. It has increasingly become that economic security and national security technology that every country is going after. India in particular has done a great job in terms of establishing very aggressive and comprehensive policies. We need to work together because this is going to be a long journey. We have had a good start. I think from the government standpoint, it has been a great start, but it's not the end of the journey. It's a marathon, and we at Tata Electronics are definitely looking forward to partnering with the government to make sure that we collectively see our joint mission getting realized in the next few years. Thank you.
Thank you very much, Mr. Utpal Shah. And we request you to kindly stay back, sir, as I would call upon Mr. Jitendra Chadda from Global Foundries to present a memento to sir. Thank you, Mr. Utpal Shah, for your valuable perspectives on how government policies and infrastructure can shape the semiconductor industry's growth. Thank you once again. And now let's hear from Mr. Manish Gurwani, IS, Mission Director, Gujarat State Electronics Mission. His insights will provide a roadmap for Gujarat's leadership in semiconductor manufacturing. Sir, please take the stage, and we request all of you to kindly extend a warm welcome to him. Thank you.
I hope I'm audible. So, yeah, good afternoon, everyone. I'm Manish Gurwani. I do realize that I've just made in time. I'm Mission Director for a unique body, Gujarat State Electronics Mission. When I say that it is a unique body, it is a unique body in the sense that it does policy promotion and investor facilitation as far as the electronics and semiconductor sectors in Gujarat are concerned. And it is the same body which releases fiscal incentives as well. So while in some of the states you would find investors interact with one body for policy promotion and they get to deal with another body for incentive dispersal, this is fortunately not the case in Gujarat. So for all kinds of investor facilitation, for all kinds of approvals, and consequently the incentive dispersal, any investor has to deal only with one body, Gujarat State Electronics Mission. So I've got only 6-7 slides. Yeah. So the first slide highlights why Gujarat has been chosen as a manufacturing pioneer over decades and over years, and why Gujarat has now emerged as a semiconductor hub for the country. So it's best performing state in all major rankings. GSDP of $309 billion. It contributes 8.6% of India's GDP, contributes 30% of India's total exports, 38.5% of India's port cargo handled, longest coastline of more than 1,600 kilometers. Most interestingly, Delhi-Mumbai Industrial Corridor, a major chunk of it, 38% of it passes through Gujarat. It has a wide airport connectivity, 19 airports, including 3 international airports. Amazingly connected roads, transport facilities, wide gas network, 55 gigawatt of total capacity of power, out of which 54% come from renewable sources. Therefore, the state has also emerged as one of the green states in the country. The state's water network is 63,000 kilometers wide and scattered across all the regions of Gujarat. There's another point. There are 2 major industrial estates where semiconductor clusters are coming up. One is in GIDC Sanand, near Ahmedabad, and the second is, of course, Dholera, India's first semicon city. There are more than 230 GIDC industrial estates with plug-and-play facility. GIDC Sanand 2 is one of them. I am today joined by CEO Dholera, MD Dholera, a senior colleague of mine in the Indian Administrative Service, Dr. Kuldeep Arya sir. So while I'll dwell upon the policy perspective, I'll deal with semiconductor policy and electronics policy. Dr. Arya will talk to you in greater details about Dholera and the emerging ecosystem there. So as far as semiconductor and electronics is concerned, there are 2 major policies which GSEM runs. One is the Gujarat Electronics Policy. The other is Gujarat Semiconductor Policy. So under Gujarat Semiconductor Policy, projects like Tata, Fab, OSAT, ATMP, compound semiconductor fabs are covered. They're contingent upon Government of India's approval, and consequently the approvals are being granted by a state government. The Gujarat Electronics Policy is more of an umbrella policy. It caters to a wide spectrum of products and applications pertaining to electronic sector. If you look at both the policies, the incentives mentioned in the policies are a judicious mix of both capital in nature and operational in nature. So our policies are customized, attuned to the investor's requirement so that the capital requirement and the operational requirements have been factored in. Now, I would seek your attention to the bottom part, speedy project approval. Micron Technologies ISM approval, Government of India's approval was granted on 15th of June. The Government of Gujarat's approval for a project worth 22,000 crore was granted the very next day, 24 hours. It took us less than 24 hours to approve a project of that stature. This is how this state has always functioned. Mind you, Tata Electronics, another project worth more than $11 billion. ISM's approval was granted on 7th of March. Government of Gujarat's approval the very next day, and the foundation stone laying happened on 13th of March, and the construction is going on rapidly. Similarly for CG, so our approvals are contingent upon Government of India's approval. We don't have an additional layer of scrutiny at our level. Once the project is scrutinized and approved at Government of India's level, we take less than 24 hours to approve a project of these statures. This is how the state has always functioned. It has continued to function. The state has a rich culture of industry-academia collaboration. Micron has collaborated with Namtech. Ganpat University is a good name. PDU, IIT Gandhinagar, today only Tata and IIT Gandhinagar have signed an MOU. The slide is to highlight that the state has a rich heritage and rich culture of industry-academia collaboration. A unique initiative, recently we have announced an ATMP training center in PDU. Now the center is a tripartite arrangement between Government of Gujarat, Department of Science and Technology, PDU, a university in Gandhinagar, and of course Micron. So where equipments have been donated by Micron and some CapEx and OpEx related expenditures have been taken care by Department of Science and Technology and the university. So now this is not a part of the policy, but on a case-to-case basis, we are open to such projects as well. And this is a unique example of a project where government and industry, Micron, and academia, PDU, have come together for a common cause. So as I mentioned, Dr. Arya will speak in greater details about Dholera. So right now, we have been very, very fortunate to have 4 semiconductor projects in Gujarat. Total 5 projects approval have been granted by Government of India, out of which 4 have landed in Gujarat. We have been very, very fortunate. We accept the fact with the humility that these 4 projects have landed in Gujarat, but we keep our ears open. I always tell my people, tell my team that we should always feel very, very humbled, very, very grateful, and keep our ears open. So we are open to your feedbacks, your suggestions on our policy or infrastructure. Now these 4 projects are definitely a path-breaking moment for Government of Gujarat, but we look forward to many more. Now, Micron, Tata, CG and Kaynes, both in Dholera and Sanand, are working on their construction. Our aim, our desire is to build the entire ecosystem of semiconductor electronics in Gujarat, be it specialty gases, chemicals, tools, components, everything. We are in touch with a lot of potential investors and partners. And I always make it a point to tell my people and tell my colleagues from the state. In fact, I would also use this forum to thank people from other states who have come together. This is a spirit of cooperative federalism. I always mention that we'll be happy if you come to India, we'll be happier if you come to Gujarat. So thank you to all colleague states. That's all about my presentation. This is my mail ID. All kinds of questions can be addressed to this mail ID. We are open to all your suggestions, your feedbacks on our policy or on our infrastructure. Now I take this opportunity to invite a senior colleague of mine in the IS, Dr. Kuldeep Arya, will talk in greater detail about Dholera. So candidly, I tell my team that I had a mission, Gujarat State Electronics Mission in literal sense. So I am a man with mission literally. He is a man with mission metaphorically. He is the one running the show on the ground. Over to you, sir.
Thank you very much, sir. And welcome, Dr. Kuldeep Arya, sir.
Thank you, Manishji. So I think for Dholera, since morning we are hearing a lot about Dholera. Can I have the presentation, please? Yeah. So we just heard from Manish that Gujarat is the most industrialized state, and Gujarat is having lion's share in India GDP, FDI inflow, industrial output and manufacturing, even in exports. We aspire to be 10%, we aspire to have the 10% share in India GDP by 2047. And I'm mindful when we say that 10%, at which growth we have to grow. So it's now almost 8.6%. I'll begin with the National Industrial Corridor Development Program, which aims to create the world-class cities with its 11 industrial corridors. And with the 32 industrial cities, we are fortunate to have Dholera, the first node of Delhi-Mumbai Industrial Corridor. It is the largest city of DMIC, and it is the India's first greenfield smart city. So Dholera special investment region spans over 920 square kilometers, which is a very huge area, and which is divided into 6 big town planning schemes, further strategically divided into 27 town planning schemes. Town planning scheme is a development mechanism adopted in Gujarat, where we do not acquire the land, but we pool the land. Certain portion of land from the original occupant is taken, and then it is consolidated for the development authority, and the rest portion of it is given back to the original owner, either at the same place or at another developed place. So this is the most easy and a working model of development in Gujarat. So out of these 27 TPs, almost 5% area has been developed and set to become the global hotspot for high-tech industries, because government has declared this 22 square kilometer area as the semiconductor city. And it is evident with the investment made by Tata Electronics and PSMC. And today in the morning we heard the announcement of Himax also. And now the manufacturer is there, their technology partner is there, and a buyer is also on the field. So and the another announcement also made by the for the fiscal support as well. So now they are going to sail through very nicely. We with the plug and play industrial infrastructure backed by the government subsidies. So Dholera is poised to become preferred manufacturing hub of India. We welcome here the semiconductor and ancillary units, the electronics, and the developers for other industrial and social infrastructure projects. Dholera offers strategically allocated zones for industry, residential, commercial, and hospitality sector. We have large contiguous land parcels available in Dholera. The plug and play infrastructure provides the ecosystem for seamless industrial development with the large network of roads with utility ducts and other industrial corridors. These are some actual photographs of this site. With 360-degree connectivity of Dholera, it is the ideal hub for advanced manufacturing. We are well connected with the air, rail, road, and ports. I'll try to emphasize mainly on the Dholera International Airport, which is the Greenfield International Airport under construction. In first phase, we will develop one runway. In the second phase, another runway will be constructed. The cargo operations are supposed to start by July-August 2025, by this year, whereas the passenger services will start by December 2025. Similarly, the 100-kilometer long straight-aligned national expressway, which will reduce the time of travel from Dholera to Ahmedabad by 1 hour. It is almost 95% of the work has been done, and today the NHAI chairman is on the site visit of this expressway, and we hope that before this monsoon, this expressway will be inaugurated. This is a 4-lane expressway which can be expandable for the 6-lane expressway. Dholera offers stable and quality power. We have 2 DISCOMs in the area. One is the state PSU, whereas one is the private distributor, and they have come up with 2 substations and redundancy power supply line, and 2 additional substations are under implementation. The reliable and efficient water distribution network with the availability of sewage treatment plant, water treatment plant, and common effluent treatment plant is in Dholera. Dholera also, the administrative building is equipped with the office space, auditorium, banquet, and the other amenities. So we facilitate the investors to, rather promote them to use these facilities. Lot of discussion has taken place on the weak social infrastructure development in Dholera, and recently Utsav has also said that we need lot of social infrastructure in Dholera. So these are some projects which are supposed to come up within a year in Dholera. Today morning itself, Honorable Chief Minister has laid down the inaugural stone for the school, hospital, and fire station. We will soon come up with a good food court there, and there is a big land parcel of around 156 acre land which we will develop as the integrated residential township. We have allocated almost 21 acres of land to Tata. They are developing their designs and wish to get more land, around 80 acres. Similarly, the residential and commercial complex will also come up with the help of the private investors. So around 1,000 studio apartments are planned within one and a half year time period. And we have allotted this land to a leading joint venture company of Gap Associates, Sun Realty, and BMS. For the hospital, we discussed it would be a 200-bed state-of-the-art hospital with 25 ICU and the other emergency care. Today, the inaugural ceremony, foundation stone ceremony happened. So I wish that within the time period we will achieve this construction. An integrated school up to 12th standard with the type design endorsed by the Central Board of School Education is also coming on the site. Other upcoming facilities for the accommodation, one corporate hotel with 100 plus room is to come within a year itself. Similarly, we are also trying to start a tent city on the site. We also believe in the organic development of the city, and within a radius of 5 kilometer area from the main activation area, around 250 residential developing units are present, whereas within the 30 kilometers, another 500 units are available. Danduka is the nearest town where we have the basic facilities to cater the needs of the people. Nevertheless, just 100 kilometers away from Dholera, we have the bustling town of Ahmedabad, which is having all facilities. And as I said, with the advent of the expressway, this will be more nearer from Dholera. Some tourist destination near Dholera, the National Maritime Heritage Complex in Lothal, which is around 37 kilometers away from Dholera, is being built by Government of India with a total cost of 1200 crore. The first phase will be inaugurated in this December. The other, tourism sites are near Dholera. So with these words, I would say as we move forward, we invite you all to be partner in this transformative journey. Thank you. Thank you for giving this time.
Thank you very much, sir, for sharing the valuable insights. Sir, you can stay back. And I request Mr. Uma Mahesh, ex-EC member, to kindly present the memento to sir. Is Manish here? Manish, sir? Yes. Manish Gurwani, sir, are you here? Okay, he's left. No worries, we'll send him his memento. Thank you. Thank you very much, sir.
Yes, our team would be there too.
Next, we are honored to have with us Shri Sushil Pal, CEO, ISM MeitY, Government of India. His role in shaping the semiconductor mission has been crucial to India's technological progress. Sir, we invite you to the stage to share your thoughts with us. Welcome. We welcome you, Shri Sushil Pal, sir.
Hi, good afternoon, everyone. I just had my lunch, speaking after lunch when you... Anyways, I think I've already spoken once in the morning, but then sorry to be, putting... But I would try to dwell upon certain policy issues which government is, handling. And as such, if you look at India's economic journey, I think it's largely been focused on the primary sectors and the services sectors, with primary sectors contributing to roughly about 16%, but employing 46% of the employment, right? And the tertiary sector, I think it contributes to roughly about 50 to 55%. So in a way, this journey has been a bit different from the typical evolution of economy from primary to manufacturing or to secondary, and then to the tertiary sector. In India case, somehow the manufacturing sector did not take off to the extent, to the level it should have. As a result, I think we still contribute to only about 16-17% of the GDP, and that's the reason I think maybe government in its vision thought to come out with a policy which is focused more on semiconductors, which is focused more on electronics, because this particular sector is the most important segment. Why also? Because, manufacturing global value added is roughly about 16, 17 trillion, and out of that, 14, 16 trillion of global value added in manufacturing sector. Almost 4.5 trillion is only electronics. So roughly 25 to 30% of the global manufacturing revenue value added is electronics and semiconductors. And that's the reason if any manufacturing sector needed a push or a thrust, then it is the couple of years, I think, wherein we have become actually the second largest producer of the mobile phone, producing almost about 33 crore mobile handsets, every year. We've become net exporter of the mobile phone from being net importer a few years back, and electronic export, as I said in the morning, has been climbing up the ladder, and it is now the third largest sector in terms of the export. These shifts are happening because of the well-designed policies, both of the central government as well as the state government. And most crucial policy intervention has been the national policy on electronics in 2019, which included the three policies actually: the PLI for large scale, the EMC cluster scheme, and also the specs scheme for the components. And as now, since we have reached that assembly stage, that we have a huge downstream market for the components, and these components include both the semiconductor components as well as the non-semiconductor components. For the non-semiconductor components, we are already working actively with the industry and are in advanced stages of coming out with the policy. And for semiconductor components, ISM was brought in to actually catalyze the semiconductor part of it. And even the discussions for covering the larger ecosystem of semiconductor, which includes components, equipments, the gases, and the raw materials, I think those are also underway. And we are hopeful that we'll be soon coming out with that policy as well. The chip manufacturing, as you all know, is the most complex process. I think it's the most complex manufacturing process which humankind has actually seen. And this requires roughly more than 1,000 complex processes, more than 16,000 to 17,000 vendors across the supply chain. And it's highly capital, it is intensive from all segments. Leave the size apart. That's the only place where it is not intensive, because it's highly miniaturized. If you leave the size, I think it's a capital intensive, it's a knowledge intensive, it's a skill intensive, it requires huge, and also it requires a huge, massive amount of infrastructure. So if any economy or if any state can cater to the manufacturing requirement of the chip making, it can obviously, cater to any other manufacturing requirement, because the challenges in those sectors are pretty much less. And these chips, they crosses something like, 70, more than 50 countries' borders, and therefore there are huge global interdependencies as well. And another reason, why this, because of this being, I think, because of the huge global interdependency in making a chip making, because certain parts of the certain part of these value chains are made in a very specific geographies. Say equipments belong to a very few geographies. Similarly, the raw materials even belong to, like photomask, belong to a very few geographies. So any disruption in this supply chain can actually put the global supply chain of the semicon to a halt, and therefore it's important that we actually make these supply chains highly resilient, so that we do not again face the global shortage of the chips or the disruption of the economy which we faced after the COVID-19 when it hit us, which impacted we only hear of automotive industry, but it hit more than 170 industries in the country, and it actually impacts the overall economic growth as such. So apart from this basic need for having a resilient supply chain, there is another reason, which is a huge demand for semiconductor. As I said, early in the morning as well, that India is expected to constitute roughly 10% of the global demand of $1.2 trillion by 2030 or so. In terms of the providing infrastructure support, I think government had, as I said earlier, I think it had come out with the EMC support as a part of the national policy in electronics. In the EMC, I think we have approved 19 greenfield projects and 3 common facility centers. And of these, roughly about 400 companies have been allotted land and committing an investment of $6 billion and creating a jobs of roughly 300,000 jobs creation with 150 companies already in production. So, and apart from those EMC policy, I think in even the budget this year, Honorable FM announced the creation of industrial parks, which will provide the plug-and-play industrial parks, which will provide the complete infrastructure, and that it was, I guess, 100 industrial park, which was announced by Honorable FM and Ministry of DPIT, Department of Promotion for Industrial. DPIT is actually in charge ministry for taking these proposals forward. And budget also announced another policy intervention, which was very important. Fabrication requires reliable access to the critical minerals as well, such as cobalt, aluminum, arsenic, rare earth materials, etc. And any shortages in these materials, critical materials or minerals, may actually expose the vulnerabilities of the supply chain and actually create choke points as well. With that intent and with that vision, the government brought the National Critical Mineral Mission of roughly about $4 billion, 34,000 crore, to focusing on the extraction of these critical minerals, both within the country as well as abroad. So we also acknowledge the pivotal role played by the state government for the fulfillment of the above objectives to establish India as a semiconductor hub. And actually, we believe that that's purely the collaborative effort of the federal and the provincial government, which can actually ensure that any semiconductor manufacturers and suppliers, they can operate in a very stable, cost-effective, and innovation-friendly environment in the most cost-effective way. As I think I would not go into the details of the infrastructure. I think my colleague earlier for the Dholera as well as Manish before him, they would have spelled out in detail as to what infrastructure support the Gujarat government is providing in terms of providing the assured access to the power, as well as providing the ultra-clean water, or be it providing the connectivity through the road, airport, as well as the railways. So in conclusion, I would only say that, I think India's journey to become actually a semiconductor hub is actually backed by a very clear vision, bold policies, both at the central and at the state level as well. And it has provided a strong foundation by providing the financial incentive, rather the most lucrative financial incentive in the world, and a strong infrastructure support. The state government are also complementing these efforts by offering region-specific incentives.
For your insights on India's semiconductor mission and the role of government initiatives in fostering industry growth. Thank you. I would now call upon Mr. Dr. Hemang Shah, Senior Director, Government Affairs, Applied Materials. He will take us into a key discussion on policy enablement. To set the context, I invite Dr. Hemang Shah, Senior Director. Over to you, sir.
Thank you. Good afternoon, everyone. What wonderful presentations we've had from both, the state governments as well as Sushil Palji, and not to forget the tremendous progress that Tata has been making in Gujarat. I'm sure you all will agree that we are just getting started in India's semiconductor manufacturing journey. Now, for a self-sustaining and a competitive ecosystem, we need all the elements to support manufacturing. And that's where fabs come into the picture. That's where assembly houses, the testing houses also come into the picture. I represent Applied Materials, where we make one of the most critical pieces for running a fab, which is equipment. We like to think that equipment is the beating heart of every fab. And we take pride in what we do. And we are what we call as the enabling pieces of the ecosystem. And it's not just us. We need other folks to also develop this system out here, which includes the ancillary providers, the gas suppliers, the chemical manufacturers, and so on. Now, this reality, the vision to reality coming to life, has been spurred by the central government with the India's Semiconductor mission. And we just heard from Sushilji of how it support, which is in terms of incentives and also the infrastructure. Now, however, there are aspects where we need to probably, get all of us together and see how we can make it a thriving ecosystem in the country. As an example, there are building codes, fire and environmental safety, and other criteria where the industry has to count on governmental support. Now, a page that we can borrow is the International Code Council. Now, it has an interesting history. In the 1980s, the semicon manufacturers in the US got together, and they got together with the building and the fire officials to develop codes and standards. They developed this for two purposes. The first one was to support the technical requirements of this growth industry. And second, and the most important one, is to maintain high standards for life safety and emergency response. Both of these are non-negotiable. Now, these gold standards or model codes are reviewed by the ICC every 3 years. So they continually keep updating these, and they stay up with the times. And this is where India can look at developing a national guidelines. Now, we have states, we have the center which are supporting these in their own ways, but maybe the industry can get together and, and provide our relevant input to the government. It is also heartening to see various support for infra, including logistics and power tariffs. And these are much needed because, as we understand, such investments are not only capex intensive, but they also require a fair amount of operational expenses. So it is heartening to see the governmental support on that, and the industry will count on it. But I think that's enough from me. I think what I now want to do is turn the page over and bring it over to two states which are enhancing this ecosystem. Let's hear from them. First up, I'd like to invite Shri Sanjay Dubey, IAS, ACS from the Department of Science and Technology, Government of Madhya Pradesh. Sanjay ji, please welcome me. Please welcome Sanjay ji out here.
Good afternoon. And as Mr. Pal has just mentioned that it is very difficult to have a session post-lunch, I'm here to invigorate the session. I'm here to offer you another pie, and that pie is of semiconductor business, and that pie is expanding. So I'm not here to tell you about how we are going to compete with Gujarat or Rajasthan or any other state, but I am just here to tell you how the states and the government of India is collaborating. So here is the offer, here is the recipe that we want to offer from heart of Madhya Pradesh with a very warm heart, that is state of Madhya Pradesh. We have as a strategy, we don't want to focus on the fab manufacturing, as we understand that it is a capital intensive, and we have a neighboring state which already has an ecosystem getting developed for the manufacturing part of it. But if you see the whole pie of the manufacturing sector, it's about 50% which comes from a design as well as R&D, and then on the packaging side of it. And if you take that, we are designed to focus onto the R&D and the chip designing, and also on the packaging side of it. Though we are welcoming the manufacturing also, and the policy suggests that whatever offers are being made by the state of Madhya Pradesh, no other state is able to match with that. Coming with this, we have a strategy, but we also have an intent. And intent is shown when we actually give you the policy assistance that we do. So if you talk about the three pillars that we were discussing about, whether it is chip designing, whether it is manufacturing, or whether it is packaging, if you look at the chip design part of it, there's a lot of incentives that we are giving. We are giving 25% of CTC on each employee who is involved in the chip design if they are housed in Madhya Pradesh. We are talking about rental assistance. So if you have a plug and play, essentially the chip design happens not in the factories or into workshop, but it is in the plug and play facilities. There also we provide the facilitation in terms of giving you the rental benefits. Then we talk about taking care of the EPF employees, because we understand that essentially the design is all about employees' welfare and taking care of the high salary that they need to be supported with. If we talk about product development, if there is a design-linked incentive that we have devised, that if there is nothing that we have as a product, or if the government of India has not approved of it, then we would provide 25% of a development cost, which is approximately 50. So 25% of a development cost is essentially 50%. If the government of India has already financed, so it becomes about 75% of the subsidy to the manufacturing companies. We talk about DLI that being given. If it is a design-linked incentive, we are saying that if it is not approved by the government of India, then you get a 25% on the project cost. If it is approved by the government of India, we also give you seed capital. Even before you start with your manufacturing, you actually get a seed capital of 10%, and when you are able to do the 50% of your project commissioning, we provide you another 15%. So we are open to inviting the industry to come forward and establish their shop in case you want to progress in Madhya Pradesh. If we talk about manufacturing, we are providing, as it is, Madhya Pradesh has a very cheap land rates. We provide about 75% of rebate on the cost of the land. There is no stamps duty, so 100% of stamp duty is waived off. The projects that are not approved by the government of India, even if, so you have a policy where the government of India approves the project, which is about 50% of the capital cost that is borne by the government of India as a subsidy, and the states do the matching share. In case of Gujarat, it is 40% of the total project cost, which is about 20% of the 50% that they are giving. In case of Madhya Pradesh, we are giving 40% if you are not approved by the government of India, which means essentially we are giving it. But if you are approved by the government of India, then 25% of the total project cost, which is 50% of the approved cost of the assistance that the government of India giving. So practically, any industry that wants to set the shop for manufacturing in Madhya Pradesh, you get a straightforward 75% subsidy into the manufacturing part of it. On top of it, the money that you are borrowing, you would get an interest assistance. You would also get a power tariff rebate of 2 rupees per unit, and you also get a customized package. Over and above this, if you are making an investment of 400 crores, which is practically for all manufacturing capacities, if you are into the fab manufacturing, you can always come down to the CCIP, which is chaired by Honorable CM, and you can ask for additional benefits that you can want for. But this is not all. We understand that it is not about the design, it is not about the manufacturing or the fiscal incentives. We also understand that the back or the bone behind this is essentially the skill development, and we are encouraging academia, industria engagement, as well as giving the support for achieving the upskilling for any of the individuals. So if you talk about any industries, and you talk about any undergraduate who is willing to upskill themselves into any of these semiconductor ecosystem for electronics and VLSI design, we provide 20 lakhs of subsidy for each candidate. We have an outlay of 50 lakh rupees for each individual institute if they are running a course which is essentially for a VLSI or semiconductor design. We are reimbursing 50% of the cost to the employer in case they want to subscribe or in case they want to forward their employees for upskilling. Whatever expenditure they are going to incur, we are going to contribute 50% for each of that employee. We are also looking at internship support to the students who are actually right now in the colleges to get 10,000 rupees to 12,000 rupees as an internship support per month if they are getting interned into any of these schemes. And we also provide tape-out facilitation so that the students are encouraged to have a chip designing, and for each tape-out, we provide 5 lakh rupees to the students. So that is a kind of skill development support that we intend to give to the students. And top of it, if you are having a workshop or a common facility, that also is supported. No other state provides any kind of subsidy to the developer. But if developer is creating an infrastructure or a COE, or if sheds are made by them and it is being used by the industry, then again you get a subsidy on the land as well as onto the capex and also on the other facilitation. So that is a kind of facility that we intend to give in case there are semiconductor industries who are willing to come forward and do the factor. But if you talk about, each one of you would understand that when we talk about the policies, everybody wants to listen to what is the ROI on the investment that we intend to make. And this is a small picture of what we have actually proposed to the industry in case you are setting a shop in Madhya Pradesh. And it is that if you invest about 10 crore rupees in a chip design and R&D facility, you get an assistance of approximately 30% directly. And on top of it, you can also have other assistance in terms of skill upgradation, in terms of industry academia support, in terms of APEX. But this is what you get on a CAPEX rate of investment, return on investment. On innovation, if you are spending about 100 crore rupees or 100 rupees, you actually get an assistance of about 50% from the government. So you get back 50% of your investment in a 5 years period. If you are looking at a manufacturing, that you are actually getting 77% back. So 75% on CAPEX, and on the OPEX also, on the other facilities that we provide, you get 2% more. So it is about 77% that you get back when you are setting a manufacturing facility in Madhya Pradesh. And if you are a developer, which no other state provides this facility, if you are a developer, you get back about 27% on the investment that you are making. So if you are either a developer or a manufacturer or a design person, you actually get the kind of benefits which no other state is able to offer. If you talk about the strengths, and somebody was telling me in the morning and the sessions also, but the industry is not about fiscal incentives, it is also about the ecosystem, how you are going to develop. And Madhya Pradesh has a lot of positivities attached to it. If you talk about it, we have 24/7, we are power surplus state, 24/7 energy supply. We provide green power, certified green power to any industry that requires, and we have about 30% of green energy getting generated from within our state. We have, and you know, Narmada originates from Madhya Pradesh. It supplies water to even Gujarat. We have abundant supply of water and a fresh water, the cleanest water that one state can offer. It is in abundance. You have highly skilled trained manpower in Bhopal and Indore. These are the places which are also the cleanest capital in a row, and the cleanest cities in a row for 7 years continuously. And there are competing cities, but none of them could come close to Indore and Bhopal in terms of cleanliness, in terms of highly skilled manpower. And probably Indore is the only place which has IIM and IIT in the same city. And on top of it, if you talk about the numbers, the number of graduates that you are churning out, the kind of institutions that you have to provide the skilled manpower, there are enough opportunities available for each of the industry people to hire these from the institutes that are of world repute and are of very good nature. And if you talk about the latest, when we talk about this, I am coming from right from heart of India. And if you see, the most of the ports, whether you talk about, we are landlocked state right in the center of the country, but we are very, very close to almost all important ports and also the airports. So within 600 kilometers of a distance, which is just about 6 to 10 hours of a journey, you would actually be at any of the ports that are of importance. So this is so close. If you look at towards Delhi NCR region, where the Semicon is developing, where it is just about 3 to 4 hours that you can reach from Gwalior. Essentially 3 hours you can reach from Gwalior to Delhi. If you have to travel to Ahmedabad from the boundary of Madhya Pradesh, it is less than 3 hours. But if you are even from Indore, you are traveling, it takes 6 hours for you to reach Ahmedabad and other places like Dhurera. So this is the kind of distance that you have. So you have vicinity with Kandla, you have a vicinity with JNPT port, you have Paradeep port and Visakhapatnam port, and we have ICDs also supplying, so taking care of your exports and imports, so as to make sure that whatever challenges you have in the logistics is taken care of. And besides that, we have an industrial policy which supports logistics. So we take care of your additional logistic expenditure if you are setting a manufacturing base in Madhya Pradesh up to the port. That is taken care of in the other policy, which is logistics policy, to take care of your concerns as far as this. And when we talk about industry, we talk about incentives, we talk about a lot of things, but we forget to have an employee's point of view, and Madhya Pradesh is very, very ideally and easily discernible that it has its own character. So we celebrate almost all festivals, whether it is Garba, whether it is Durga Puja, whether it is Ganesh Puja, whether it is Muharram. It is all festivals are, it's very, very cosmopolitan. You don't have one particular cuisine. You don't have one festival that you can boast of. We actually are carved out not on the basis of linguistic uniformity, but we are the ones who were left out because all the other states were carved out of linguistic regionality. And Madhya Pradesh is the only state where you will find Gujaratis, Maharashtrian, Marwadis, Punjabis, and Uttar Pradeshi, all of them in equal numbers and being celebrated. So any employee who is otherwise settled in any part of the country would love to come back to Bhopal or Indore because they find an ecosystem which is very, very conducive to them, whether it is social infrastructure, whether it is educational infrastructure, whether it is pubs or cinema theaters. They are abundant in number, and that takes care of your employees' confidence, and that takes care of their concerns. If we talk about other issues that we are essentially looking from the employee's point of view, it is ease of living and work-life balance. And you would see that if you compare with any other big towns or any other cities, whether it is cost of living index, whether it is pollution index, or whether it is traffic commute index, we fare fairly very, very good ahead of most of the cities in the country, and that is where people would. We have an API which is much, much below. Average API is 60 in almost all towns, which is far, far lower than any other states. We have less traffic commute time, and we also have a very, very cheap cost of living, which does not mean that it is not a good quality, but I am saying that it is good quality with a lower investment that you would have to look at. And finally, we have a strategy, we have intent, and we have a commitment, because we are the only state probably which has exemptions from Shops and Establishment Act. So nobody, no labor officer will ever knock at your door. We have unified all labor laws in one single register, which you have to maintain online. So nobody comes to your door asking whether you are maintaining the registers or whether you are following those labor laws. There are exemptions of 22 kinds. We worked out that how many permissions are required. It is about 37 odd permissions which were required by the industry to set it up. 22 permissions have been exempted completely. So even if it is for a red industry, we said nothing doing. If industry is coming up, we will not ask questions. So they have been removed of the 7 departments that were actually trying to do it. We have a public service guarantee, first time in the country which enacted this, the only state which enacted it earlier. Now it's been followed by it, whereby we say that this permission will be given in this much time. So even if the Pollution Control Board is to give the permission, they have to give it in the same period of time. Otherwise, the penalties are imposed, personal penalties are imposed on the officers if they don't do the thing. We have removed multiple laws. We have removed them because we considered that they were not conducive to the industry to set this up. And we have Cyber Tehsil. We now have a system which probably no other state, no other country has, where you can register your land sitting anywhere, anytime. So practically the purchaser can be in Hong Kong and the seller can be in UK, and you can actually register a document sitting in your places at any point of time in any day. 365 days, 24/7, you can register a document. No other state can give you that kind of facilitation. You don't have to go for a mutation. It is Cyber Tehsils. So you don't actually see an officer. The moment you purchase a land, the property registers are sent online to the concerned Tehsildars, and Tehsildars sitting at Bhopal. Even if you have purchased land at Indore, the person sitting in Bhopal would do it online. You don't have to physically visit. You don't have to go and connect with anybody. You don't have to make an application for doing this. It is online on the process itself. So this is the kind of facilitation that the Madhya Pradesh government offers to anybody who is interested in. So we have a strategy, we have intent, we have a commitment, and we hope that the industry, academia and industry will come together to function. And we are here not to compete, but to collaborate, because we understand that there is a huge expanding pie of semiconductor manufacturing business, and we want to be partner and share in the development of it. We are there to help you and lay a red carpet. We ensure that anybody and everybody is welcome, and we are happy that there are some of the semiconductor industry people who have already shown their commitment. They have taken the land and they are starting their operations. I'm not here to disclose their name, but it is known to the industries who have invested in Madhya Pradesh. Thank you very much for having given this time.
Please come up, sir. To present the memento, we have Rajiv Khushu, IESA member and at TI. So please join us in thanking him. Thank you very much. And now we have Shri Sanjeev Gupta with us. Sanjeev is the CEO of the Karnataka Digital Economy Mission. So let's hear what the state of Karnataka has to offer. Sanjeev ji, over to you.
Very good evening, all of you. Thank you so much, ISA, and giving this opportunity. But before I start about Karnataka, I actually want to appreciate Sanjay ji for giving a fresh wave of Madhya Pradesh attraction power and such a great initiatives. Congratulations to you, such a great work that he has done by the government of Madhya Pradesh. Having said this, we all stay in a union of states, and one of the states that comes up is Karnataka, which I want to present to you. Yes, Karnataka is a leading state, and we say it's an advantage Karnataka. And when we say this, we also look at to some of the numbers which India's economy is growing. And how do you see this economy growing much bigger and bigger in the pie of as compared with the other countries of US, India, China, and Japan? Friends, we are not far when India is going to cross becoming the third largest economy in the world. Very, very close to that. By 2030 and by 2050, we would be one of the largest country in the world from the economic power. And if that's the case, the Indian electronics and semiconductor industry is also taking its own shape. In fact, Niti Aayog has projected that somewhere around $700 billion is what we're looking at a market globally. Now, if that's the case, then there's a call for us to look at semiconductor pie for all of us from the different states and industry to work together to occupy the space for us. If you see the local India semiconductor demand, and in fact in this field also we see an opportunity where the local demand itself is growing big. And the reasons for it, the telecommunications, the mobile manufacturings, and the AI wave which is going inside, the consumptions, the data centers, and all that stuff is creating an opportunity for the local domestic consumption going up. We also see that where Karnataka comes as an important play. And traditionally, if you see, we are the second largest from the electronics exports perspective in the country. We are, because of various things that we do in the value chain of the semiconductors, as you see on the screen, from the design services to the manufacturing, to the electronics manufacturing, engineering services, and semiconductor designs, we are there. I don't know whether you know the fact or not, but 100 chip designs offices are in Karnataka plus. Karnataka has 100,000 PhDs, which gives to the high quality talent of the semiconductor industry. Karnataka is the second largest design house in the world. Karnataka is also the fourth largest tech cluster in the world. Karnataka is also the R&D center of almost Fortune 500 companies of the world. So if all these scenarios look at it, we see Karnataka is a jewel in India's economic status, so to say. We are 8% of the population of the country, but we contribute 40% of the electronics exports and approximately 40% of the IT exports as well. So that's the way the state has been designed for. Well, we are recognized numero uno in various fields, be the innovation index, be the defense, aerospace, bio, we are as ranked as number 1. We want to sustain this power. More and more number of ones needs to come in this circle of numero uno. Why we are so different here? Because of various reasons for it. One is the important part is that the talent which is available in the state of Karnataka is not of as on today. In fact, it's a journey of more than 100 years that the premium talent which has been from pan-India and now across the globe is based out of Karnataka. And that's becomes a very important element of our journey. There are many reasons for this, is that we have the industries which is able to promote more of innovations and R&D work which happens in the state of Karnataka. The other element is the startup ecosystem which is flourishing in the state of Karnataka is pushing up the index further and further up. Out of 100,000 startups in the country, the Karnataka has more than 25,000 startups. The first experiment, in fact, I have set up an ESDM task group by the government of Karnataka, which is led by none other than Mr. Jitin Chandraji, who is sitting here with us. Thank you, sir, for giving us those advices and strategies to execute on the ESDM side. He has also been a very important player in designing the fabulous accelerator called Safal. And that fabulous accelerator Safal has become an example in the country. How do we create more fabulous startups and entrepreneurs where industry comes on a board and give them the mentorship and tools and technologies? And that's the best example for that. Just a hand of applause for Mr. Jitin Chandra for helping us to doing this. Thank you so much. The other elements is the policies that the government of Karnataka does is, the government of Karnataka positions the government of policies in such a way that all the policies are targeted on what we say and what we deliver. Our policies are much more future-oriented. In fact, the first R&D policy in the country was coming out from the state of Karnataka. The first GCC policy now also is coming out in India is from Karnataka as well. So on the policy front, we are the leading state. If I take you another example of some of the areas where we are working on, which could be the areas of infrastructure. We have developed the airports. We have 2 international airports. You know the Bangalore airport. And then closer to the Bangalore airport is also regarded as the 3rd largest airport in India. It is also regarded 1 in terms of the customs clearances, ranked number 1. That means the processes are laid down in such a way that the industry feels ease of doing business in the state of Karnataka amazingly great. Plus the Bangalore airport, the ports that we have, and the nearest ports which are available also. So all those phenomena gives us the potential for Karnataka to be the leading state in the journey of electronics. There are 4 industrial belts that we have come out in different parts of the state. In Mysore, in Belgaum, Hubli, in Tumkur region, all those ranging around 230 to 240, 50 acres of land. I'm very happy to share with you that not only Bangalore, but the electronics manufacturing is very popular outside Bangalore. For example, in Mysore, we have 4 EMS big companies ranging to revenues between 600 crores to 1,000 crores of revenues. We have India's largest PCB board manufacturing company in Mysore. So all these facts of the electronic system and components and electronics manufacturing of the, let's say, automotive electronics or defense electronics or healthcare electronics, all of those part of this. Very happy to share that those are based out of these locations called Mysore, Tumkur, Belgaum. Recently, the NITEC has also set up a largest manufacturing of their equipments in another region of Hubli. And we see that momentum coming in. So now their suppliers are also looking at to see how we can collaborate, how we can work together. What I wanted to convey a message to all of you is that, yes, there are various components of the semiconductor which works on. Any brand that you pick up from the perspective of semiconductor is available in the state of Karnataka. And those brands which are, I just take you a little more further up slides. We have also got a very unique innovation ecosystem. Friends, I need your attention because this is very important for the future perspective. I don't know if you know the fact or not. The largest employer for tomorrow's economy is going to be the startup. And for that player to come in place, you require to set up an ecosystem as on today. We have more than 20 centers of excellence set up in different fields of the electronics, which are catering to innovation, the skill requirements in future of those technologies, and bringing industry as a corporate partner towards designing the new wave of technology growth. And that's the best example that we have. The India's largest AI Center of Excellence, Art Park, is based out of Bangalore. Biosciences, life sciences, nano, all of the largest Center of Excellence are based out of Bangalore and Karnataka. We are also taking this further, going to let's more of the other cities in Karnataka, in Mysore and other places, to put together those Center of Excellence. No other state has a program called as Elevate program, where we give grants up to 50 lakh to an entrepreneur. And today, till date, roughly around 1,000 startups has gained benefit from this, with roughly 280 crores as a grant money given to them. No other state. And that's the reason today Karnataka is recognized as the unicorn hub of India. Out of 100 unicorns born in date in India, 105 or so, 47 are born from Karnataka, out of 105. एक ताली बजती है हमारे लिए भी. Thank you. Thank you so much for motivating us. The way that we see is very different lens. We see the Center of Excellence will play a very important role in creating the power of knowledge from a corporates to the upcoming new technologies. And that's the way that we design the Center of Excellence. You look at the who's who of the semiconductor industry based out of Karnataka. The slide which shows you gives you the clear picture in terms of our deep semiconductor presence and the wideness of the semiconductor industry that we have. But we are hungry. We're hungry for more. We want to have the largest share of the technology devices coming out from Karnataka. The sophisticated chips we can designs and possibly manufacture in Karnataka. Not only just looking at the testing part of it. In fact, Sanjay ji talked about the value chain of the semiconductor. Except the manufacturing, we are everywhere. And in that value chain, if the manufacturing comes in, the only place in India you will find end-to-end of semiconductor, and especially from ESDM side, is one place in Karnataka. Sometimes it says that, अगर आप कर्नाटका पे नहीं पहुँचे, तो शायद आपने इंडियन इकोनॉमी को महसूस ही नहीं किया. So please connect with us. Look at the pulse of semiconductor industry from the eyes and lens of the state of Karnataka. I also reviewed examples of many in this kind. There are policy benefits to talk about. My last slide and my request to you is, we are there not only to say that we are great, but we want to be there to say India is great through the window and opportunities that Karnataka offers to the world. With this request, please allow me to connect with you all the time and be your friend in the journey of your growth and industry partnership. Thank you so much.
So you can stay back for a moment. And I request Mr. Sunny Malhotra to present the memento to Sir. We also like to call upon Hemang sir. Sir, would you like to present a memento to Hemang sir as well? Thank you very much, sir. Thank you. As we move forward, we have an exciting lineup of keynote addresses, followed by a thought-provoking panel discussion on talent, skill, and capacity building, a crucial topic in today's evolving semiconductor industry. We have a keynote address. And to begin with that, we have Mr. Dinesh Munireddy, Senior Director of Software Engineering at Lam Research. Welcome, sir. With extensive experience in software engineering and innovation, he plays a pivotal role in driving technological advancements. Please join me in welcoming Mr. Dinesh Munireddy to the stage. Wake up, folks. Thank you.
Good evening, everyone. I know this is a fag end of the day, but we have a few important topics to cover in this last session. One of the things that we hear is semiconductor industry is booming in the country, and there are a lot of companies that are coming to set up semiconductor wafer fabrication manufacturing plants here. Now, what I'm going to talk about is in this process, how important it is to develop the skills and what is one of the areas where the skills can be developed and how Lam Research is helping to the cause. So quickly moving on. So as we all know, our world is critically dependent on the semiconductors as we move on. It is used everywhere, starting from our homes, smart homes, all the way to the automobile industry, getting into the two-wheelers, four-wheelers, as well as we are talking about medical industry. Everywhere we need chips. And in order to have those chips need to be manufactured. And so the semiconductor today is known as the chip manufacturing is known as the new oil, where we are very critically dependent on that. Now, to do this, companies like Lam Research play a significant role. We have been, our company has been there for over the last 45 years. And we are a global leader in wafer fabrication equipment and services that we provide to companies like Intel, Samsung, TSMCs, and so on. And in our country, when Tata comes up, Lam also will play a huge role in kind of providing equipment to the ecosystem. Now, in order to have talent that is needed to manufacture the equipment that we deliver, we source talent from all over the world. As you see, though we are headquartered in Fremont, we do have offices all across the globe. The right kind of innovation, we do source the talent from all across the world. And in India, we are present in Bangalore, where we have a second largest engineering R&D center, where we actually have the skills to go ahead and manufacture our equipment and provide services to our customers. And semiconductor industry is not, the top 21 semiconductor companies are all across the country already. And to add to that, we have seen new upcoming semiconductor plants that are being starting. Since morning, we have been hearing on companies like Tata, Micron, and other companies which are setting up their plants all across the country. Now, while this is an exciting time for our country, exciting time for the semiconductor and the chips that is needed for us for our consumption, we do have certain challenges. And the biggest challenge that we have is the skills that are needed to go ahead and run these fabs. What we do not have is an ecosystem in terms of industry where we need to have an equipment to get on-hands training. The skills are needed in abundance, and we keep hearing 80,000, 100,000, and more than that in terms of the number of people that are needed to get skilled to work in these companies. There is a shortage of students and the trainings that are needed to go ahead and take forward for that. So how do we fill in this gap? This is something that we'll cover as we move forward when we talk about those challenges. So one of the potential solution to address this skills gap is to provide virtual training. So as I mentioned, in order to train the students in the semiconductor areas, you need to set up a fab, and that fab needs a lot of money, infrastructure, and in order to maintain, also you need to have millions of dollars. So it is not practical for us to have all these fabs set up for just to do the skills development program. So in order to close that gap, we can actually have a virtual solution which mimics the solutions that we provide through our equipment. In this process, the students can go ahead and learn, which they can put to practice when they join the companies. And this is one potential solution that we have. And this leads us to a potential solution that we have in terms of a virtual fabrication solution that we have in the form of simulator 3D. Quickly going on to talk about what simulator 3D is, I want to take a step back and talk about virtual twin. So what is a virtual twin? Virtual twin is nothing but a digital representation of a physical entity or a physical product system and physical processes. So anything that is physical that can be represented in the form of digital, that is known as a virtual twin. To the right, you see an image which actually is a representation of of a city in various layers. To the bottom, you will see a subway system. On top of that, you will see plumbing, electrical cabling, and then you do have streets, and then you have the ecosystem that is needed on the surface level, and then you do have the buildings and the architectures. Now, think of virtualizing all these things. Each of these layers, you can go ahead and literally do a virtual twin and have it mimic exactly to what and how they are operating. Similarly, if I have to take this context in the context of semiconductor industry, at LAM also we do have multiple scales of virtual twins. At an equipment level, we do have the overall equipment can be mimicked as part of a virtual twin. In terms of subsystems, within the individual modules, you can go ahead and have a virtual twin for those subsystems. And getting into the wafer layer, you can also have a feature level virtual twin that can be done. When we talk about simulator 3D is an application that helps us be a virtual twin, virtualization of wafer level fabrication for us to look at the characterization and so on. And this is where we see students, when they get hands to this application, they will learn quite a bit, and then that can be practically applied when they go ahead and join the companies. Now, simulator 3D is our process modeling application, and we do have several benefits when we talk about this. So the first thing that we look at is any wafer, when we have to go ahead and develop a footprint of that, we can do virtualization of that, right? And the second thing you look at is the environment. Now, for the actual thing that needs to be developed, we can go ahead and fill in the gap between what can be done on hands on the equipment and what can be done using the application, so that they understand the process intricacies of that. It also forms a democratized solution for all the universities, irrespective of whether the universities have the infrastructure and ecosystem that is needed. They can go ahead and do this because our application runs on a laptop, a common laptop, without needing additional computation power. So they can use this application, then go ahead and learn. Now, how this will benefit the students? When we look at here, so this application, if you see that is the virtualization solution that we get from the application. First, it will help the students understand how to create a 3D structure from the scratch by altering various characterizations that is needed. So students will be able to go make the changes to the DC power supply, the process gases and elements, and actually literally go see how these changes are affecting to the final end product of how the wafer is constructed. And then it also helps them understand, so in real life, someone will have to go ahead and process the wafer on the equipment, take it out, take the SEM model, and then do the measurement using microscopes. With this application, they will be able to do those measurements literally on that application software. And they also, in this process, can see how the device can fail, make adjustment, and see how to make it work again. So in this process, they will be able to learn fast and fail fast. And last but not the least, they can perform the advanced technology co-optimization, going from one node to the next node so that they can do these experimentations well. So literally, this application provides all the abilities and capabilities that are needed for them not only to learn, but also to optimize and fail fast. Now, this also meets diverse needs of university and industry. So when we talk about this, there are basic users who are actually trying to just run and provide the solutions. And then there are users who does design of experiments. There are power users and super users going all the way across multiple verticals in the process technology. All of them will be able to use this application. Now, after giving the background of the application that we have from the company, in 2023, our Honorable Prime Minister visited White House, and there was an MOU signed in the presence of the then President that LAM Research will help upskill 60,000 students over the next 10 years. And then since then, our journey has begun. Now, I will take a brief detour and talk about Simulator 3D, why we picked this as an application which will help us upskill 60,000 students over the next 10 years. Simulator 3D is something that is a proven application which we have deployed across multiple universities across the world. Now, in order to take this into our country, what we wanted to do is start with a pilot program at Indian Institute of Science. And that is when we said we will go ahead and take it from there. So I talked about Simulator 3D. I also want to let you know that we actually have created an MOU, and we want to deliver the skills development for 60,000 students over the next 10 years. And I also mentioned that we have signed an MOU with IISc to do a pilot program, and then we have a tripartite agreement that we have signed with ISM, MIT, and IISc. So a quick run through the journey that we have. To establish this program in 2023, we said we will do a pilot program. With IISc, we just restricted it only to IISc, and we did a skills development pilot program at IISc in 2 sessions. After first pilot session, we actually got some inputs from the university as well as the students, made changes to the curriculum and the presentation and the application that we need to deliver. And finally, by June 2024, we finished the second pilot program, which we were in parallel ready to go ahead and deploy it across the country. Now, in April 2024 is when we had an agreement signed, MOU between the IISc as well as the Government of India, MITI and ISM. And from April to September, we actually did invited all the universities across the country. Based on the tripartite agreement, there were certain conditions we had to look at, and we selected the top 20 universities out of the 65 universities that came across. And then in November is when we invited those universities. 14 of those universities participated in the skills development program. We trained the trainers with the help of IISc professors. And in December is when we sent an NDAs and MOUs with all these universities, where the universities can go ahead and deliver those courses. As we speak, I'm really pleased to say that we have distributed more than 830 licenses to all the universities, and more than 525 students, as we speak, are being given skills development through these professors who learned, and they have initiated these courses across 10 universities. More universities will join the bandwagon, but I want all of you to kind of recognize how soon that this skills development will balloon towards the 60,000 students over the next 10 years. So we are continuing to open these registrations for all the universities across the country. And for spring 2025 coursework, we do have the following universities from all across the country, northern region and southern regions as well. And if you have any further questions regarding this skills development program, you can write a note to semiverse_stimulator3d@lamresearch.com. I will be more than happy to help you all with that. That's all I had. Thank you very much.
Thank you very much, sir. And I would now request Dr. Manoj to kindly present the memento to Mr. Muni Reddy, who has just shared his insights and perspectives with us. Thank you very much, sir. Next, we have a keynote address by Mr. P.R. Sivakumar, founder and CEO of Maven Silicon, a leader in VLSI design training and workforce development. His expertise has been instrumental in bridging the skill gap in the semiconductor industry. Please help me welcome Mr. P.R. Sivakumar. And I now request all the speakers to kindly adhere to the time. Thank you.
Good afternoon, everyone. I would like to take this opportunity to thank IESA and our industry for this amazing opportunity. IESA Vision Summit is a great conference for entrepreneurs like me who want to share our vision with the industry folks and the engineers community. Great. Today, I'm going to talk about how AI, artificial intelligence is transforming our industry and how we can help the next generation of chip designers to build their long-term careers in the AI-driven semiconductor industry. All right. Maven Silicon, we started our journey with training new college graduates as a finishing school in 2010. Continuing this incredible journey for more than 15 years, we have deployed more than 5,000 chip designers in the semiconductor industry. And in this journey, we collaborated with Tier 1 global chip makers, services companies, and various fabless IP companies. And Maven Silicon has also been designated as an approved training partner by ARM and RISC-V International. So with this domain expertise, now we emerged as a center of excellence in semiconductors for academia and industry. About our partners, we work with various non-profit organizations like IESA, ESSCI, NSDC, and we also partner with our academia partners, IIT Guwahati and PES University. That's about Maven Silicon. We offer various kinds of VLSI courses for working professionals. We are ARM-approved training partner. As an approved training partner, we are there to train your engineers on ARM architecture, various architectures. We can even train them on ARM-based SoC, how to build system on a chip using ARM and how to verify them. And we can also train your engineers on RISC-V architecture. We offer various courses, VLSI courses for experienced engineers. Please take a look. This is how I planned my keynote. I'll start off with the history, how the industry is evolving. We need to know the history so that we can learn from our mistakes. Suppose we want to do something new in terms of creating IPs, then it's important for us to recollect the history. What worked, what didn't work, that's important for us. And then I want to explain how we contribute to the global semiconductor supply chain. Then I will take you through AI-driven semiconductor industry, how this industry is evolving. And then finally, I'm going to talk about how we can guide the next generation of chip designers, basically how they can build their long-term careers in the AI-driven semiconductor industry. We started our journey in 1960. Global chip makers like Intel, Texas Instruments, they used to make chips for products like calculator. That's how we started our journey. Then there were many players, they were making chips for PCs. And then when Steve Jobs introduced touch phone, smartphones became popular, and we were there to create different kinds of chips for smartphones. And then IoT became popular, and today we are talking about creating various kinds of AI chips. The most important thing that I would like to share with you is the technology, how the technology is evolving. Our journey started with Intel's x86 CISC processor, complex instruction set computer. And then ARM's RISC processor became popular, reduced instruction set computer, primarily for devices like smartphones. And then NVIDIA introduced GPUs, primarily for video games. But today, we use GPUs extensively for AI workloads. And today, we are talking about a RISC-V open ISA, open instruction set architecture. I will explain it a little later. Again, you look at how the progress has been in fabrication and EDA. We started our journey with older technologies like 180 nanometer. Today, we are talking about using technologies like 2 nanometer and higher nodes. There are various things happening, but if I consider the major transformations, what I would say, all the OEMs and software giants, companies like Apple, Microsoft, Meta, Amazon, they all design their own chips to differentiate their products and services. The other thing is, the entire world is trying to balance the global semiconductor supply chain due to various reasons like geopolitical situations. Every country is gearing up towards having a good semiconductor manufacturing ecosystem. And the third thing is, AI is changing everything in semiconductors. So our industry is going to evolve as AI-driven semiconductor industry. RISC-V is an open ISA. This is something special for the next generation of chip designers. RISC-V is going to emerge as an industry standard ISA. What it means is actually using this processor, engineers can think of creating various kinds of processors. Using this ISA, they can create any kind of processors like CPUs, GPUs, NPUs. So it's going to emerge as an industry standard ISA. What it means is we don't really need to deal with too many ISAs, right? We are fine with general purpose ISAs. Take a look. They can survive for more than decades, but you consider the specialized ISAs, they will not survive for long. That's where we need open ISA, something like RISC-V. So you get IPs and chips from countries like United States, and what we do in India, actually we provide design services to the global chip makers. So in India, we have army of engineers for design services. We deal with design verification and physical design. So beyond design services, it's time for us to create a good fabless IP ecosystem. Of course, manufacturing is happening. It's happening everywhere. What if we want to create advanced chips for our own consumption? Chips for defense, our own chips for space, right? So we need to think about it. We have been supporting fabless IP ecosystem in India. We upskill engineers and we deploy them as chip designers in the industry. And now we are looking at how to support even the manufacturing ecosystem. We have signed an MOU with NSDC to support our academia partner, IIT Guwahati. Now, IIT Guwahati is offering various executive programs and job-oriented courses for the new college graduates, executive programs for the working professionals, and job-oriented courses for the new college graduates. Let's take a look how the industry is going to evolve further, AI-driven semiconductor industry. AI demands advanced data centers. So we need to create new kinds of CPUs, GPUs, accelerators. We would be looking at various options like 2.5D or 3D packaging or using chiplets to create advanced AI chips. And whatever the chips we are going to create, that will help AI to evolve further. It's going to accelerate the evolution of AI. And AI evolves. Obviously, it will be used extensively for the EDA, electronic design automation, and that's going to help the industry. We would be able to create more and more complex chips, and this is cyclical. This is how it's going to happen within the industry. And the evolution of AI will help us to deal with various things like design, chip design, We would be using various kinds of agents. Even for chip verification, we can think of automating the simulation process. AI will help us to generate test cases. AI will help us for the coverage closure and various other things in EDA. AI will be used extensively in EDA. I would say like even the future is going to be something like EDA versus design services, right? So they would be looking at like how to replace more and more resources. They would be collaborating with global chip makers like, hey, we are there to help you to deal with complex chips. You don't really need too many engineers. We can reduce the cost. So definitely the future is going to be something like EDA versus design services. And for other things like chip implementation, fabrication, silicon testing, PCB, everywhere AI will be used. So what I would say for the next generation of chip designers, AI will not replace subject matter experts. So it's time for them to understand the systems, how we build SoCs, something like M-series chips or A-series chips, how Apple makes all these complex chips. That's what they need to understand. Even entrepreneurs, they need to think beyond design services. So the future is going to be something like this. This is my quote. Let's design AI chips and let AI implement its AI chips, which means the implementation will be taken care by AI, and we are there to design the chips. So this is the program we are introducing as a trailblazer. First time Maven Silicon is introducing an executive postgraduate program, postgraduate degree course for working professionals. It's called as RISC-V powered postgraduate degree course. Take a look. In this course, actually, they designed the SoC using RISC-V processor. They verify the SoC using methodologies like UVM, and then they implement the SoC, and they will also learn how to design various kinds of accelerators. And there are modules like GenAI for VLSI and design automation using Python, machine learning for EDA. There are various other modules. So I would like to take this opportunity to thank you all. Thank you.
Thank you very much, Mr. Sivakumar. And on this vibrant occasion of Semiconnect and ISA Vision Summit 2025, we are ready to brochure launch of the Executive MTech in VLSI design for the company, Maven. And I would like to call upon stage Mr. Ashok Chandak, President ISA, and also the senior dignitaries from Maven, Ms. Pravina, Mr. Hem Chandra Bhatt, Mr. Uday, Mr. Viresh, Mr. Sonu. At Maven Silicon, we are committed to aligning with India's ambition to be a global leader in the semiconductor industry. Our mission is to bridge industry skill gaps and build a highly competent workforce. We extend our heartfelt gratitude to ISA for this incredible opportunity to launch a premier program designed to equip the semiconductor workforce with cutting-edge skills and drive industry excellence. Can we extend a great round of applause to all of them? Congratulations to all of you. And Ashok sir, we would like you to present a memento to Mr. P.R. Sivakumar. Thank you very much, sir. Now we are honored to hear from Mr. Ranjan Bandyopadhyay, Chief Human Resources Officer at Tata Electronics. He will share his vision on workforce development, a key driver in shaping the future of the semiconductor and electronics industry. Please help me welcome Mr. Bandyopadhyay.
Good evening. Good that I'm a nervous speaker and there are very less people, so I can say whatever I want to, and I'm hoping people don't sleep, like, some of the people doing there. Two things I wanted to say before I start the presentation. A is, for any organization to start, we would need capital, technology, and talent. In the talent space, then we talk about talent, man, machine, and process. Woman, man, machine, and process. So I'm going to cover those three aspects. And the way I'm seeing it, I've broken my presentation in 5 parts. Global talent availability, gaps, future ready, and the two speakers spoke about digital twin, mixed reality, and others mentioned, and attrition challenges, attracting challenges, and mitigations thereof. Because unlike what's happening in Taiwan or other countries, we have been talking about social infrastructure, but it's very difficult because not much is happening in Dholera from that perspective. We have been talking about semiconductors since morning, but one most important aspect is we'll be among the top 5% of the countries in the world to have joined the semiconductor space. I'm talking of the wafer level manufacturing, not talking about OSAT, which we are putting up in Dholera. I'm just talking of, putting up in Jabil Road in Assam. I'm talking of Dholera. And as you can see, that we have lots of design engineers, especially in the south, but we don't have many semiconductor resources in India. My father used to say that brain drain is better than brain in the drain, that point in time. Now we want to do the reverse of it. How do we bring back Ghar Wapsi, the new word for us, and we are trying to do that. So if you see, for Tata Electronics today, we have about 350 international hires. We have hired from 15 countries, some of them in Dholera, some of them in Jabil Road, some of them in Bangalore, some of them in Hosur. But it's a very, very uphill, it's a difficult task, because why should anybody come to India from an advanced country? If you want to bring somebody, they would want their salaries in dollars or equivalent, plus, and all the facilities that one could provide. It's a very costly proposition. But when you don't have talent, you have to have seed talent from overseas. I'll be talking about it more. And the ecosystem, like I said, at least in Bangalore or in Hosur, we can manage. Jabil Road is very close to Guwahati. It's okay. Dholera is quite far. So if I look at it, we are talking of 25,000 jobs. Whatever my numbers here are at is at the wafer manufacturing level. I'm not talking about OSAT. So please bear with me if you see the numbers as less, because people are talking of 1 lakh, 2 lakh, and I'm talking of 25,000. So please bear with me. I'm just talking of wafer level, because we might have this fab today. Some other companies might come tomorrow. And the numbers that I see is 25,000. Taiwan and Korea has, almost, I don't know the numbers, many more semiconductor professionals there in the country. But if you look at the world, you will see about 22% of the semiconductor professionals are Indians. And getting them back is also becoming a challenge. So if you can see Lawrence there, we brought him from Singapore. My talent acquisition head sits in America, Phoenix, And it's a completely distributed model because that's how we are going to attract talent. This is about India. The ones in dark blue are the places where we work. And I'll be talking about Gujarat in the next subsequent slides. And as you can see that Karnataka, the entire south, has a tremendous pool of engineering talent. If we look at Gujarat, Gujarat is a fantastic place to be. We are working with a skills mission. We are working with IIT Gandhinagar. And of course, in my subsequent slides, I'll also be talking about the other places that we are working with. And you know, what we are doing for Dholera, as we speak, we are conducting a socio-economic study of the region. And we are looking at opening skill centers in rural Dholera, in and around, so that we can empower the local people to get jobs in the semiconductor fab that we are creating. So that's the intent. Yeah, so like I said, today we are working with IIT Gandhinagar. Tomorrow it could be NIT Surat, it could be Nirma, it could be GTU. And I also heard Kaynes talk about Shastra. We have been working with Shastra on VLSI for about 4 years now. And definitely other places that we need to. We have also recruited a professor of practice who is going to come from the United States to sit in IIT Gandhinagar and work with us to bridge the gap between academia and industry. And we are also going to put in a lot of equipments and other things for people to, for students to experiment and work around. So, 5 levels of intervention, like I spoke about the socio-economic study and what we are doing. I also spoke about the international hires that we are getting. The challenge for India will not be to bring in international hires, but also to make the skill native. And for us to make skill native, we have to go in for talent development. We also have to have students involved in research projects. We have to look at IP and other things, have hackathons. So those are the 5 levels of intervention that we are talking about. My PPT is out there for everyone to take. And I would definitely stick to the time because, I don't want the lady in blue to come and tell me, yeah, 5 minutes left. So this is the skilling schema. This is the 3 dabbas. One is talking about our external focus. The next one is internal focus. And third one is how do we look at the future-ready resources. Because finally, the intent is having talent made in India, made for India, and made by India. So that's what we are looking at, completely Atmanirbhar Bharat, and we are working towards that. These are some of the things in the academic area, industry interface we have done for the EMS industry, which is about 4 years old. I don't know how many of you all are aware. We are a very, very young company. We were established in the year, meaning 27th of October 2020, we had our Bhumi Pujan. Today we have 65,000 people working in 5 states, over 1,500 acres of land, and every day we are growing. So this is what we have done in the EMS space. The reason I'm showing this is we'll be doing this plus in Dholera because wafer level fab manufacturing, wafer level manufacturing is something which will help India truly become a superpower. We spoke about digital twins, LAM research mentioned about it. Of course, because today what we have done is we have recruited 120 engineers from IITs and about 20 PhDs from Indian Institute of Science and other IITs, and we have sent them to Taiwan. And they have been training for the last 1 year. And we'll not have this luxury every year. So we would need, because our equipment will start moving in from April 2026, and we would need to deploy all kinds of technology that is there, including hologram, digital twins, of course, and see how do we scale, skill at scale. So these are some of the huge challenges. at least for international hires, you are paying them a lot and bringing them. Why should a young kid go to Dholera? Neither do you have a pub, neither do you have a place to see a film, nor do you have a swimming pool, nothing. So I think social infrastructure is something that the government has to seriously think about. Only having hotels will not work, or having a fire station. Fire station is definitely a need. It is not a luxury, but a need. We'll also be having our own fire stations and things like that. Social infrastructure is something extremely important, not only for international hires, but also for our kids to come, having the right schools, having the spouses engaged in some activities. We are on our own. Tatas will go for a township, Tatas will go for their own mall, Tatas will have their own hotels, hospitals, but the government should also participate equally. By now, they should have done something. Even the roads are not made properly. Once the international hires come, the problem is for them, they are going to work and coming back home. Only thing that they see is the road, which might not be as good as the country, but the work environment, everything is same. For the spouses, it's very different. How do we involve the spouses? How do we look at creating global villages? How do we help them get jobs? How do we make them part of our purpose? How do we ask them to volunteer is something that we are looking at. And this is, I think, one of the major successes we have had in the last 3.5 years, creating a community of purpose for the spouses. And that's pretty much it. And I have completed before, not only 15 minutes, I have completed in 10 minutes, right? Thank you very much.
Thank you, sir. Good job. Thank you, Mr. Bandyopadhyay, for those thought-provoking insights and also for completing. Sir, you can hold yourself, please. Completing well before time. I now call upon Mr. Ved Prakash Pal, Director, IESA, to kindly present a memento and also say thank you personally or from our behalf. So we can truly say Tata sets the benchmark. Thank you. Up next, we have Mr. Murthy Murugaya, Senior Director, Asia RBP at Micron. With extensive experience in leadership and talent strategy, he will be sharing his thoughts on the workforce landscape. Let's give a warm welcome to Mr. Murugaya. Welcome, sir.
Thank you. Good afternoon, everyone. Okay, so it's already 5 o'clock in the evening. So I'm a little curious to see the absorption rate or the attention power for each and every one of us. But I think all of us can do our best. I'll try to do my best, and I'm sure that each and every one of you will be able to do your best in order to stay with me for the next 10 minutes, in order to absorb whatever that I'm going to be sharing with all of you. I do not have any slides for today because I know I have 10 minutes. And a brief introduction about myself, as what the Madam MC mentions, my name is Murthy, and I head Micron Asia from the human resources perspective. And so I like to say that I'm responsible for 40,000 Micron employees to bring their best self to work every day. Okay, so that is what I do. And I look Indian, and I'm an Indian origin, but I'm from Malaysia, actually. So my grandparents migrated from India to Malaysia 2 generations ago. And so I'm Malaysian technically by citizen, but of course I've had a very close relationship with India. And I have been tasked in order to help set up the Sanan Micron site a year ago. So I've been in Gujarat for the last 1 year plus together with my team here. So what I'm going to be sharing with you is about my personal experiences in terms of bringing up the site. So whatever that I'm going to be sharing with you today is more about what we have done at Micron in terms of attracting and retaining talent. So from today morning, if you have been here, I'm sure that you have heard about Micron being the pioneer. Am I right? Okay. So we saw the, it's like a rhyme, powered by Tata and pioneered by Micron. So I find that to be very interesting. So when we talk about pioneering something, and I know that a speaker, one of the speakers, he used the word trailblazer. So, and I really like that word a lot because how many of you here like hiking or mountain climbing? Okay, I'm sure that you will be able to relate to what I'm saying because when you hike or when you go down a certain path where people have used the track multiple times, it's a lot easier, right? But every now and then you want to try out a new trail, and let's say if it is an uncharted trail, so you find that extremely difficult and extremely challenging because now I'm a hiker, so I have a group of friends that we go regularly, and we every now and then we would like to venture a certain trail which has never been charted before. So you will discover, for every 10 steps, you discover something new, either an obstacle, either a challenge, either something new that you have never seen before. It could be an insect, it could be a snake's den, it could be a branch, it could be a kind of plant, that can scratch you, a lot of things that you go through, right? So when I was asked to look into this project, I was extremely confident because in the past I have done 3 brand new startups on assembly and test in other locations of Micron. So I was extremely confident that we'll be able to do this, just like any other site. So until I came here a year and a half ago, so I had a very interesting meeting with one of the manpower agency with whom that we wanted to work in order to have our headcount supplied, right? So I was having a conversation with that gentleman, and he told me, Murthy sir, you don't worry, okay? I have been in this business for the last 10 years. That company A, I have supplied 2,500 people within 1 week. That company B, I have supplied 1,500 people within 2 days. So I will be able to give you whatever headcount that you wanted. And that really shocked me because that's when I understood one of the most prominent manpower supplier, they do not really understand what is the kind of skill set or what is the kind of talent that we are really looking for in the assembly and test space. So, and that's when we got together as a team that we decided we will not be able to 100% depend on the pre-existing ecosystem, but we have to co-create an ecosystem. Okay, we have to co-create an ecosystem. So that is what we embarked on 1 year ago. Started working very closely with universities, started working very closely with skill development centers, started working very closely with polytechnics. And I can give you a couple of examples, some real life examples, nothing conceptual here. It's not only purely a theoretical thing, real things that we have done. From the academic standpoint, so we knew that, in India, talent, when we talk about from the VSLI standpoint, so we have more than enough. A lot of supply in the marketplace, and that's a talent that we don't have to worry. But when we talk about assembly and test manufacturing, and that is pretty scarce, and that is something that we have to really work towards. So what we did, we brought our team together all across the globe, and we created a module or a curriculum called ATMP, or Assembly Test Marking and Packaging Program. It's a 42 hours program, designed and developed the Micron subject matter expertise, and we gave it to first 7 universities in Gujarat. And very, very generously, they accepted, yes, we love it. We would like to incorporate this as one of the elective program in our BTech program, and they accepted it. So the first batch, we had 400 plus students graduated and completed the program successfully. And then subsequently, GTU approached us. They said that, hey, can we also proliferate this in the rest of the universities, which comes under the umbrella or under the ambits of GTU. And we have successfully conducted faculty development program for 132 lecturers. And then the second cohort is going to begin next month I just got the number, we have close to 945 students enrolled from 32 universities. So these are some of the early interventions that we are doing in order to create and shape the talent before they come into the market. So when we say 900 plus students going through an assembly and test, marking and packaging program as part of the undergraduate BTech program, does that mean that Micron is going to be hiring all that 1,000 people? The answer is no, it's not. Of course, I need about 5,000 headcount in the next 3 years' time at our site at Sana and Gujarat. But I only need about 700 to 800 engineers at the most over the next 2 to 3 years' time. But so these are the talent, these are the resources that is going to be made available in the ecosystem. And subsequently, we also thought that there's going to be an enormous need in terms of developing and creating skills at the diploma, at the diploma, and also at the manufacturing specialist level. So we started working with PDU in terms of setting up the Center of Excellence. So we donated 3 equipments, 3 tools, a wafer saw, a die attach, and a wire bonder, and we had to set up the equipments. We trained the lecturers, and we created the modules and also the materials, and we're going to commence the first batch of students of close to about 25 to 35 people, because that's their capacity for one cohort starting from next month. So these are some practical, real examples that Micron have embarked on in terms of preparing the talent at the early stage. Alongside with that, so through Micron Foundation, so we also completely understand, we completely realize that we have to build the ecosystem from the beginning. So the early intervention, just like what I mentioned. So we have set up a science STEM lab at Ahmedabad Science Center, one of the biggest science museum in the country. So we have set up the lab. And to date, in the last 3 months, to date, we have close to about 2,700 students, underrepresented students, who have attended this center and who have benefited. And alongside with that, we have been working with UN Women in terms of providing them STEM education, a program which we are working very closely with a non-profit. And each and every woman who participate in this program will be given a free training for 120 hours, okay, in terms of STEM. And we have set up Maker Lab in 2 different schools within the vicinity wherever that we are operating. So these are the early interventions that we are doing. Alongside with that, one thing that I would like to stress here is that, because when I first came, and so what I was told is that in order to get talent, we have to target, so-and-so universities, so-and-so institutions. That's why we get the quality students. I don't disagree, but at the same time, as an organization, to think more broadly and more holistically to see how we can create an environment so that we will be able to provide an opportunity for people at every level of the society or academic capability to have an opportunity to participate in this great vision and mission so that they too can grow. So in order to realize that vision, Micron specifically, we have created our talent pipelining strategy in a way whereby we go to the tier 1 universities and we hire engineers. We go to even the tier 3, tier 4 universities who comes out with a BTech qualification as our technicians, and we go to ITIs and we bring them, those people who have qualified, who have completed their courses, and we bring them under an apprentice program so that they can go through a 12 months experience with us, and then we can decide whether they can be part of the organization or not. So today, being a multinational in Gujarat, being the pioneer organization in the semiconductor manufacturing space, so we have taken a very broader approach in providing fair and equal employment opportunity to people from every level of the society. And now we are even looking at people with disability, and we are trying to see what we can do with the veteran community. So that as an organization, as much as we would like to build talent, as much as we would like to be the best in what we do, we would like to leverage on this opportunity in terms of providing opportunity for people with variety of skill sets to come in and build a career, at the same time build their dream and build their future. So that is what Micron here is for, and we'll continue going down that path, and we'll be more than willing to share whatever things that we are doing with our fellow organizations who are also venturing into this path in this vicinity and in Gujarat. And at the same time, we are also more than willing, in order to learn from each and every one of you, what can we do better in terms of building the talent ecosystem in Gujarat. Thank you.
Sir, can you stay back for a moment, please? Thank you very much, Mr. Murthy. It was truly inspiring, and I now call upon Mr. Ankur Jain to present the memento to Mr. Murthy. Thank you once again. And now it's time for much anticipated panel discussion on talent, skill, and capacity building, how to ensure an adequate workforce for local units and beyond. This session will address strategies for skill development, industry-academia collaboration, and workforce expansion. Moderating this discussion, we have Dr. Suraj Rengarajan, Managing Director and Head of the Semiconductor Products Group at Applied Materials. A very warm welcome to you, sir.
Thank you. Good afternoon. Okay. Let me do something. Okay, all of you stand up. 5:30. You've been sitting for too long. Stand up. Okay. Pick the most precious thing that you have, wave it in the air. I'm talking about your phone. And phones for some people. Right? Okay. Everyone awake? Okay. Now let me help a little bit more. I'll tell you a joke. What is bigger? Rajnikant or NVIDIA? So people who don't know Rajnikant, please raise your hand. Everyone knows Rajnikant. People who don't know NVIDIA, please raise your hand. You don't know NVIDIA? Okay. So what's the answer? Rajnikant. Why? Because NVIDIA is only a semiconductor company. Can somebody explain? Okay. Rajnikant was a conductor. Okay. Now people are fully awake. Yes? Okay. Wonderful. Okay. I think the lead up to this panel was really great. We had speakers who covered a variety of things which this panel will now cover in more detail. Dinesh talked about how digital tools can be used for scale. We had Maven Silicon, Shivkumar talk about how AI can be used as a design tool, again, for scaling productivity. And we had two real-world use cases. We had both Ranjan Bandapadhyay from Tata and Murthy Murgia from Micron talk about how they are doing and planning to do skilling, scaling for their real-world projects, right? So these are real-world examples of what needs to be done here in Gujarat to make things happen. So I have a panel of people here who we can now deep dive some more on some of the topics, do a little bit more. And the other thing I also want to do is ask the audience some questions on these topics. You've heard 3 or 4 speakers talk about it. What are your views after we talk to the audience? And we'll keep it light, brisk, fast. I know it's late in the evening. No, nothing more than 2 or 3 sentences per person. Just keep it sharp to the point. So give me a 10-minute warning, and we'll try to get some.
For sure.
We'll get some questions and get the audience involved. So I'd like to invite the panelists on board. So first, Dinesh Munireddy, Senior Director, Software Engineering, Lam Research, and he was here earlier, and he gave an excellent talk. Ms. Heinz Henrietta, Head of Recruiting for R&D and SMD, Southeast Asia, Infineon Technologies. Welcome, ma'am. Mr. Anku Jain, MD, MediaTek, India. And finally, the Sari to Silicon fame, Mr. Ashok Kumar Mehta, co-founder and director, Suchi Semicon. So,
We have placed out there, sir. There are 3 of them.
Hello. Yeah.
Hello. Hi, good afternoon. So what I'll do, we will have a quick round of introductions, maybe just a couple of minutes about who you are, what you do, and then we can get started with the panel itself.
Hi, I'm Haynes, and I lead the talent acquisition for Southeast Asia. I'm associated with Infineon, and we have a big R&D center, which is Infineon's largest R&D center, over 2,700 people in Bangalore. And now we're looking to venture into the Ahmedabad market, and we have a new office coming up in the Gift City, and I'm really looking forward to engaging with some talents here. Yeah, that's about me.
Hi, this is Dinesh Munireddy. Actually, my day job, I work as a head of analytics and data sciences at Lam Research. At the same time, I do have a part-time job where I actually head the university engagements for Lam Research India. So I work with a lot of universities in terms of recruiting and various other engagements that we have across the universities. It is in this context I head the project which is skills development using semi-verse solutions, and it is in that context I am here having a conversation with you all.
I hope they pay you twice. Sorry? I hope they pay you for both jobs.
Well, no, as it says. So the reward for good work is more work. That's what I get to hear.
Good afternoon, everyone. My name is Anku Jain. I'm the Managing Director for MediaTek in India. So I've been with MediaTek for the last 20 years. It's been a long journey, and we have gone through ups and downs of talent management. It's a very tricky subject, and it's not easy to, although we are a fabless company, are not very relevant for manufacturing, But I think the challenges would be similar. Once the ecosystem builds up, it can be a bit of tricky to get people and to retain them. So that's always a challenge. But we have been here for 20 years. We are about 1,000 engineers now. A very exciting journey we had so far.
Hi, good evening. Ashok Mehta from Suchi Semicon, and our moderates give our name Saris to Silicon. So everyone knows about our stories. We are from the textile people, and after this COVID, we diversify in the semiconductor chips, assembling, packaging, testing. And this is the first OSAT plant in Gujarat who started in this December 2024. And we are proudly feel today we launch our first chip with our Chief Minister, Shri Bhupendra Bhai Patel. And in April, we are going to commercial productions, and maybe end of April, we are going to ship these chips to US market. Thank you.
Okay, and just to round it off, the compere introduced me. I'm Suraj Rangarajan. I'm part of Applied Materials India. Applied Materials has been in India now for more than 20 years. When I joined, it was about 800 people. Now it's 8,500 people. So we have some idea of scaling and capacity building, capability building. And we do work with a lot of the tier 1 colleges here. We have a close to 20-year relationship with the IIT Bombay, where we have in-house presence, and we've done a lot of groundbreaking work with them. So in this session, we'll talk mostly from a manufacturing perspective, but also just building the industry, right? Whatever challenges there are in building a sustainable semiconductor industry. So the first question I had was numbers. I think Ranjan showed a nice chart with some numbers and all that, and that was for his, I think, Dholera kind of capacity. But what is the size? Because if you read papers and articles, you get numbers anywhere ranging from 100,000 to 500,000 people are required in India and all that. So what's So maybe just take a guess. What is your sense of what does maybe in the next 5 years, 2027, 2028 is a good target. How many semiconductor professionals do we need in India? What is that number? And what is the gap also, if you have that?
I think easily over 6,000 to 7,000.
Okay, 7,000, okay.
I would say, if we have to look at it per fab, it would be easily around 10,000 to 15,000 based on the size of the fab and based on the capacity of wafers that we see. But in order for us to look at it in a wholesome, the numbers may look big, but a fab requires various disciplines and various skills. So if we have to kind of try to break it down and
there is that pyramid
and then look at where the critical skills are needed and how these skills need to be segregated and trained. All the way from IIT levels to PhD plus levels. So that is what my
okay,
take
but so about 15K per fab
per
was
fab
what?
and so on.
Okay.
Yeah, I would say, maybe 100K plus, in this industry. But as you said, I think we have to look at the kind of skills which are required. Although we can say as is a semiconductor skill, but some plants would have maybe a very low skill requirement because all the work is done by the complex machinery around us. And the people just need to probably, press a button and things happen. So it really depends on how does the industry evolve. And some of them could be low skill, some would be definitely PhDs or IITs and so on. But that we have to just still see how it goes. But it will be a challenge because, if you look at the manufacturing fabs, the kind of talent required are not available at the moment. So the companies are trying to get people from other geographies where the talent is already mature. And that is its own challenges. So we'll discuss that later. But I think overall, maybe 100K plus. Yeah.
If I talk about my industry, I required for 5 years more than 3,000 skilled employees. 3,000 in my industries, what I imagine it. And I think within 5 years in India, more than 10 to 15 packaging unit will be start. So according to that, maybe 30 to 40,000 skilled employees required in these industries for the packaging. I'm not talking about the fab.
Okay.
I'm talking about the packaging industries. We required about 15 to 20,000 skilled employees.
Okay. Yeah, I think, and I was in the session where Professor Thumala Rao was giving his introduction. He had similar numbers. He had about 25 to 50. That was his ballpark. So I think we are all converging around that. And in that bottom of the pyramid was the biggest. Out of that 50, about 18, 20K was the technician, hardware, equipment, right? That is the skill set. And then as it goes, operator, tool operator, then device engineer, and then somebody who can do integration and yield, right? It goes up. And that number keeps coming down, right? Fab is not really that. It is more automated. So now in that, which is the biggest area that we have a challenge in this? Now going back, suppose we assume 50,000 ballpark is what the size of the problem is. Which is the biggest challenge that you see for India sustainable industry? Where is our biggest problem?
For me, there is no challenge.
Okay.
No challenge. Because I already planned 2 years back. Next 2 years, what I needed, I already planned. So I don't think about any challenge.
That's very optimistic and very good to know, right? And
if everybody could do that for their industry, then
that would be awesome, actually. But from my, maybe I can just visualize the kind of challenges. One is that I mentioned that a lot of people need to come from other geographies to kind of fill the gaps, talent gaps. And I think if you look at, I was talking in the other, Taiwan roundtable earlier, and the way Taiwan works and the way India works is very, very different. I'm also from, I'm from MediaTek, which is a Taiwanese company. So the way they work and the culture gap is humongous, right? So I think that is one challenge which will be kind of horizontal across all parts of the pyramid. right? If we have people from other geographies, at least for the higher tier talent, we may have to do that, right? So that is one thing we have to address, the culture gaps which are there. And apart from that, I think the challenges will be definitely more in the upper tier, right? Getting the people to know about those technical skills. I think technician level probably will be easier, slightly easier to fill the gaps. Yeah.
So, talking about LAM specifically, we have been here for 25 years and we have known how to manage the skills gaps that we have. But the challenge we are talking about is related to the fabs that are being built. In that space, I think we do have a huge void, and I do sense that we do have that gap in all the tiers, as you were talking, Suraj, earlier.
Yes.
Now, all the way from the low-level technicians who are taking the wafers and managing and coordinating stuff, who have to run the tools, press the buttons, and so on, and all the way to the PhD levels and so on with expertise where they have to ensure that the yield is there and then all the equipment are delivering the products that they are looking for, because pretty soon people will start looking at are we productive, are we making money. So the lower tier skills I think will be easier gap to fix as opposed to the process level integration gaps, which to some extent we are facing that gap in LAM also when we talk about process technology skills and so on, mainly because of the ecosystem infrastructure challenges that we do have. So that is a place I think where we should kind of continue to focus, because that will take time. Both of us being in the same industry, we know even individuals completing their MTechs and PhDs, when they come to our companies, it will take for easily a year or so for them to get the domain expertise. So we'll have to see mechanisms and methods in which we can speed that up, and that is where virtual solutions will play a huge role. That would be my take on this.
Sure.
So ours is an R&D organization, and what we face, if I look at the top part of the pyramid, really the leadership skills, right? We're looking to drive competency centers out of India. And really we see that we don't find people or talents who can drive across regions. That's been a challenge. So putting together a lot of leadership programs, trainings, upskilling people has been on the top part. Now, if I look to the mid-segment, what people do, from an end-to-end work is very limited. So again, we have to go back and look at systems where we could put together functional trainings so that we can, really get people driving and putting together all topics end-to-end. And at the bottom layer of the pyramid, now we see with students coming from universities, there's a huge skill gap. What is taught to them in academics is not what they actually translate doing. So what we're doing is we're trying to put together programs and work together with universities where we could tweak syllabuses. And that way, when students are engaged in the universities, they can actually learn some bit of the work that we do. And we also offer very comprehensive internship programs as well as apprenticeship programs where people can be on the job, learn skills, so that after 1 year we're able to see them as good part of the workforce. So that's how we've been able to drive and work through the different parts of the workforce.
Sure. Hold on to that. We'll come to some of those later. So in my mind, I think all of those are true. But one thing that I think overrides all this, and we talked about this a little bit when we met over lunch, is the mindset. This industry requires a mindset in order to deliver high yield day after day in multiple sites. It requires a mindset for you to be able to do the same thing every day and do it perfectly, right, to perfection, and not accept low yield, not accept variations, not accept excursions. I think that will be the important thing to drill down to everybody, right? The fab only makes money if the yield is high, right? So the next topic is timing, right? We are all here. Many of us were here 2 years ago when there was the first Semicon over here, right? There was a lot of excitement. Micron was announced. Now, a lot of MOUs on the stage today. There is excitement that more things are coming. From a timing of this skilling programs, initiatives, and all that, where are we with that? Are we ahead of time? Are we on time? Are we late? In your sense, given you said there'll be about 10 or 15 such units and all that, are we ready for that from a skilling training perspective? Are we ready for manufacturing that's going to happen in India?
Yes, I think we are on time. When we planned, almost 1.5 years back, we appoint the key persons for the plant. And as of now, today, you've seen the MOUs and all that. So 2 years back, whole world talking about India Semiconductor, they told Indian companies on the PPTs, not on the actual ground. Now, everyone believe in that. Now, India can start. And once the Indian people start, they will not stop. Once we start, we will not stop. So I think we are on time. On time.
Good to hear that.
Yeah, definitely, Rome is not built in a day, right? And the only way to, finish it is to start first, right? And I think, as you said, start has already happened. And with the, if you remember, in September, we had a Semicon event. I think we had met there also. And you could see all the global CEOs under the same roof, which was absolutely amazing, right? So I think the ball has started rolling. And, but of course, there will be challenges, which has to be encountered. So there's no perfect time. Right? We have to start, and that has really happened in a big way. So the timing is right in that way. We have a big push from the government. I think industry, the animal spirits are on to get things done. So I think things are going good.
Okay.
So depending on the kind of industry we are looking at, I think we have a gap. We do have a gap at various levels. At the same time, I also do see that we do have a will.
Okay.
When I say that, in the last 1 year, 1.5 years, I have personally seen how the industries, the academia, and the government come together with a resolve to do the skills development because that need was identified. And we do have several entities trying to pick this up. So that said, we have several ways to close on those gaps as well. So one at lower level, we have started engaging with the universities and the relevant industries to partner with, and government is pulling a lot of legwork to kind of make this happen. Now at the top of the pyramid, we may have to look at experience skill set, which is already there worldwide. There are several companies with major skills. So looking at solutions like expats, having one-to-many trainings that happens at the working level on the day-to-day trainings and so on. So we need to have a combination of these trainings to be done to make sure that we come up to speed. And it will be only a matter of time where we will be able to close that gap because we are actually attacking at all the levels to go ahead and fill them. So that's where I think we do have a will to make that happen.
I would say I would definitely agree with Dinesh. There's definitely a gap which can definitely be fixed. And what I see more is that across the globe, people are recognizing the vast potential that exists here and the huge availability of talents. You name the skill and, we have it here. Of course, there is a little bit of gap, like I mentioned, but they can be easily fixed because of the potential and above all the commitment. And now if I just take the semiconductor companies that I've worked for, most of the product-based companies, we all started out small. But now if you see the R&D centers are built in a big way, and it's obviously because people believe that we have the right set of talent. And if you see now, we are no longer seen as resource centers, but more as competence centers where we can drive activities right from the requirements gathering till the fab and the silicon tape outs, everything can be done out of India. And I see that more and more that, there is a lot of investment that is happening, and it's great to see the government support, not just in terms of funding the organizations, but also the universities who are more flexible lately. And I also see the industry and academia connects, where they're more willing to bridge the gap and make skill more easily available. So definitely this is the right time, and I would believe that down few years, India would have some really exceptional talents. And I'm actually proud that Infineon has its biggest R&D center in India. So we have the biggest center here.
Okay.
That speaks for itself.
Cool. I'm happy to see some sort of alignment. Yes, I think things are coming together. So one concern is if you do it too much ahead of time, then you have people without a job, and then that creates a sort of negative vibe around the industry. Right now, semiconductor is a desirable area to get into, and we should build on that. The other sort of secret weapon in my mind is the diaspora. There are a lot of people with experienced semiconductor talent who are willing to come back and take on leadership roles and do things here, right? And that's something that we should sort of leverage and build around that. So that, to me, whatever gap there is can be addressed using that, right? So many of you talked about the academia and the industry, government, and other organizations, right? So now my open-ended question, do you think they are working in sync today? The government has skilling and training initiatives. There are SKI and other agencies that are driving curriculum, EICT and all that. Then industry, you saw both Micron and Tata are doing their own initiatives to meet their own needs. And academia, many colleges are doing their own coursework, semiconductor coursework and all that. Are these in alignment, or do you see these being sort of separate? Are you seeing them coming together, or are you seeing them working in parallel or as separate entities?
So I certainly see a disconnect today. We do see a need of skills development for semiconductor. At the same time, there are several initiatives in different areas when we talk about universities, when we talk about industries trying to help, when we are talking about government. We don't have a clear framework to go ahead and see, like we were talking about, there are multiple layers and pyramid. Do we have something specifically structured for each of these tiers, and cohesively are we working together? At least to my purview, I haven't seen that happening. But at the same time, if we think about it, do we need that? Or is there an opportunity for us to kind of continue to invest in upskilling? And naturally, I see over next few years, it will boil down to what are actually needed.
The market will...
And the universities themselves will come up to a place where there is this demand. So I think it is a very natural way of how any of the skills that happens. Like when you looked at in 80s, doing a BCom and getting a job at bank would be a good thing to do, and then everybody kind of went into that, and then later part engineers, and now within engineering you have multiple disciplines. As we speak, people are, even parents are falling into a line on, I want my kid to be in computer science, and within that data sciences, AI and ML. So this is something that is a natural phenomena, and I think over time it will kind of settle down to what actually is important. And I think our industry is also going through the same phase.
Okay.
Yeah, I think academia is a long-term thing, right? It'll and it's happening. I mean, there is a disconnect for sure, as you said. The kind of skills required may not be taught, and it is very difficult to influence the the colleges
curriculum
to change. And even if they change, students may not like it or whatever, right? I mean, it's a very long-term, slow process. But I think it should be more of a learning from the industry itself. So, within a company, if a person, if a new startup is happening in India, then maybe a good way to learn would be that some people go to their HQ or maybe the partner company in another country and have 50 people there and learn from there. That's what will teach them not only the hard skills, but also the mindset. As you said, the yield ratios and so on. I think once they see it, they know that work ethic is so important. So I think in the short term, probably it has to be within the industry, learning from within the industry. And people can maybe have expats here, or maybe people can go from here to their the partner company and so on. Academia will take its own time, and it's a very slow process. Yeah, that's my feeling.
As of now, we are already doing MOU with that so many colleges. Even SVNITs, the very good NIT college from Surat, we are doing MOU with there. We started the courses as there. Our team every week went to the college and teach to that student. We are selecting some students. They came to our factory and practically our staff teach them according to that equipments. So one of them and almost 450 college. So we are having the MOU with them also. So I think within 2-3 years, all that good universities, college, they started the course and regularly they touch with us and our technical team, how we can learn to the students, and always our two technical peoples, almost they went to some colleges for teaching the students. That is our strategy. How we can give to the society also, that is our motto. So we send our technical team to the college.
No, I think you've invested a lot and it's paying off for you.
Really great.
Yeah. I think everyone's putting in a lot of efforts, but that real sync is missing, like you said. But this is such a topic that we need to take a very structured approach, right? And what I believe is first is analyzing the needs of your company, right? And then structuring an engagement that is more fruitful and how can you benefit out of it is key. And if I look at some of the companies, right, to name some of them like Texas Instruments or a few others, where 60 to 70% of their population is built with new college graduates. There's very structured program of engaging with universities, right, picking up students right from the very early stages, making sure that they are there in your campus, actually looking through your products and then developing hands-on. Also engaging with the professors, training them as to how it can be taught at the syllabus. Then guest lectures where you are actually talking about the product line, where's the gap, and how you can actually build them through the years. And once they are on board, investing through mentorship programs, through trainings. With all of this, I think it's a doable thing.
Okay. So I'm glad to hear the sentiment. To me, one gap is in order for the industry to be sustaining, you need to also be able to do R&D, right? Can you, once you're set up, can you make the next product? Can you push the next innovation? Is that talent being created or is that being nurtured today? Because that cannot be imported. You can import people who can work on this. You will need to create the next set who will push this forward. So where will that come from?
Actually, India is the hub of talent. India is the hub of talent. And our company already appoint almost 8 to 10 engineers in the senior levels for the R&D sectors. So there is, in this industry or any industry, we need the R&D. And we already started in our company.
So I think this is kind of related to the startup ecosystem also, right?
Yes,
I mean, how
startup,
So I feel, in India, we are the third largest startup, world, number of startups in the world, and 114 unicorns or something, right? So that, I think the animal spirits for startups.
So, and also in the design, mostly it's been captive.
Right.
Is there product type companies in design, right? And they are starting right now.
They're starting out, right?
Yes.
So I think definitely because of the, I think over the last 15, 20 years, my take is that the VC ecosystem also has evolved. 20 years ago, there was no VCs, venture capitalists. So even that funding ecosystem has evolved. And therefore, and also the new generation is ready to take more risk. So I think this is a good combination for new startups to happen, and that's what's happening. So also in this field, I think such things will help to create more such opportunities. So innovation, of course, is required, but I think risk-taking capacity and be able to latch onto it, that is also kind of happening. So I'm very confident it will happen over time, that we'll have more and more innovation and companies starting up from here.
Sure.
So the biggest challenge that we see, and we keep talking to universities about this, is when we hire students, we do see a gap in terms of what we notice is the students are very strong in theory. But when it comes to
no industry relevant,
when it comes to making things, getting their hands dirty, there is a gap. And I am pleased to see that that is kind of turning leaf right now, where we do see the latest graduates who are coming out of the universities are actually willing to get their hand dirty. And this is actually happening across tier 1, tier 2, and tier 3 universities as well. So I think that needs to be emphasized more if we have to be innovative, if we want to really get to a space where we develop products and develop solutions as opposed to. So far we have been very strong in delivering solutions and services. But product development is an area where we still have a huge opportunity to go ahead and improve. And I think that revolution has started. I can certainly see that.
Yeah, I agree to all of them. What I also see is these days students are very bright, right? When you throw out problem statements, there are a lot of innovative solutions that come. And with mentorship, and I see a lot of returning Indians, so pairing these folks with these senior talents would definitely help. And I see that there is a moving trend towards the positivity where we could tape out products. So definitely agree to this.
Okay, now coming to the another aspect of this, right? All this skilling, training, and teaching, curriculum, all that is good, but till people do something hands-on, everything is theory, right? It's in the mind, it's learning. So how do we give people more hands-on time, right? So I'll use applied materials as an example. In the 20 years that we were here, most of the people never saw equipment. Everybody worked on a computer, on a model. The output was a design which went to a supplier. Supplier made the part. It went into the equipment. The engineer never saw it. If it worked or didn't work, they didn't know. No feedback, right? And they continue doing design on their computer, right? So recently we've set up labs. Now we have about 16 bays. We have tools. So if an engineer makes a part, that they get a part, they put it in the system, only if it works, they send it, right? So we need people to get more hands-on to show that they can be more productive, right? That is the value. Unfortunately, semiconductor, it's not so easy, right? It's a high capex and high value add. You don't want to put that much in front of people to learn. How do we fix this? How do we get people more hands-on today so that they are more productive and they ramp faster?
So I will have to resort to virtual solutions here. The reason is, actually you were bang on when you said it is highly capital intensive, and investing in so much will happen only when you have the volume to consume. I think Lam had a similar journey as what Applied has, where we had to set up the fab specifically to cater to the product development needs. Now, thankfully, these days we do have solutions in terms of virtual reality and augmented reality, and we should certainly go leverage those solutions in addition to the virtual twins I was talking about. It has to be a combination of everything, and which will only help us minimize the amount of time individuals will have to spend on the actual equipment. When we talk about 15 years ago, we didn't even have any of this virtual environment where people can at least get a feel for what is happening. So I think we should certainly invest more in these virtual solutions, which will help. That would be my take on it.
Sure.
Actually, I don't have too much comment, but I think AR, VR definitely is a good way to go. And I mean, there is no shortcut to this. It takes time, and people, being away from the equipment, it's not easy to visualize. That's true. And I think it just takes time. Maybe they have to travel to the places where they have the equipment. And that's the only way I can see. Yeah.
Yeah, I agree to what you mentioned, right? The only way is to have short-term assignments, long-term assignments where people can actually go to the fabs or to the place where they could, actually see what work they have done, how does it translate. Of course, now we've also set up, most of the companies have these silicon labs where they could actually see the silicon translating the designs, which they do, translating into silicon. And that gives a lot of motivation for engineers especially, is what I can say.
But for us, we already purchased the equipment, set up all the equipments in our factory. So we are giving the training on our own equipments. So that is the biggest plus point for us. Yeah.
How much time do we have?
We have finished with the time. It gets
Okay.
6.
Can we ask a couple of questions?
Okay, if the crowd has any. Then.
Okay. I can always count on people to ask questions.
Yes, sir. So we can pass the microphone. He can use mine. Reshma, can you please pass on the mic?
Thank you, panel. It was really on the bang on the problem. Basically, I'm Pinakin Thakur, and I work for R&D more than 38 years in ISRO. And now I have my own company. So my problem and question is, it's a chicken egg problem. You need a product, you need to train the person. If you are training the person, they don't get job. And we don't know what to produce.
Yes.
So who will fill this gap? Whether IESA, government, or who will do this? Giving the direction.
I
think it'll be mostly the market forces will take care of this. And, people are finding ways to learn, and as
so
we discussed
can
earlier.
bridge using internship, apprenticeship,
Yeah.
things like that. We can do stopgap, but finally, industry there needs to be a
that's
job
what.
at the end of the road.
Industry has to have that
At
one.
the end of the road, if there's no job,
Otherwise, this
then
whole
it'll stop.
drive, I think.
Correct. 100%.
within-
100%.
Please.
But
Thank you.
once we have success stories like
Yes,
him,
yes.
that will really give motivation to a lot of people.
Yeah, we need, instead of 10, we need
Maybe
20
10 like
more
this, yeah.
companies, right? Yeah.
So I think something ground level it should happen, this kind of programs.
Sure.
Okay, thank you.
There's one more behind you.
Go on the back, please.
Yeah, hello panel. It was a very productive session, and I'm an MTech student from IIT Kanpur and an incoming recruit at Applied Materials. Hi, sir. Hi. So I just wanted to, there was a discussion on the bridging the gap from academia to industry, and that engineers are not too into making their hands dirty. So can you just elaborate on what exactly is the gap when engineers come from academia to industry, specifically the semiconductor industry?
Yeah, so two things. One is a lot of the knowledge is bookish, and a lot of it is N+2. Graphene, 2D materials, things like that, which for the industry today is not a topic. Industry today wants somebody who can come and do stuff that is in flight, right? That is, I'm working on that, help me with this, right? academia, for good reason, academia works at least 2 generations away. And I think the point there was, at the foundational level, we need to figure out where the gap is. Academia should always work long range, but the hands-on, how does a vacuum pump work and how does a cryo pump work and how does a diffusion pump work is independent of node. That they should know.
Yeah, and to add to that, I think a very good start. And to add to that, one of the things we were discussing is, in semiconductor industry, you need systems knowledge. It is not like if I am siloed in one specific area and I know this. Getting deeper, but how it will impact. When you're doing a mechanical design, what kind of electrical consideration need to happen, how this will be programmed. So to have all those things, when people start working on it, they will certainly get a solution to it. So last year we conducted a systems engineering challenge. That was the first of a kind. And through that, when it was very pleasing to see students come and start trying to solve a simple problem according to the semiconductor standards. It was, their task was to build a robot that functions, where we gave all the parts. And we said, you go ahead and design how to pick a disk and place to a specific place. So they quickly went on trying to build that, as opposed to taking a step back, doing a design, and then look at what solution will help and then move forward. But they were very curious in going ahead and building that, make it fail, and then try to make it work. So there are these simple nuances that actually need to be filled in when individuals need to be industry ready.
Right.
So I think the universities are also forthcoming. They're working to understand this, and that's why I said it is improving and the will is there.
Thank you.
I can add more from the HR perspective, right? So when we have started hiring through hackathons, and we feel that people who hack into problem statements are better off on the job. So here, when we see when we put out the problem statements, people are struggling. We have to keep directing them, hey, take this approach. And at the end of every hackathon, I can tell you, there are very few people who actually drive and complete the solution, right? So it is mostly, we are hiring on the basis of the approach. And one more thing that I've also seen over the years is, again, don't take me otherwise, but I've also seen that people very high on academics are not necessarily the ones who are doing great on the job. We've also seen people with 7, 8 CGPA doing exceptionally well on the job. So really, it's the passion for technology, I would say, and those that do more hands-on work are the ones who thrive the best. That's my opinion.
Okay, thanks a lot. Thanks to the panelists, thanks to the audience. It's past 6 in the evening, and thanks for being with us. So I will give everybody on the panel one sentence to capture where we are today with respect to skilling and training and capacity building for the semiconductor industry, and what you and your company can do about it. So one sentence, short sentence.
I think, overall we are in a very good right direction. I mean, it has to start, and it has started. And it's a multi-decade journey.
Sure.
Right? I think even if you see other countries like Taiwan and so on, I think they took 30 years.
Correct.
We just started, right? So it'll take many, many decades. But it's a very good direction. I think we are on an expedited path. And yeah, I feel very optimistic.
Sure.
Yeah.
I have already talked about what LAM is doing towards skills development, but there is one thing I want to tell everyone. Semiconductor industry is totally unique, something that not many people are into. So if there is one word, if people want to carry away, it would be perseverance. If we think about, let us say there is this course that came, we all learned, and I expect the job, maybe you will fail, but overall, being 26th year in this industry, I know that this is a place to be. Please be persevere, learn more. And even after you get into the industry, after you learn, every year the node keeps shrinking. And then there is no time even to look at the success, because there is something else that is already there. So perseverance is something that is required in this industry when you are learning, after you learned, when you are working, and when you retire also.
Like he said, this industry has really caught up, and when I just take for Infineon example, right? We started out as a very, very small team, and today we are over 2,700 people. We have a gamut of all the activities on the hardware side, on the software side, on the system side, on the application engineering side. So we are really committed to grow, and now with our expansion into the Ahmedabad office, we're really looking to hire more and more research and development engineers, and we are very committed to making this a real success.
Actually, we are very new in this industry. All the experienced people are here. I always came here for learn something for my industry. And today also, I learn a lot from the panelists, from that keynote speakers and all that. And I'm trying to success in this business. Thank you.
Thanks. So for me, the word on this is passion. I think everyone involved in this is passionate to make this work. Everyone keeps saying that India missed the semiconductor bus now 4 or 5 times. This time we will catch the bus. So with that, thanks a lot. Thanks for being part of the audience, panel, and I hope you had a good day today, and see you here tomorrow.
Thank you very much, sir. And we would now call upon Rajiv Khushru, Director, Texas Institute, to kindly present the mementos to the panelist and the moderator. We are few, but we can clap more so that we can make more sound. So thank you, ladies and gentlemen. This is Dhwani signing off for the day, and we will see you tomorrow morning with bright smile and lovely heart. Thank you. Bye-bye.